implementing while loops. So
That's right.
that's going to be interesting.
That's right. Welcome everybody. The stream is officially live. I checked it on Twitch. I actually see it now. So that's good. I gotta make my Discord announcement. Is this gonna be okay? Did it break things? Can you still hear me? Okay.
I can still hear you. Can you still hear
We're good.
me?
I can. We're good.
Okay, that's good.
Okay, we're live with I'm gonna at you at eternal. Oh god. How do I do this?
Hold
Okay.
on, you can just copy paste that, I suppose, or I can.
Okay, I did it. I typed A and it happened. It's
Oh,
smart enough.
it's clever enough to figure that out, I
Yeah,
suppose. Yeah.
I type AE. It's like, oh,
Yes.
thanks
I
Discord.
don't have that problem because I have it on my keyboard.
That's right. On layer 7, key 32.
It's actually just layer 3, like
Oh, that's not
Alt
bad.
Graph plus A, because I use it so commonly. Because I think you know why.
Oh, I just linked Twitch. How do I do this?
Oh
This
dear.
one, please. There we go.
Yeah.
That should be better.
It's actually clever enough to change the embed.
Okay.
Interesting.
Oh god. Oh, this is recursive. Hey, look, recursion.
Oh dear. Oh no.
Okay, move this. Wait, back over here.
Oh god.
How do I make this full screen again? What have I done? Okay, I double
Yeah.
clicked it. Okay, what do we do? Ruark says, oh no. That's
dear.
correct. Okay, I don't even remember where I'm going. I'm going to the compiler. That's right, I'm not going to the compiler. Ruark says C compiler now, Kappa Pride. It's written in C. It's written in C.
Well, it's
How do I do this? Oh god. We should just make C one of the input languages.
oh god. Have fun passing C declarations.
That's right. Okay,
And
how do I...
writing a free processor.
We'll just call... we'll use system and just call the preprocessor in
Oh, God.
GCC.
Oh yeah, just call like clang and dump LVMI and pass that. That's gonna be easy, honestly.
There you go. Yeah. That would be easier. We fixed this. I have to refresh this.
Yeah.
Okay.
There we go.
We did it. Okay, so for those that don't know, there's another hefty PR from the man himself, Suraid. Is that how I say this, by the way? Do I just always say it wrong?
Well, if it's Old Irish, so the answer is yes.
Okay, that's fair. It's actually...
It's just the Old Irish word for eternal. So
That's
usually
right.
people call it that.
Okay, I'll go with eternal. I'll try and do that from now on. It's hard when I read Suraid. I have to... my mental switch. Anyways, there's an IR parser now. And of course, backend optimizations.
Sure is. Backend optimizations. What did it even do? I forgot.
The stack frame full minimal
like,
thing.
Yeah. The stack frame thing, and also like we actually support Linux now because earlier we just hit some panics if you tried to compile on Linux.
Oh really?
Yep. Because we hadn't implemented CodeGen context creation on Linux yet, and stuff like that.
I see. That's probably the same now. On MS1 and Linux.
I think there's some code duplication there because I didn't really bother coming up with a clever solution, but
that is fine.
It's mostly the same.
There's a lot of unused code in the backend right now.
Free Linux literally calls CodeGen context free MSVC or MSWin. So
they may or may not be the same.
Yeah.
It's fine. Oh, I like the force push. That's a great way to end off a PR.
Yeah,
I feel like it really...
That's because I forgot to... You know how you can reference an issue in the commit message GitHub will close? I forgot to do that at first, so that's why.
That's right.
To amend the commit and then fix that.
Nice. That way it'll close when we merge this, right?
It should, yeah.
That's insanity. GitHub is so complicated. Alrighty, well, let's take a look at files changed as we do. We're gonna look over it. 2 new files seems reasonable. We have an entire BBNF grammar for the IR,
That's right.
which is incredible because we don't even have one of these for the language itself yet. We sort of do, but because I asked for it
Sort
For,
of. wrote one.
for something we're going to talk about later. Syntax highlighting.
Oh yeah, that's right.
Yes, beautiful syntax highlighting. Anyway, there's an entire eBNF, which if you are if you can read this, that's incredible. I can get through it, but the pattern matching loses me when we start to get like, okay, there's an
Oh.
optional repeat with itself
Yeah.
in it.
It's a matter of practice, I suppose. I couldn't read this either to begin with, at least at first. So
That's fair. You
it's
heard it
easy
from
enough.
Saraid. Practice. You'll get good at grammars, and it's worth
Get
it
used to
because
syntax.
yeah, it's much better when you have something formally defined to actually write a parser for it.
I used to just
beautiful.
write passes without grammars, and I always make mistakes or not be sure what I was like, what state the passer was in. But nowadays it's easy because I just write the grammar, and then I basically more or less write a function for each rule in the grammar.
That's
Not
impressive.
always exactly, but more or less.
It'll
And
always work like that.
And that's usually why, and that's also what I did here, is I put the basically fragment of the grammar that a function passes as a comment above the function, and you'll see that in the actual code.
In the large diff.
Yeah.
Yeah. We have diagnostics first.
Oh
Very
god.
cool. I'll get there. I'm gonna find it.
You just need to scroll down for a bit because then there's the Lexa.
That's right. This is all Lex thing.
Yeah, and then there we go.
Nice. There's the
that's
parser. We're getting there. Resolver. Here's the macros.
the macros.
Here it is.
There we go.
We
That's
did
what I mean. Horribly misaligned, but you get the gist.
On line 666.
Look at that alignment.
I don't know what GitHub is doing.
Actually, the alignment, the thing is, in the grammar, you know how the annoying thing is that the names of some rules are longer? So you have to kind of
Yeah.
align them. And then when you copy them into the code and the rules are on their own, the alignment is completely off. I don't know, I always
true.
forget to delete the extra, padding.
White
So that's
space
why you
kills
have
us
this
all.
huge huge block of space just in the middle, and just sitting around there doing nothing.
Yes.
I always do that.
Okay. Up next, we have the Un IR mode, which is just beautiful, and Emacs mode for the IR, which I
That
love.
is scuffed Emacs mode, but yes.
Yeah, it's very minimal. There's no syntax table, which is worrying.
I didn't bother with that.
That's fair.
too much
It's
work.
it's so
I
much
always-
work.
I honestly always just do this. Syntax highlighting is all I need.
Well, in that case, what we talk about later, Tree Sitter you're gonna like it a lot.
And also the thing is, you're not going to be writing IR by hand too much. This is just for reading IR files.
Don't tell me what to do. No,
You
you're-
can if you want to. I just don't recommend it.
It's true. It's true, but this would probably get us through 99% of our use
Hopefully,
cases.
you can always extend it. Like,
I'm gonna
whenever
write
we
it.
add more instructions, we just need to add them there in that huge or.
I'm gonna write a Tree Sitter parser for the IR.
I suppose you can. There's the grammar right up there, and this grammar isn't even recursive, because I was gonna write a recursive descent parser, but it's not actually recursive.
That's awesome. We don't even need recursion.
It isn't. Functions contain blocks, blocks contain instructions, instructions contain certainly not other instructions, so there is no recursion there.
That's true. That's incredible.
It's just a, I don't know, descent parser, I suppose.
So we have a new
Top-down.
our descent parser.
There's no recursion.
Sounds like a spiral descent.
Oh god. So it
It's
should be
going
fairly
down.
easy to write a grammar for this.
It definitely should. It shouldn't have too many conflicts. It's pretty I mean, yeah, we can even match new lines with regex, so we should be good.
Oh, that's good. Yeah, I decided not to allow 2 instructions in a single line because that might be confusing.
Nah, we should just have everything able to be written as one line.
Oh god.
Shout out to Python. Okay, we have some example IR, which, if I must say, looks beautiful.
The compiler now recognizes .ir files as IR.
Nice, nice. So you don't even have to pass in a flag; it just does it.
No, we can add one at some point, like GCC's -x flag or something.
Nice. We could even have it -x for compatibility. Ooh,
Sure.
we could have whole. Okay, this is cursed. We could have whole compatibility, like translations for command line arguments. So have like.
Oh,
So we could have like conditional compilation to compile with GCC compatible command line arguments. And then like MSVC compatible command line arguments if we really
no.
want to die.
Not MSVC compatible. No.
Does anybody even use?
Fun fact regarding MSVC compatible command line options, that doesn't sound that bad until you realize that they start with a slash. What else starts with a slash on Linux? Absolute paths.
Oh no.
That's why you don't do that. Actually, and if I don't know if you've heard of CPP front or CPP2, there's this like Herb Sutter, who is pretty famous in the C++ world, who is writing basically something that compiles to C++. It's like this entire thing. There's a CPPCon talk about it. And in his code, he wanted to support both Windows style and Unix style command line options. And there's a comment there that says that when using Windows style command line options, he allows unknown command line arguments because he couldn't figure out how to get the thing to realize that something that starts with a slash might also be an absolute path and not an option. So this is a problem that there is no good solution to, I think.
That's a good
why
point.
you don't have command line options that start with a slash on Linux, because that's something else.
That's really interesting. I never thought about that. That's like one of the major distinctions is that Windows has its drive letter system that prepends
Yep.
every absolute path. So it's like, oh,
mean, And even if it uses backslashes too, because on Windows there's like some really cursed way to just you can start what's it like? I think if you put 2 backslashes and a question mark or something at the beginning, that's an actual absolute path because drives are not actually the absolute. It's cursed. If you look at how Windows works internally,
is that really possible?
All we know about that, but
Oh no.
like there's another even more absolute type of path even in Windows.
I didn't that nobody even knows about. I don't know
Yeah,
about it, and I
no
program
one
on
is-
Windows. It
So
looks
yeah,
like
that's what we're talking about here.
yes.
Also, these are static asserts now.
That's right. That's right. So instead of runtime, they can run during compile time and save the
Yeah.
user time, which is always important. And they mean that it can't fail at runtime, which is probably a better reason to have them be static.
In general, if you can make it a static assert, you should. You probably should.
That's true. We can now handle Linux instead of just running into a panic, which is probably better, arguably. And we now have this new format for
That's
IR
right.
format, because not only do we parse IR, we also output IR. There's a backend that that outputs the IR that can be parsed, right?
Yes.
It's kind of
Well,
like the
it outputs IR. You can just compile a normal file and output IR. Oh yeah, that can be parsed in the sense of that you can pass the output. Yeah.
yeah, it's like
You
a
can then
reference
compile
implementation.
a regular file to IR and then pass that IR file and emit it as assembly.
Incredible. That's kind of mind blowing. So yeah, cool. It'd be like, I guess GCC takes object files, so it is exactly like
And
GCC.
Clang takes LLVMIR files, so
That's right. It's probably more
And-
like to that.
yeah, and also if you look at how link time optimization works, it's basically just compilers emitting their intermediate representations into the object file. Like GCC just writes Gimple into the object file, and in case of Clang, it's LLVMIR. That's how link time optimization works. It's actually all like merge together at link time because the linker then actually invokes the compiler.
So the linker will like do the register allocation and that stuff.
No, the linker just calls into the compiler. The linker
Okay,
invokes the
and it
compiler.
feeds the
The
IR
unregistered
into the
link is
compiler.
compiled, yeah. And the
Okay.
compiler uses the IR in the object files. It combines all of them into a blob and then compiles that as one huge thing. It's as though you had basically
Okay.
merged
Yeah.
everything into one translation unit.
Incredible. That
That's
doesn't
also why
sound that hard.
incremental compilation doesn't work with link-term optimization. Meaning if you change one file, you have to recompile everything effectively.
I see, because it all becomes one big
Yes.
file. Very cool. I think we could do that.
No god.
I know. The future is bright and also dark.
Oh
Just
yeah,
scroll
I've
into it here.
removed every last way of creating a function except for IR function or something like that to make
That's a-
sure that we
yeah.
don't create a function that's not actually inserted anywhere. But that's not in here, that's in intermediate representation.c.
That's a very good idea. Because it's like when we were creating instructions manually without using the
Yeah.
the functions. It's like, oh, then everything goes out the window. It
Yeah.
gets real tough. But yeah, that's absolutely the way to go. So we now just open a little scope here to do parameter counting and creating a
Yeah,
function.
because shadowing.
I see.
Mm-hmm.
Shadowing is coming from like Lisp, it's like, how do you get away without shadowing? It's so confusing.
Yeah, but shadowing has caused me a lot of problems in the past with, especially in C++, because in C++ it's especially nasty if you name the parameter of a constructor the same as a field, and then in the constructor body the name of the field refers to the parameter, not to the actual field.
Oh God.
If you move the parameter into the
Yeah.
field and try to access it in the constructor, bad things happen. So that's why I don't do that anymore.
That's incredible.
I
Yeah,
always prepend an underscore to the parameters.
that's right. I usually just use like the first letter. Like
Oh yeah, that also works. I
if the
suppose.
member is parameter, then the parameter would be P.
I usually shorten it, so I'd call it param or something.
That's probably smarter and more readable. Again, Lisp and the single letter variable names may have something to do with it.
See how it is.
What is this number? What did we gain?
This is the parameter count. You now need
nice.
to pass that in.
I didn't
Because
notice.
yeah, because it needs to know how many parameters there are. Eventually, this should be
Yeah.
the actual function signature, obviously. Once we have a type system that's, I don't know, we have a type system, but I'm not sure how to integrate it into the IR or something. Because
Yeah.
eventually we'll also have to include types in the IR. Because loading an 8-bit value is a bit different from loading an 8-byte value is loading a bit different from loading a 1-byte value, so...
Yeah, I ran into that when doing the assembler. I did a little side project, wrote a little x86-64 assembler that handled like move, sub, add, and it.
Oh yeah, I saw that.
Oh man, you really got to know the size of the operands. It's rough. It's like
Yeah.
completely different in opcodes, which I didn't know.
Yeah.
It makes sense. I just figured that the assembly directly mapped to opcodes.
Yeah, not quite.
Yeah, there's like
move is like 100 different opcodes or whatever.
yeah. It's scary.
Yeah.
But I think we could write an assembler in like 3 days that handles all of the instructions we use from here.
We're not using that many instructions to begin with, so that's that. But if we do that, we'd definitely probably have some sort of low-level IR, and then we could actually do proper instruction selection.
That's true. That's true.
Oh yeah, this now handles the languages.
So I have a
And
question.
currently, I just exit with 2 if IR parsing fails, because what the hell am I supposed to do then? Like,
Exactly. That's exactly what we do in main.c with the parsing of the regular language, right?
I see.
We just exit with 1, and then if type checking fails, we exit with 2, and if like Code gen fails, we exit with 3. I think that's literally
Okay.
how it works.
Okay.
It's just it's numbers I made up while writing main.c. Although that didn't work.
I
Okay,
see.
don't
I
do that.
typically just exit with 1. I don't know why I did 2 there. Maybe just that way I know that if it's 2, it's IR passing, probably. I don't know.
Exactly.
Like, usually when I'm debugging, if you ever see exit code 42, that's probably because I left the debug exit somewhere.
I do that all the time. A
Mm.
printf exit 42. You're like, if it
Yeah.
gets to here, I'll see this message, I'll see the
Yeah.
data, and then it'll close and it'll be fine. Just stop segfaulting, please. Okay, so I have a question. Why do we parse IR here instead of in main when we parse the other stuff?
That's a good question. We need a codegen context to pass it. Because it generates.
Context here is a codegen context.
Yes.
I missed
because
that
it
in the 9
way
parameters.
it passes it, it just generates the functions and blocks and everything directly while it's passing it.
That's right. Okay, I see. So we need a... Okay, yeah. So we'd have to like restructure...
Yes. We could just make some
That's a
global
good idea.
context thing that has the codegen context and the passing context and stuff like that.
That's a
And just
great
pass
idea.
that around. That's what LLVM does. LLVM just has the context. Oh, sorry, the LLVM context.
Yeah,
I think it's called.
we'll just call it context.
Yeah. But the thing is, LLVM calls it, so it's LLVM : LLVM context.
They really like the name.
Yeah, at least I'm pretty sure it's LLVM context. Yeah, it is.
Oh
Because
god.
of course. But yeah, that stores all the state, and then that could also like store the strings that we dynamically allocate or stuff like that. That way we could actually like free them.
What, you want memory safety? This is C, bud.
Oh,
We
God.
yeet the memory, we just leak it. Who cares?
Thing is that I changed it to what function names, and now char point isn't always like stir duped and freed. Because they sometimes, when the IR parser generates functions, the names are fragments of the IR code, basically because there is just string views, and I didn't want to rely on or hold on to those for too long, so you can actually free the IR code once you're done parsing. At least that's the idea. You should be able. I'm not sure if that works right now, but you should be able to do that at some point. So I'm just stir duping everything.
Stirdup is the legend.
Like, yeah. Though in this case, it didn't work, as you saw. So we had to use
Strandup.
dupe, and that doesn't. It's not a thing on Windows apparently. So yeah, I've changed the name of this flag for reasons.
Is it because it says dumper?
Possibly.
Possibly.
Also, Codegen now takes like 7 parameters or something because.
It's just a few.
Yeah.
Yeah, 7, 8, 9. 9 isn't bad. 9 parameters. Only
Yeah,
5 of them
takes
are
a
on the
node
stack.
and an IR string. One of those is always empty or null because we also have string now, which is basically just a pointer and the size.
That's the type of string I like. I can understand that type of string.
Because I hate calling string length. I don't like it. I don't like of and access to the string length. I usually cache it because that's more convenient.
I agree.
That's also why I always use memcopy. I never use string copy. I know the length of the string, so I always use memcopy plus the length.
That's a good idea. It's at least, it shows that you have the correct data. But if you have the wrong data, it's going to go really badly.
Yeah, if you have the wrong data, then bad things are going to happen anyway.
That's true even with string copy. If there's no null terminator, you are
I called
screwed.
it lang fun for now because I didn't know what else to call it.
That's perfect. I think it'll be easy to search and replace in any case. It could be lang vomit for now.
Oh dear.
Just lang and then vomit emoji.
Yeah, because that might honestly be a legal identifier. It is in C++, I think.
Yeah, it should be in C.
Might be in C.
We might have to use Clang for that. I don't know if GCC is down with emojis.
I've never tried using emojis in C, candidly, so I don't know.
I have not either. I saw like a post on it years ago, I'm pretty sure at this point.
I know you can do it in C++. That's all I know.
Nice.
So we have this now because users are just too annoying.
That's a
Like,
yeah, that's a very good idea. It turns out this is often a problem.
yes, yes.
So having a way to debug it specifically is probably a genius move. 200 IQ.
I've changed the syntax of that to more or less match the new syntax of the IR. That's like we have
Nice,
two
nice.
ways of printing IR. This is like the debug output, which also prints the registers, and then there's
Yes.
like the actual IR, which you can pass.
Okay, okay. So this is like what you would print to standard error, standard out to show to like the terminal and be like, hey, this is what the IR looks like.
Yes.
But this is not what would be like, this is not the back end or the parser or
No.
anything.
Yeah.
Okay.
Exactly.
That makes sense. That makes a lot of sense. And there's just small
Call
changes
it
like return to
annotated
red.
IR or something, I suppose.
Yeah, it's fine. We'll it's kind of a small detail. Nobody needs to know about it. Like, it's slightly different. Don't try and copy paste, debug out like an error
Yeah,
message
don't do
and
that.
try and use that.
Yeah, we'll stream at you and give you a diagnostic, so you'll know at that point.
That's
IR
true.
phi arguments are now pointers because reasons.
I saw that
Horrible reasons.
for horrible reasons. Yeah.
Yes, for horrible reasons, because we actually need to hold on to the pointers to them because we need to update them later, and we can't do that if it's a vector, because if it's just a vector of phi arguments, if you reallocate that, the pointers get invalidated, so you have to store them on the heap.
Interesting. That makes a lot of sense. It's kind of like
The
a
classic problem
linked
with
list.
vectors. You cannot store pointers to the elements.
I don't tell me what to do.
I mean,
No,
you're
you're
free
right.
to
It
do
just
it if you want segfault.
it just yeah, I don't want them, but I do get them a lot, so it makes sense. More debug uses, which looks great.
That prints the users actually in the debug IR output, and if you can see, it seeks to column 60 in the terminal.
Oh, yes. Amazing escape codes. I just figured it was a color, but you're right, it doesn't get reset to seek. Also, the G should have tipped me off instead of M.
Mm-hmm.
I'll get there.
And
I'll
also
get there.
60 is like what is not a built-in color because those are 30 and 40. I don't
It's
think
true.
60 is a valid color.
Yeah, I don't know what 60 would do.
It's probably something else. I don't know. For all I know, it like rotates the text or something because there's escape codes for blinking and everything. Like,
Yeah, we use those in Lenser OS.
I saw it. Yeah.
When I saw that, it blew my mind. I was like, you can have text blink,
Terminals can do that. Yeah.
and then I realized it's at the same rate as the cursor, and it started to make sense.
Ah, that makes sense. Actually, never thought about that.
I was like, well, they implemented it for the cursor, so they implemented
This
it.
is basically for set IDs, but just for a single function. They now reset, to one in each function, and we don't
Lua.
use zero because if we ever see a zero, we know it's an error.
Nice.
That
It's a
way.
Lua moment. It's a one-based indexing. I like it.
Yeah, because if you have an instruction that's just not allocated an ID, then it's going to be zero because we calloc everything.
Ah, that's
That way,
true.
whenever you see a zero anywhere as a basic block number, I mean, the block numbers, do they start at, they might start at zero, I don't remember. But if you see that in like an instruction number, you know, okay, we're probably referencing a removed instruction or something like that.
That's true. That's good to have checks like that built in, so that we know when things go wrong. I totally forgot what I was just gonna say. Block ID starts at 1, Lua moment. Anyway.
That's good. Yeah.
Oh, yeah.
Was the one.
Yeah. So, Lenser OS
instruction
extension.
You can see starts at parameter size because the way we do parameters now, that has also changed, is when you create a function, you pass in the number of parameters and it appends that many parameter reference instructions to the entry block of the function.
Which totally
So
makes
that's what
sense.
that is. And those instructions are not emitted into the IR or included from the IR because they're handled as like part of the syntax. So you
Okay,
don't actually have a parameter reference instruction in the IR, in like the written IR, only internally.
which makes a lot of sense. It'd be really annoying to have to parameter reference
Exactly, and that's
in the
also
written
why we
IR.
changed that to what parameter references actually reference the value, not the variable that gets allocated for the value. That's a separate thing that the front end has to do manually now, and it does.
That's I think that's totally sensible, especially with the IR parser now. We're gonna have we're gonna do advent of code in the IR. We have 5
In the
days.
IR, not even in the language itself, just in the IR.
Yeah.
I mean,
So
honestly, the
good.
IR is more flexible than the language right now. You can do while loops in the IR just fine. I'm just saying.
Hint hint. It's true.
You can also do direct calls, which you can't in the actual language. You can optimize indirect calls to direct calls because, fortunately, that the way we implement indirect calls is it's so scuffed that it works. Like it's so scuffed that it can actually be optimized away because it's a global variable that's stored into once, and it can
That's
optimize that
perfect.
away.
I still think it's incredible how many optimizations we have already. It's a little scary. It gets better than this.
It does.
That's incredible. So this stuff is the new phi stuff with pointers, I'm presuming.
That's phi add. What's that for? Phi add argument. I don't. Oh, that's if you want to like. What's that for actually?
Stream
Oh,
mark used.
that's
So we okay,
just.
yeah.
Oh, that's just to add to the arguments of the phi and market is used, I suppose, because I didn't want to add it manually because I might forgot like the usage thing. So that's that. That's why that's there.
This does the new fancy
Yeah.
parameters.
Uh, don't
Don't touch it.
use this. This is used by the IR parser because
Okay.
it doesn't know how many parameters a function has to begin with when it creates one because it doesn't see
Ah,
it typing it.
that's right.
So that's used by the IR parser. Don't use it in the front end. It should just use IR. It doesn't need to use it at all. It just needs to pass in the number of parameters, and that's it.
Just a big don't use it label all over it. It's
Yeah,
crossed out. Stay
just
away.
like underscore internal underscore don't use or something like that. There's like, have you seen the? I don't program in React, but there's like this underscore secret internals don't touch or you'll be fired variable. It's literally called that in all caps with a leading underscore.
That's so awesome. We should definitely have that defined in the language, like in every program. If you have the aluminium flag,
Of course.
we're gonna have the aluminium flag just trigger a bunch of bunch of
Yeah.
trolls. It's gonna open what it opens. It's gonna just gonna let people figure that one out on their own.
Yeah.
It's so much fun. I still love that that's built in.
Function create is gone now. This is just IR function now.
That's right, the one way to create functions, which is GigaBrain. So that, because this is a lot that we'd have to remember if we tried to create a function ourselves. Oh God,
Precisely.
I don't even want to think about it. Param should be size t.
Yeah.
Yeah, that makes sense. So casting, because W conversion, it's good. It's good. We're doing a lot. I'm gonna speed through the rest of this. IR is value. That basically if it returns something or not,
Yes.
because return doesn't actually return a value. It just
So,
uses
yeah.
a value that returns something. Okay. Print defun. Is this debug output or actually?
This is for both. That's why it's here. This is
Okay.
used by both. Like the function signature is printed the same way in both
Nice.
representations. That's why it's here.
Ooh. Huh.
That's just there for that doesn't do
Future
anything.
reasons. Yes. Same with this. Unless we're inlining functions now.
Not yet.
Not yet. That's an amazing answer. If you asked me a month ago, are you ever going to inline functions? I'd say, are you insane? What am I, a chemist?
Oh, the instruction types are like a macro instead of an enum because we
Is that
also
what-
need them in the parser. We need to define a second enum with all of these in the parser.
Ah, that's right. Okay. Okay. Why can't we use the same enum?
because the parser enum has to have more. It
Ah,
needs more.
okay. That makes sense. This is cool. So you can call any function on all of the instruction types?
Any macro, but yes, or any function, I suppose. Yeah, but that's not gonna be a good idea. Just pass a function in there.
Because all you'd get
Supposed
is
to be a
for each
macro.
type. Oh god. I wonder, can we convert the compiler output into an image somehow?
What are you trying to do with that?
I don't know, but I want I want like an image to be output, and it goes, here's your program.
I mean, you could just take all the bytecode and slap it in a PNG or something, or like no, PNGs are hard. Like the other thing that's like this other
JPEG.
format that's really easy. I forgot what it was, what it's called. There's one that's like really simple that you can use for this.
Honestly, file formats are a lot simpler than people lead them out to be.
I'd say it depends on the file format, but generally, yeah.
PNG requires like 4 different compression algorithms and 18 different matrix multiplication functions, so it is a little different, but you're correct. I'd say most of them are pretty okay. Did we not have this before?
No, because we have no way of emitting it.
That's
we don't
funny.
have logical right shifts in the front end. Or in the language, I suppose we don't.
When would we even... Does anybody? Does any compiler have... Like, does C? How do you do a right logical shift?
I think. How do you do it in C? You cast to an unsigned number, I suppose. Other
Crazy.
languages like JavaScript, because it doesn't have signed and unsigned numbers, or Java. They have a logical and an arithmetic right shift operator, because they don't have the concept of signed and unsigned numbers. And this is something that you'll see frequently. Unsigned and signed can be used instead of like providing a separate operator for that. Because the way unsigned and signed just works, the numbers inherently are not signed or unsigned. Because it's just it's just a bunch of bits, right?
Yeah.
What determines whether a number is signed or unsigned are the operations you perform on them. So the only thing that an unsigned or signed type does is it tells the compiler to select unsigned or signed operations. So you can either have unsigned and signed types, or just one type and one class of types and signed and unsigned operations, and that's what LLVMIR does, for instance. LLVMIR only has an I64, not U64. But you can do an unsigned, or you can do a sign extend, a zero extend, whatever on it.
Oh no.
So it just has integers, it doesn't have signedness in the types. That's in the operations. That's the other way of doing it.
Craziness. That doesn't seem like too bad of a way to do it.
Yeah, I think it makes sense in an IR, not so much in a high-level language.
Yeah, I don't think we can slap that into the source code.
Most of the time.
This is the IR backend, if I'm not mistaken.
Yes.
So we can see that we can emit code that looks like the IR now, that is the IR now. And then we can go ahead and feed that back into the compiler and parse that into assembly or whatever we want. Or more IR, if you want to.
Re-emit the same thing, I suppose. Optimize it and emit the optimized IR or something like that.
Ooh, that'd be cool. Handwrite IR and then have it optimize it and see what you could do better. That's right. Arguments are now a pointer. We have a parameter instead of a parameter reference. This is fine.
Yeah, and also if you have a parameter in the register allocated, that's an error, because that should have been lowered. Or lowered to like register.
I see, I see.
In that giant switch case.
That makes sense. I never worry about panics. I figure we'll run into it very quick if it's a problem.
Well, you say that and then we'll have weird bugs that take 2 hours to debug. So I don't quite trust that.
What else am I gonna do tomorrow, man?
God.
It's like leaving breadcrumbs down the trail just so on the way back you can eat them all. Not for anyone to follow you.
Of course.
Oh, I love that. That mental image. Ah, yes.
Yeah, that's what I was talking about earlier.
Um,
Like
I
that.
I have a suggestion.
Okay,
This
okay, I guess I suppose I can add one more commit to this thing. Oh my god.
maybe a
How did
slight
that happen?
problem.
See, this is what happens if you don't check for like memory leaks. That's how this goes unnoticed. You just
Exactly.
create more context. Oh
This would
god.
stay there until the end of time if I didn't scroll through this code.
This is in the Arch
Because it
64,
works.
like line what? 8,
850.
8, yeah, something like that. Free, okay. Not re free. Okay, I'm gonna commit that as well.
Beautiful. We're gonna see a. I like the sound of your keyboard, by the way.
Thanks.
I
Actually,
unironically.
in what's it called? Cogen Context x86 64 Linux free. That's a long
Yes.
name. Now, of
It's
course, I can't use backticks and double quotes because it will evaluate that. There we go.
dealing with
All right.
shell string stuff in git commit messages is the worst.
It's
It's like
annoying. At
I
least
just
I
want
have
to back.
syntax highlighting in my shell, so it tells me if there's something wrong.
Nice. That is very good.
Mm-hmm.
What shell do you use?
ZSH.
Nice, nice. I use new shell because I'm on Windows.
Mm-hmm.
I,
I
it's
tried it. Yeah.
honestly, it's nice. It's not as nice as it could be. It's still in progress.
I'm
But it
just
is
very
very
much
nice.
used to like POSIX shell script syntax, so I prefer that.
That's a perfect idea. I just have never used shells, so I was like,
See?
something I've written Python. It can be like Python. I can at least
No,
understand
I
it.
do use like a for loop every once in a while for like bulk renaming files. I did that the other day, and Agma was just amazed that that's possible.
You should have him run the fun compiler with dash dash aluminium. It'll
Oh
blow his
god.
mind. From the terminal, it just opens up. He's like, "What? No." If we can have it where it like opens the video in full screen, I would love that. I don't know if that's
Yeah, that's a
possible.
good way of doing that because I'm not sure if there's even an option to spec.
Yeah,
Does this
there's
open
no.
have an option for that or XDG open? Maybe I don't know. Mm.
We'd have to like emit a click where we think the full screen button. Oh, we could just emit an F press right
Oh,
after into that process, right?
Um, I suppose if it's a child process, you can maybe, but then you'd have to like I think you'd have to fork it manually for that.
We'd have to write an entire custom
Yeah.
executable that gets built just so when you run the aluminium flag, it opens and then presses F. It's worth
Oh
it.
yeah, this stack frame thing.
That's right. So we
Uh,
now have full, minimal, and none stack frame.
yes. Full is for when you have local variables and calls, or just local variables actually. None is when it's a leaf function that doesn't allocate anything on the stack. Minimal is if it is, what is it, if it's not a leaf function? No, if it doesn't allocate anything on the stack, but it's not a leaf function, meaning it doesn't need the stack itself, but it needs to align it. So in that case, you still need to push some garbage for it to align it to 16 bytes. So we're just pushing RBP, and that also
Amazing.
means, by the way, that we could theoretically use RBP as like another general purpose register in those functions, or to save like a value that would otherwise push and pop, because RBP is unused in a function that's like marked as frame minimal, or that's is of type frame minimal, or whatever you'd call it,
That's an
because
amazing idea. That sounds
yeah,
incredible.
it's something that compilers do. By the way, you'll just see GCC randomly using RBP to store random values sometimes
That's a
if the
little
function doesn't
scary.
actually have local variables. Or RBX, because those are the benefit out. Those are Colli saved, meaning you don't have to push and pop them.
Mr. Mugume says, need help on Discord, daddy. Easy problem for you. Okay. Well, I'm going
Oh
to look
god.
at it. I'm going to look at it before I put it on stream. Okay. How can I fix something like this? Current next does not equal null, and new element
Oh god.
ISBN current next ISBN. What? Because I know
Uh,
if next is null, because I try to access ISBN.
That never happens because if the left hand,
Oh, is
if
greater
current
than.
next is not equal to null, like the right hand side of the and only gets executed if the left hand side is true. So by definition, if you get to the right hand side, the left hand side, current next is not null unless you have a race condition somewhere.
That's exactly correct.
So it can't be current next cannot be null on the right hand side of the and because of how lazy evaluation works.
Mr.
So
Mugume says
something else
that's what I
is
thought.
faulty. It might be new element that's null because you're not checking for that.
That's what I would guess. Or current itself could be null.
Yeah, that's also an option.
Just anything you dereference with the dereference operator, you should check if that's null. And then if it still happens, then you have something real weird happening. But one of those null checks should pass if you're getting a seg fault exactly from this line.
Well, it should fail technically, but yes.
Thank you. Yes.
And also for stuff like that, I recommend just using a debugger because it'll tell you where it failed and what was null.
It's a good point. Okay, to be fair, debuggers are good at tricking you into thinking it's a different problem. Because they show symptoms, they don't show the problem.
I suppose.
So the symptom can be like, oh, the stack pointer is completely wrong now, but it was actually just this other thing, like a function call happening, which is changing the stack frame. And then
Yeah, but at least you know where to start, more or less.
it's a good point. But where is my seg fault coming from? Probably a null dereference. If it's from this line, that would be, it's from this line. Because that's all you've given us. So it's definitely from here. Unless it's not from here, in which case I don't know how we would know. But
Yeah.
I would guess that it's a null dereference of one of these things, if you have tracked it down to exactly here. But yeah, just check current null, check everything null. You're on your way. And then you could even have each of those in a separate if and printf, like different things, or handle them differently if they're not at present. Okay, where were we? CodeGen Prolog, we now use the fancy frame optimizations. Very nice. I'm going to presume these work because I've tested the output assembly.
I think they do, yeah. I've tested them and they seem to work from what I've seen.
So they work on Linux and Windows. We're doing good. That's right. Tail calls are
Yeah.
allowed in the IR, and the IR can be output into x86-64 assembly, and the IR includes tail calls. So an optimization doesn't have to be included, turned on. What am I can't speak.
Basically, it's that tail calls are always handled by the back end. It's just that when optimizations are disabled, we don't try to introduce any more.
Yeah. That was much more succinct than whatever I can spit out of my flapping mouth.
Oh yeah, and return is now emitted not in the epilogue, but separately because we sometimes
Oh,
have a
tail
jump
call.
after the return. Because like in the tail call, yeah.
Okay. That's very cool. Okay, I'm gonna ignore that. It was there before.
That's just if you have a jump at the end of a block, and the jump after that, there's no point in emitting a second jump. If you already have a jump out of the block, an unconditional jump, or a return.
So like jump
That's-
threading type of thing?
Something like that, yeah.
Okay.
I don't remember exactly what situations this fixes, but there's some like weird corner cases.
Twitch just let
I'm
me
not
know.
that anymore, actually, but it's just there.
Twitch just decided to sabotage the stream and give me a
Oh.
notification, mobile live dashboard. You hear my phone go off?
I didn't.
Oh, there you go. It went off. It's like when you do something embarrassing at a party and you're like, nobody saw me fall, right? And everyone's like, you fell? And you're like, I should have just said nothing.
Yeah, so this is now a lot simpler because we're not allocating
wow.
here anymore. We're doing that in the front end.
That is much simpler. That's probably a good change. Mr. Mugume says, found it. Thanks for the help. Absolutely,
That's
Mr.
good.
Mugume. What are you working on? What is this a part of? What is ISBN? And why do you? What
Like
is?
International Standard Book Number, something like that. It's like a UID but for books.
Oh, that's right. That's like in the first page, isn't it? And it's a long number.
It's not that long, but yes.
Mr. Mugame says, yeah. Yeah, it's like, listen, in America, anything more than two, it's a long number.
I
That's
see. I
big.
see.
No, I'm just messing with you. We lost our dumper. The the back end no longer has a large, or I mean, a dumper check.
Uh,
It's too much fun. It is too much fun. We now have a debugger, which is
mhm.
much better.
Oh, I see. Yeah. By the way, look at the scroll bar. We are like halfway done.
Okay, it's only been 50 minutes. This is a short one.
Oh God, it has been 50 minutes.
Isn't
Jeez.
that scary? The good thing is, I'm pretty sure while loops are going to be like 5 minutes.
Oh yeah, which means if 5 minutes is 3 hours, then we should get that done in 1.5.
You got it now. You got it now. You
I
got it.
see.
That's the stream time. So at about 5 p.m. today, we should have while loops done. We now have the custom
Like,
stream type.
I don't know if you know Star Trek, but it's like you're like the anti-Scotty. Like,
I don't
Scotty
know
always,
enough Star Trek.
he's like the engineer, the main engineer on the spaceship, and he always says, okay, you get this done like in 2 weeks, and he gets it done in 1 week. You're the opposite. You say you get it done in 10 minutes, but it takes you 3 hours.
That's correct. That's correct. That's an accurate assessment of my time estimation skills.
So we have diagnostics now. The way I usually do this is note is for like informational stuff. One is for warnings, for errors. ICE is internal compiler error. That's a well-established abbreviation. And sorry is for GCC the GCC uses that for unimplemented. I don't know if you've ever run into that. I
Yeah,
have.
sorry,
Because I
unimplemented.
tried to do cursed things with it, like using I don't know too complicated expressions in designated array initializers, and that just it didn't like that. So yeah.
Sorry, we can't do this for
I
you.
also got that once when in like an earlier build of GCC when I tried to use a requires expression inside of a template as a template parameter. I didn't like that either.
Oh no. Requires inside of a template parameter?
A requires expression, yeah, because it's just another expression as like a Boolean template parameter.
Oh god. GitHub might disagree about this, but I agree with you 100%.
I mean, if
Their
you've ever
workings.
submitted a bug on GCC or looked at that,
Oh, it's
GCC
correct.
bug, you know it, yeah.
Yeah. That's why I prefer this abbreviation. This one is the good
Mhm.
one. GitHub is questionable tactics regarding those letters. Like,
Hmm.
yeah, here's their address. What? So here are the names. Sorry, unimplemented. Internal compiler error. In case any. Yep. Probably don't reorder those.
Yeah, just don't in general reorder things if you
Nice.
just have a reason to.
I owe every PR. I try and reorder a few enums. Make
So
it
this function, read the comment at the top.
okay. I missed it. Oh yeah. Issue a compiler diagnostic. Issue diagnostic. Warning. Alter this function at your own peril.
Yep, and I mean it. I mean it.
Do not touch. Can we make this a read-only file, like with chmod or something?
Yeah, let's set it to immutable in like ext2 or something.
Yes.
But thing is, this is the second worst function I've ever written in terms of like how long it took me to write. Not this particular instance of it. This is like the sixth or seventh iteration of this function that I copied it from another project. But writing this type of function in general that just formats a line like this is horrible. Like there's only one other function I can think of in any of my projects that's worse than this. Log10 is to compute the width of a number.
That's incredible. Log10 is scary. That's how you know it's a formatting function. When you just see random math, that doesn't actually...
Yeah.
It's like, I've heard of that, but how is it used here? That's how you know it's a formatting function. This is incredible. This is a lot. Oh, wow. Nice.
You assume
This
tabs are
is
false spaces because if they're not, then what the hell are you doing?
yeah, that's the correct amount of spaces. This is what I was about to say. That's perfect. That's the only correct amount of spaces, right?
Hmm.
Ooh, that's fancy.
It's for underlining, yeah.
That's fancy. We have the Lexer. I'm gonna skip over the Lexer. I assume it works.
Yeah, I mean,
There are token types. There are symbols in the symbol
oh,
table.
and that parser instruction type enum is why we need the all instruction types to be a macro.
Nice, nice. That's right. And then we define the iron. Ah, okay. That makes a lot of sense. Oh, it's right here. I missed it. I can't read.
Oh, we have also symbol tables here in the like they're also like here, even though that's Alexa, but yeah.
That's fine. Whenever you
And
can build them as early as possible.
note the job buffer at the end.
Oh no.
Because yes, error handling is over set jump and long jump because the choice was either this or wrapping every last pass and Lexa function in if this returns false, return false, or in a macro. So I did this because the alternative is horrible. Like you'd have
Yes.
to wrap every call to next token in a check.
That's okay, yeah, that would suck. I know exactly what you mean though. Because that's kind of how the parser works.
I see. Yeah, that's
Where
typically
every time you
default.
expect something, you have to check.
Half of the code is error handling.
Yeah. And it's the horrible part is the parser doesn't even do it most of the time. It should check expected.done every time it calls expect. It doesn't.
Oh
It
god.
really doesn't.
Also here, if you want to add an instruction, just add it here.
Okay. So new IR instruction would be add it to the macro, add it here,
Yeah.
and then add it anywhere there's a static assert.
Yes, and there is a static assert here if you scroll up a bit.
Oh, nice. Oh, beautiful.
I
Okay,
had to
so
cast it to ints because like these are two different enums.
oh, does
The first
W
is
conversion complain about enum to enum comparison?
yes, it does.
Well, that's
As it
weird.
should.
It's not really a conversion. I guess it's a type
Not
conversion.
conversion. It's not even doubly conversion. It's a comparison of two different enums. That's a weird thing to do.
I guess I do it more often than I
I
care
see.
to. I guess because I often do like this type of thing where I have an extension enum and I have like multiple extension enums based
I
on
see.
especially for file formats where they have like optional headers that can come after the main header and then it's like
I
it gets
see.
difficult. Anyway,
It is
delimiters.
start and is continue. That's like if you know character classes from Unicode, a character that may start and continue an identifier. I think that's also yeah. There's a comment for that too. And these
Nice.
delimiters. That's something else.
So
I don't remember what we need those for. There's somewhere in the Lexa. There's a reason for those.
could we use like string span or string cspan and just check the actual Lexer delimiters from parser.h or c? I just
Um,
opened the same one. I'm s- small brain.
I don't see. The thing is, I don't do parsing with any of the C library functions because I parse and Lex character by character for the reasons that you'll see in Nextchar a bit
I see.
down.
Next. Oh God. Oh no. He likes character by
Yes,
character. Okay.
yes,
That's
always because there's two cases you need to handle. One, what happens if you at the end of the file you just don't want to run off, so you just keep returning zero. And two, new lines need to be handled. In this case, it's not that important actually, but there are languages that care about that. So we just treat \r, \n. We always treat \r as \n, and if we have this check is unnecessary in this case because it would be necessary if we had a parser that keeps track of what line it's on, which this one doesn't, because we treat \r, \n, and \r as one new line. That's what this code does, which in this case isn't terribly necessary because I changed something, and we could just check if it's \r, we just set it to \n.
I see. I think that's fine. It's not a problem. New lines in the IR parser. You should probably only have one instruction per line, like you were saying. Mr. Mugame says, "Where is a Eternal from? I like his accent."
The accent is Bit of a mess, honestly. It's mostly a northern accent. Mostly Yorkshire, I'd say.
That's
Mostly, yeah.
northern UK for those uninitiated.
Probably what else would northern mean?
No, north of the world? I don't know. Are you from the North Pole? Northern.
Northern typically means northern England. Not even northern UK, because Scotland is Scotland. Scotland is not in the north. It's Scotland. The north
That's a
is the
good
north
point.
of England.
That's right. So yeah, yeah, I remember that UK video now. So like England is the 4, but it doesn't include the other one on the side, right? England's like the
Yeah,
main island.
not include Wales. No, okay, okay.
It's close.
Great Britain is the main island. Then there's Ireland. That's the other island. It doesn't help that Ireland and island sound pretty similar.
I see. I see. Okay, yep.
Ireland, the island, and on the island of Ireland there's Northern Ireland, right, which belongs to the UK, and then there's Wales and Scotland, which are not part of England, okay, but also part of the UK, and England is like the rest. And there's also some islands
Ah.
like the Isle of Man or something, but
That's okay. I that makes a lot of sense.
yes, there's like this entire where's like the British Isles Venn diagram. Look,
So just to clarify, Britain is a country within Great Britain, the island, which is within
Britain
the
is not a
UK.
country. The United Kingdom is a country.
The United Kingdom is a country. What are the things within the United Kingdom called?
Okay, hold on. I'm gonna pull up the British Isles Venn diagram.
I would call them states because I'm American. You have a country split up into
what else?
states.
Image, copy image. Okay, hold on. I'm
So
gonna.
very good.
Can I just post this on the Discord? I suppose I can.
Yeah.
Oh God, this thing is in the way now. Okay. Yeah, this is like the UK Venn diagram, or not even UK. It's the British Isles Venn diagram.
Oh yeah, sensible. It's simple, easy to understand.
Yes.
The diagram itself is, but the data is quite confusing.
Oh, and to answer your question, Scotland and Wales are countries.
Okay.
Wales has its own national anthem and flag, so
So these are countries? Or is the United Kingdom is a country with countries in it?
yeah, sort of.
Okay. Okay. That's fine. I'm okay with that. I get it.
That's what the United Kingdom.
I get it. Okay. So the Great Britain,
Great Britain is like the main island, the big one.
yeah, and on the right side you have like England. On the north you have like Wales, and on the left south side you have Scotland. Am I wrong?
Scotland is in the south. Jesus fucking Christ, that's abysmal. Okay, time for another map. Scotland is in the south. Okay.
Where is it?
I think if there are any Scots in chat, they're gonna want to murder
It's
you
next
right
to
now. There you
northern.
go.
Luckily,
Jesus
they're not
Christ.
common in these circles. Thank
Scotland is in the north.
you. So, okay. Wales is the little bit on the left, so I mixed up these two.
Yeah.
Okay, I feel less bad. I was at least close with the what was it, geology?
Scotland is in the south. Jesus Christ.
Well, they sound like American Southerners, so it's hard to get that out of my
mean,
head.
Not really, but I guess they both have like thick accents, so I get where you're coming from.
Yeah. So Ireland, oh man, Ireland is an island and a Republic of Ireland and
Yes.
Northern Ireland.
Ireland, the country, which is part of the island of Ireland, and then there's Northern Ireland, which is also an island, but that's not Ireland, it's part of the UK. Simple, right?
I feel like I'm describing the working result thing in the parser. I'm trying to wrap my head around it. It's so difficult. Oh man. So Ireland is an island. Fuck.
Ireland is Ireland, that is true.
Ireland is an island. Oh
Yes.
god. Which has two countries on it, both named Ireland.
No, we have the Republic of Ireland, the other one is named Northern Ireland.
They both have Ireland in the name.
Yes.
So that
because
would be
they're
like
an island.
that would be like if North America had a country called North America on it. the Republic of North
Um,
America, which is kind of how it is. It's the United
yeah,
States of America.
basically, yeah, something like that.
Okay, that's starting to make sense. That was a long detour, but it's needed because this is
It's not that hard. It's easy to remember than your 50
okay.
fucking states over there.
Here's the
Like,
thing: the the U.S. It's the U.S. and then each state. That's it. That's
yeah, but
it's a
there's
simple.
50 of them.
Well, we're big. We have like this much land is like a quarter of a state.
Yeah, it depends on the state, I think. But yeah.
All of them are very big.
No, not
Idaho's
the
like the
ones like on
smallest, right?
the, what's that, on the, is it west, east
Connecticut.
coast? All of these are
Yeah.
like the tiny ones.
Yeah, all in New England they broke it up like this. Because it's New England. They're like, "Oh, yeah, we'll break it up like England."
I see.
So you have like
And
Connecticut and Rhode Island. Rhode Island is tiny.
so that was the numbers pass, I think, just now.
It's very beautiful. We have hexadecimal and octal and
Yeah, because
binary.
it's easy to implement. It's like
I
the
sh-
same thing.
I'm gonna steal this for.
That's how I always, if you look at any of my projects, Alexa is pretty much the same always.
That's fair. I mean, most programming languages don't really have crazy Lexa requirements.
Exactly, yeah. And then there's next token, which is also part of Alexa, and also usually model is the same.
That's right. Okay. Oh god, it's character by character. That's right.
Of course it is, yeah.
Make.
Yeah, this makes a thing of type with a parameter of type param type and sets a field.
Does this make a function
This
called?
adds an entry to the symbol table. It should probably be called that. And
Okay.
because we can
Oh,
add
it's right
temporaries
there.
and blocks and functions, and there's 3 separate symbol tables for them, we need like a macro. Because if you look just down there, a few lines below, the code for them is exactly the same, and I don't want the same function 3 times with just a few things changed, so I made a
Yep.
macro. And you'll see, that's a pattern actually in here. You'll have multiple macros that do things for temporaries, blocks, and functions.
I'd say that's sensible. In as far as
Probably nothing called make, but
it
yeah.
slightly confusing. Just run make and from the terminal.
Also, the comments are like awfully generic. Add the thing to the symbol table. Because what else am I going to call it? I don't know what it is in here.
It should have been called make thing.
Make thing. Yeah, that's even better. Yeah.
Make thing temporary. Can you use a portion of a symbol in a macro concatenation? Can you like
Well,
start?
splitting a symbol, and if it doesn't work, if that's what you're asking.
Okay,
That's not.
that doesn't work. That is what I
It's
was
just
asking.
preprocessor is a very primitive thing. It can't do that.
We're gonna have a very non-primitive preprocessor if we ever make one.
Well, if we do that, we should have proper like comparative evaluation and meta programming. Oh, this is like the main. This function you're looking at, that's the main instruction parser, I think.
I know, I got a little scared. I was like, yeah, this looks like the parser.
This is like the main function that does most of the parsing, which there should be a comment at the very top that says exactly that.
This is, yeah. This reminds me really similar to the structure of the regular parser. We look if it's an integer, we check for a type, and then we continue to do things based on if we find a type. If we don't find a type, we do other things.
Yeah, pretty much.
That's so cool. Parsers are very similar.
And
This
it
is
also generates the, if you can see, there's calls to like II insert and all of that all over there. So this actually generates the instruction.
oh, that's why it's in the code gen. So there's no AST. Why would there? Yeah, we shouldn't hire it to an AST. That wouldn't make any sense.
Yeah, there's no point for that.
I get it now. That's why parsing is in code gen of the IR. Yeet comma. That's beautiful. Commas are like, why are they even? I don't get it. I get it in English. Like here, it makes sense because it physically delineates this thing, this clause, from this clause. It's like, okay, these are clearly 2 different things that are put together. Oh my god. My headphones, I feel like my ears just cracked. That was incredible. Oh, but here, oh my god.
That's my chair. I really need a new chair. It's like stuck in the all the way back position, and now I need to lean all the way back for it to be comfortable.
Chat. You should donate to Eternal for his new chair.
God.
We'll never deal with those clicks again, I promise.
I'll try
You have a
not to
PO
move,
box?
move slowly. Oh yeah, so
It's
void
not a big
instruction
deal.
basically means doesn't return a value. Currently, I think that's only store and the branches.
That's right. That's right. But yeah, I don't understand why commas are actually needed in programming languages. They're just
Because
for
they aid
funsies.
usability, I suppose.
I mean, they can be
They're not
optional.
needed. You're right about that. They're usually not needed.
Yeah,
A lot of things are. Semicolons aren't needed either most of the time. There's like
it's
one
true.
case in the grammar where semicolons matter, and that's returns. Because return semicolon is different from return and then something on the next line.
That's true.
That's the one case in the grammar where you need a semicolon. If you don't want to have be white space like dependent or something. But I think that's the only place at least that I can think of. So you technically don't need semicolons.
I'm gonna trust that this works. I'm not gonna think about that too hard. Yep, so that's the function attributes thing. Oh,
That's all the attributes we support. That should probably not say duplicate const eval attribute in there. That should say duplicate like. Okay, I'll fix it real
Thing.
quick. It should say hash a.
so awesome. This is why we read through it, chat. Don't at me for
Well, we
taking an
actually
hour.
read the code, yes.
Automod. Oh, I got a new moderator tools in Twitch chat now called Shield Mode.
Oh,
And I can immediately, if I turn it on, I can just click the shield and it puts it into slow mode 30 seconds, followers only 1 month,
oh,
and like it disables chat for 6 seconds and hides all the previous messages.
interesting.
It's really, I really like it. It's like a panic button, like, oh god, chat is going wrong, press that. Which is exactly what we as creators and streamers need.
God. Oh God. Don't resize the terminal in this. Oh God.
That's funny. I just added that today to Light, the text editor. You can now dynamically resize the texts like in Emacs with Alt plus and minus.
Yeah, just look at this. Jeez. That happens if you resize the terminal.
Oh no.
Yes.
What?
Just prints the prompt a few hundred times.
Okay, now I have to test this. Does it? Okay, how do I do this? Oh,
I mean, this
it
is
does.
in C line though.
Look, it
Yeah, it does weird things. Like if you resize the terminal, it just
you
does
see
weird
that?
things.
There was lines between here. Did you see that?
Mm-hmm.
Oh, there's a line there. Why is there a
Brilliant.
line?
Because reasons probably. Did I
Terminals.
push this thing? I did. So that should be fixed now.
God.
That error message.
How do I do this? There's no reset size in this, which is worrying. Oh, now none of the sizing works. Okay, there we go. Well, hopefully. Oh God. Yep, it breaks things.
Yeah.
Okay,
I've fixed the thing, by the way, the error message.
beautiful. I'm scared to press the big red button.
There's a file list on the left. You can just seek back to it. I suppose you'd have to scroll down though.
Yeah, I'm at line 1200 of a large diff.
And if you scroll up one function more to pass layout, that's where the set jump is, in case you were wondering.
Nice. Oh God. What is set jump? Why is this needed?
The way this works, set jump and long jump is basically like throwing an exception. That's how they were implemented originally, fun fact. Long jump gets
Over 2
called by
gates.
the Adam. Okay, there's set jump and long jump. Set jump returns twice. The first time you call set jump, it saves the current state in a jump buffer. That's the thing in the parser struct. So it saves like
Yes.
register. So it's basically like a context switch, more or less. So it saves the current state and returns what is it? It returns 0, I think. Yeah, it returns 0.
Yeah.
And then you can call long jump, passing in that jump buffer, and it will jump back to where the set jump is and return 1, or return whatever value you passed to it, in this case 1.
Oh
So it's
my.
like a
Okay.
non-local go-to, basically.
Yeah. That's
It jumps over
horrifying.
the call stack.
Wow. That's possible? That's
It's standard
crazy.
C. That's how exceptions were originally implemented, like set jump, long jump exceptions.
I didn't know that. You taught me something today.
It's not
That's
used
incredible.
commonly, but I think this is a good use case for it because if you just want to like abort as soon as there's an error.
So can you implement defer with that?
Don't think so.
Okay.
Because it always goes back to where the set jump is.
So you'd have to write the set jump
Actually,
down there.
I mean, and also set jump has an overhead. It's not like C++ exceptions because set jump has an overhead. Because
You actually call it. And,
jump buffer on my system is 200 bytes.
oh, Jesus. Yeah, so it's definitely something.
That is a way to implement
these are
differ in by the way, a sorter, not really, but sorter using attribute cleanup and inline and like what's it called? Nested functions, which is a GCC extension. So basically, if you use enough GCC extensions, you can implement defer in C.
You could probably implement anything in C if you use enough GCC extensions.
I suppose
Even C++.
that's why I would recommend using GCC or Clang, not MSVC.
That's
MSVC is annoying in that regard.
It's
Because
the
it
worst
doesn't have
one.
Hyper, if it doesn't have VA opt, it doesn't have so many things it doesn't have. It's annoying.
Okay. I was like, what is USAs? But it's a U size. I'm
Use types, yes.
I'm out of practice.
got tired of writing U in 64. In fact, I didn't even attempt it. I just put the type diff at the top.
So is this freeing all the context and stuff? Just to be sure.
This is like freeing the context in case of error. If there's an error, if you scroll up a bit, inside the if pass okay, there's a return statement that returns if everything was okay. Not there. Then it falls through to that and cleans up everything.
See, I didn't read the identifier. I assumed it was an error. I was like, oh, if there's an error, keep going. If there's an error, stop. But yeah, it's the inverse. I often inverse conditionals from what other people intuitively do, which is sad because I'm trying to describe it. They're like, no, that's totally wrong. I'm like, I promise it'll work. And they're like, just do
whatever
this.
results in like fewer nested scopes. So if you can have an early return or continue, I'll use that instead.
That's probably the
Just
way
like,
to go.
yeah, case in point, in line 1282, and below that there's an example of that too. I just have two ifs and continues in them.
That's true. That is satisfying when it's kind of like a continuation based parser. It's like you get rid of all the recursive calls. You just immediately you can. It's satisfying that type of optimization.
And we have
lost our
one
dumper.
entry point to this entire thing. Like this entire thing exposes one function that's IR parse. If you scroll up a bit,
Your parse.
that's all that is in the header.
So everything we just read was only implementation details.
Yes.
Technically, all we require, you could swap it out with any library, any other file that implements IR parse.
Something like that, yeah.
And it wouldn't be too hard in CMake. We lost our dumper. It's not. It's now a Boolean.
Yeah. It's also equals false now. It equals 0. I don't know why I did that. Also, these other ints should also be bools. I just didn't.
Well, okay. The original idea was that these need to be like levels, like verbosity levels 0, 1, 2, 3, 4.
Okay.
Yeah.
In that case, it makes sense.
Valentina, thank you so much for the follow, and Cast Labs, thank you as well. I appreciate it. Thank you for sticking around. We're up at 216 now. Isn't that crazy? Weren't you here before 50? I'm pretty sure. Because we had the whole list of 50 people. Did I ever release that? I probably didn't release that. I just made that list, huh? Oh yeah, I started thinking about legally. Like, can I actually use all these people's usernames? Twitch gives me this information. Can I freely use it? There's no license on Twitch with the information they give me, so I get scared.
Well, that's a complicated topic, I suppose. Anyway,
Yeah.
we have need command line arguments like so because that's how it's usually done in my experience. Like as soon as if you have a problematic thing that could be recognized as a command line arg, just do dot slash in front of it and it'll work.
Yep. Which
Like
in,
if for some ungodly reason you decide to name a file -o, then you can do dot slash dash o and it
yeah,
works.
that's a good point. And that's really the user's fault anyway.
Yeah.
What are you trying to do? Break things? But yeah, this is all just argument parsing. It looks just like all the other arguments. It's perfect. We now have in file, out file, well, paths, and then the length of the in file path. Okay, that looks fine. So, is there a way to like clear argv?
Why do you want to clear argv?
Well, if a long running, that's for not for this program. If a long running program needs its arguments at the beginning and then doesn't need them anymore, it's just useless memory that's on the
It
stack, I guess.
is in the stack.
So you could save on stack space if you could call like argv clear, and then you could reuse that stack space.
Well, you probably don't want to just increment the stack pointer randomly in the middle of a function. That's one thing. But if you look at the typical signature for argv, it's a char pointer pointer, not a const, not a char pointer pointer const. So you can reassign it if you want to. You can use the space provided to you by argv to like store other character pointers in there if you really want to. I wouldn't recommend it, but you can.
I have some ideas.
I wouldn't do it, but you can.
You'd have to call strlen on each one, and then use that much data at each index.
God. You know, again, I wouldn't recommend it.
We're gonna make a game that's stored entirely in argv.
Good God.
It's like a little tic-tac-toe. Oh. Okay, so if verbosity, we got rid of this. Is that on purpose?
Yeah, I don't know why. I don't know. Maybe I just deleted it accidentally. I don't remember.
That's fine. We should probably have it. Or like if verbosity equals 4, and then a way to set that, but it's fine. It's really not important. We have CodeGen with the new 9 parameters for both IR and...
Yeah.
Oh, here. Oh, okay. Okay.
Oh, there it is. Just
Okay.
git being git.
Git is confusing. Why does it show that it removes something next to... Like, why wouldn't it... Okay, here's my question. Why don't we go through the output file, and then anytime something's added, it just says it's removed, like here's what used to be there. Instead of going, their current theory is to go what was removed, go through the old file and show what was added. Do you see what I'm saying? So if they put the line numbers on the right as like the base line numbers, and then anytime the old file had changes, then you can just say, oh, well, these were removed and replaced with this. And the diff output actually includes that information. So it's like they have it. They have it. They just base it backwards to what is intuitive. So you get things like this is just removed for no reason. Also, I can't deselect now. So that's yellow.
I don't on deselect, yeah.
Cool.
Totally. Great UI.
Yeah. Millions of dollars. Nice.
And that's some changes. Yeah, that's stupid, honestly. MSC, but
It doesn't make any sense. What is MSC?
yeah.
It doesn't make any sense. It's really dumb. More indent fighting?
Apparently. Interesting. I might have run format on the client format on the accidentally or something. I don't know.
I would assume so. It's fine. I don't care.
Oh, I think I might have merged something here because you changed something. I think this is like the merge commit.
Well, this is probably Emacs indentation then. Yeah.
It might be.
Beautiful. Emacs
Because
indentation is odd.
I remember merging this file.
Thank you, by the way, for dealing with the merge conflicts.
No problem. It's easy to do in C-Line. There's a UI for that, so
Nice. I think I haven't done it a lot. There's like S-Edit or something in Emacs. It gives you a whole buffer and you can jump between them.
I see.
Maggot also has a thing, but it was kind of confusing. As Maggot usually is.
I was gonna say, yeah.
Okay, git diff is being weird again.
This is all just indentation, I think.
Yep. I was like, this looks recognizable. It's
Yeah.
just confusing. Because they put it in the middle of a... Okay, whatever. Yep, that makes sense. Pollen
Really?
Haxis... Thank you for the follow. What a name. How's it going? Thank you everybody for tuning in. What's your, what was your favorite part of this PR? This PR movie. Yeah, it looks good.
Oh, I did that find if, yeah.
I love at the end of that. It's just, yeah, it looks good. The journey was the destination. Okay, we did it. That's right, we fixed things while I was looking at it.
Fix the error message, yeah.
Yes, okay, we're good. We're good. I'm gonna assume they're good. We're gonna be good. Are you good?
Yeah.
Okay, we're gonna be good. Oh, we're gonna be good once more. We have to click so many buttons.
It only took us 1.5 hours.
Yeah, my clock is a little fast apparently. I did it 18 seconds ago as soon as I did it.
Mine says like you just committed this in 2 minutes. In 2 minutes.
I am a time traveler. No, it's like time zones. So like it's, you know what I mean? It's like almost midday for me, nighttime. But for you, it's like morning.
No, it's not time zones. It's it goes fast. If you look at the minutes, like it says it's like 1 past, but it's 4 past on my phone. So it's like 3 minutes slow right now.
I see. My phone and my computer agree. Oh, now they don't. Now, that was crazy. I was looking at them and they changed.
Oh god.
Yeah, my phone still says it's 1404.
Brilliant.
It says 14. Oh, now it just updated. Yeah, it's like 20 seconds off. Craziness.
Interesting.
Well, we merged. You know what it's time to do now? Poll changes.
Trying to see if it actually works.
Yeah, and ensure... Not ensure nothing is broken. Figure out what is broken.
Yeah.
I probably have things.
I need to stage something again.
Stash. Everything.
Yeah, it's just
Everything.
like your list of stashes just keeps growing.
I gotta pop them. I don't need them.
Why do you stash them? You know there's that git restore, git reset is a thing, right?
You use those?
Yes, I do.
I thought those were like legacy.
What?
I'm just messing with you.
I use it all the time. Git reset --hard.
That is very useful. I just like to keep my changes in case I actually fixed something. I have to pull from origin main. I was like, no, I have to pull from your branch, but no, we just merged it.
We just merged. I also need to merge my main branch now.
Okay, so we're good here. What are we doing? Now I have to build it. So I just use CMake. Here, I'll make this large. And CMake is easy to use. You just build, but clean first. I know I'm the only one that says CMake is easy to use, but the alternative is make. Do you
The alternative is shell scripts, and that's not really better. That's true.
It's like the syntax of all of this. I'd say CMake is CMax.
CMax.
I know what I'm making next.
CMake isn't good, but it's the best we have in terms of syntax.
That's 100% correct. I'm excited for
syntax. It's like someone, I don't know what happened, like who designed that, and what went wrong in their childhood or something for them to design something like that. Like what amount of trauma it takes to write a syntax like that, because Jesus Christ, just look at the CMake syntax. It's like, it doesn't make any sense at all.
It's a
like
little confusing.
it's line-based commands, but then there's also parentheses on an endif. Like, what?
Yeah. That's one of the best parts.
On
Parentheses
endif.
on the
Yeah.
endif is like, endif is a function now?
Apparently, something like that. Who knows?
So
Okay,
weird.
this is what this is GCD unoptimized, I see.
Yes, we're gonna. You know what I figured out? You can call no standard lib unless you define external functions in the libc. And it's much faster.
I imagine, yeah.
That
Okay,
worked.
now try compiling it to IR.
That's right. Okay, so all I have to do is do format IR, right?
Think so. It will yell at you if it's not it.
That's a good point. It didn't yell at me. Oh, it looks
There we
correct.
go. There you go.
Yeah. Look at that. So now we have the IR of GCD. And then what we can do, yes, is feed this back in. Can I specify the type?
Right now because it's .s though. You'd have to call it .ir.
Okay. Done. And then format of the default, which is assembly. Okay. Assertion failed s.data.
Okay, could not open file. I think that's the problem.
Oh, I just gave it the wrong file. Okay. Why did... Uh-oh.
Oh yeah, I see.
Could not open file should probably care about that.
It should probably terminate if it can't open the file, honestly.
Unknown instruction name dot address.
Oh, that's because we're emitting that but not handling it in the parser. Yeah, because it doesn't really...
I chose a complicated
Yeah.
one.
Fine, I can add it. You can add it yourself if you want, or should I add it?
Yeah, let's go at it. It'll be a good exploration.
that.
IR
Would be a
parser?
good exercise. Yeah, let's go to the IR parser, and there's a list that I showed you earlier with all the keywords. Oh, not keyword instruction names. It's just search for it's type. It's uppercase type for some godly reason. I called it type.
Here?
So search for type. It's all uppercase tab, not in here actually.
Okay.
Actually,
Here.
yeah, you can put it in here. So, no, you don't need to put it in there. Actually, okay, hold on. I'm thinking about this. You might want to put just adder in here as another instruction type because
Okay.
we treat local and global addresses as the same probably then.
Are these only used internally? You should probably go up
You
here.
know, yeah, it doesn't matter. The order doesn't matter really.
Okay, we're good. The
And
one.
then you need to do a few things. You need to add it here.
Okay,
And currently
yes.
send it as like dot adder because that's like sort of a compiler.
It's an
Turns you
internal,
right now.
yeah.
Because the thing is, it doesn't make much sense to have this because eventually, like, allocers and global variables should be pointers to begin with. So it doesn't make much sense to have this as an instruction. That's why it has this weird name. It's like a temporary thing.
I see. Yeah, because when we don't know if it's a local address or global. It's just an address, right? In the IR, is that kind of what's going on?
It's the fact that if you, okay, you can't just take the address of some random thing because if you try to take the address of 4, that's not going to work.
Yeah,
it
it's
has
gonna
to be
break.
something that has a memory address associated with it, and if it does, then you already have a point to it somewhere, so you don't need this instruction at all.
I
Because
see. Yeah.
global address should not actually be an instruction. It should just return whatever the memory reference of the thing you're trying to take the address of. So in case of a local variable, it should return the stack allocation instruction that is associated with that variable. And in case of a global variable, it should return a pointer to that somehow.
I see.
It's the point is that it's not even supposed to be an instruction in the long run, so that's why it has this weird name because it's not something you're supposed to use. Anyway, you need to add handling for that in
The switch.
in like the instruction parser. So you need to
Here,
in
right?
here. Yes.
Yeah. Okay.
So you need to do a case adder and then add that. And
We'll get
okay, we need to figure out what the syntax for this is.
there. Okay. So I need to go look at the IR.
So yeah, look at the not just look at the look at the there's also an idea probably.
Oh, this is a good example. I can load the file of UNIR mode, and then, look at that. That's
The
beautiful.
colors are like a bit
Interesting.
audible because they're from my color scheme.
It's okay. We'll just ignore it.
Yeah, dot adder apparently takes a label.
Where is it? I don't even see it. Oh, it's first one.
This takes a label. Interesting.
So is that a
So
name?
for now, that is a name. That should be a name. You should look that. How will we do that? Hold on. Adder. No, not. Why are you putting adder in square brackets?
Because tail had it. Is that wrong?
Do you know what the square brackets mean?
Oh, it's optional. Okay.
Yes.
You're right. I copied. I was full lizard brain. I'm like, this look is the example. Copy it.
Tail color is the worst example you could have picked for copying.
That is a
but-
good point.
Alright.
Why is the indenting is so fucked? Because this is
I
Four
don't
space.
do indents like you do. That's why it's 4 space.
Are you
indent
ready?
as it should be.
boom. Oh, uh-oh. Hello?
Wow.
86. Oh, okay. Did you see that it said 86% complete?
Complete brilliant.
We did
Love
it.
the includes are still indented 4 spaces.
Where do? Uh-oh. Okay, go to adder. Okay, we did it.
Okay, so what I would do first is instead of doing this in here, you go to the BNF grammar and add it
Yeah.
in there.
Okay. Docs.
And you copy it over.
Oops.
By the way, I do have an Emacs mode for BNF if you're interested.
I'm interested. I'm
Okay,
definitely
I
interested.
Copy that because the way I do modes is I slap them all in my .emacs, so I'm just going to copy that out.
That's beautiful.
I don't do separate files; it's all just in my .emacs.
See, I used to do that, and then it got rough once I wrote the mode line. This handling is the most complex Lisp I have ever written, and it hurts my head. It hurts my head still to look at it. And I stupidly named it the simple mode line.
So this is the BNF mode here. But it's really short; it doesn't do much.
Okay, that's beautiful.
Hold on, where is it? I'm going to post it on the Discord. BNF mode. There.
That was a satisfying enter press. I could hear it. Bam. Okay, I'm just gonna. Can I just do this?
Just slap that in your .emacs. I think it works or something. I don't know.
I'd have to restart Emacs. Or I guess I could load the file again.
Emacs,
Here,
you can
I'm just gonna-
You can just invalid manually.
I know.
Yeah, just invalid everything.
Yep. Okay, I should now have BNF mode. Beautiful. Again.
All the colors are for my color scheme.
Oh, it's beautiful. So what do you have? What is this?
I use font lock warning face.
Ah, yeah, that would definitely be it. I have warnings the same as errors. I'm pretty sure it just
Because
inherits.
for me, font lock warning face is just orange. So
That's-
that's my way of saying orange.
That's a yeah. For me, I just have it the same as error because I can't. I don't know. But I
mean,
should
you
probably
can
set
change
that.
it right there in like
Well,
you can change the code to something else. Like I don't know.
I can. I could customize it. Here, one thing.
Not just that. You don't even need to customize. You can just go to the BNF mode and change it in there.
Oh, that's a good point because I just
Different font.
font lock string face.
It's not no string face really. We already have strings in here. I wouldn't use string face for this, but okay.
It's
Because we'll
just
have
it's
things.
yellow.
I mean, technically it's also a terminal, so that actually makes sense. Did you forget to eval it? I always do.
I have to do this again.
You only have to eval the font lock keywords, by the way.
Uh,
Just to revert buffer, by the way. Then that also works.
that's probably what's happening. Nope, it's fine. They're red. Whatever.
Okay.
It's fine.
Interesting.
I'll just leave it.
Maybe font lock string face isn't the thing. Who knows? It is interesting. Weird.
I don't know.
Anyway,
It's too complicated.
Basically, you need to add an instruction here, and it's an
Add it.
address instruction. It is a value instruction, so you can add it there.
Here? No, it's
Read
not
what-
binary.
Okay,
Yeah,
it's not a binary instruction. Yes. Is it a unary instruction? Actually, it might be.
it's on a label. It has one thing. Should I add it here?
But unary specifically is a temporary argument,
Okay. So, like this,
Mhm.
and
and
then
then for now just a label. If not,
which is name, right?
we don't need to put it in parentheses.
Because there's no
we have-
or. Yeah.
Yeah.
I lead by example a little too strongly.
Hmm.
Okay. I have follow by example, not lead. Sayings are hard. Sayings are hard. So with address name,
Yeah, address name.
okay. So all we need is name because we parsed address.
Yes.
This is
you
in the
need-
value instruction.
Yeah.
Okay.
So first thing you need to do is yeet the address, obviously.
Yep. So eat address, and then
Yeah. And then you expect a label is an identifier just.
okay. What is type from span? Should I care about type from
Ignore
span?
that. No, that's for tail call. Ignore that. If you
That's what I
encounter the
figured.
word tail, it checks that the next word is call.
Gotcha.
That's
Gotcha.
why. You
So
just need. You don't even need the square brackets. Just do error. No, you don't need to do that. Just do error. That's if it's
uh,
not identifier. That's the error case.
oh, okay.
So just do error.
Erat.
Capital R. No, you don't need to do at. By default,
Okay.
it's at the current token,
Gotcha.
which is fine. in this
That's
case.
beautiful. Okay.
And just a message like expected name after address or whatever.
Did label. We'll just go with name / label after address instruction. Is that how that works? Should I do like dot adder?
You can do dot add, it doesn't matter. And you don't need the braces around the if, by the way. I
That's
usually
true.
don't put them there because it's less code.
I'll just keep it consistent with the file.
Yeah.
That's cool. Do you
Error
use the
is
next line?
Sorry, what?
Do you use the next line or do you leave it empty? Oh, you use it. They still
I
have to.
use it typically unless there's a reason not to.
Okay.
So by the way, the reason you don't need the iLock here either. That's just if you want to report an error here later.
Gotcha.
That just grabs the current location.
So then we definitely don't need to fall through. We need to, okay, let's look at an immediate, please. Thank you. Okay. We need to do this.
Well,
I equals
sorta.
IR and the next
You
token.
probably don't want to do this. You probably want to choose something that actually uses a label. Like you need to check what this. Actually, the thing is though, global address. If you look at how it's used to get the name of a function, not a label.
That's true.
So this can be. Can this be a block? It doesn't make sense for this to be a block, honestly. I think, because you can't do global address on like the start of a block. That's nonsense. In IR, that doesn't make sense. So this has to be like a global name, which means currently it's a function because we don't have global variables in the IR yet here.
That's a good point.
So this can only be a function name, which means we need to resolve this thing later. When the way we do that is you need to manually allocate an IR global address instruction, and then use resolver declare function to mark the pointer inside of the global address instruction for resolution later on, because it doesn't do forward declarations, right? If the function is defined later on, we don't know that it's a valid function name yet, or what it refers to. So we need to fix that up later. Well, actually, wait, global address just uses the name, right?
Yeah.
So we can just use that actually, that also works.
Does this work?
Though, yeah, this works. I would actually do this because this checks that the thing exists.
Do the
But for that, you need to do a few things. You need to create an instruction of type global address.
Yep. It's happening.
More or less, yeah. And if you are declaring something, you should probably wrap the entire case in braces.
Thank you for the reminder before I put in an if zero.
Yes.
There.
Yeah.
How
that's
did
I
you-
usually do it.
Yeah. Okay. Everything's fine. I wish. Okay, Emacs. I'm overriding you. It's happening. I wonder if you can change this in the Emacs C indent mode. It's probably not too difficult. To
I
make
don't know.
Comments before a case on the base level, just like the case.
And format handles it correctly. That's all I'm gonna say.
That's true. I should just write a Clang format that copies the GNU C style. There's a lot of these.
I think that's a built-in thing. Even it has built-in configurations, and like GNU is one of them.
Does it really? Oh man. I gotta get on the.
My CMake.
Okay,
What's it called? Dot clang, not CMake, clang format. If you're interested.
Oh, okay. Yep, don't do that. Search for adder, please. So we create a
And we
global
put-
address.
Make sure not to do that on the second line, like the call value call. You don't need to set the tail call flag on the thing.
Yeah, so this instruction should probably just be called adder. Is that okay?
Yeah.
Lowercase.
Yeah, sure.
Insert into the current context, and don't do
Yeet
that.
this line because that's nonsense. Yeah. And then let's see.
Call.
It doesn't need to. It's probably not going to be that. It has to be like value. So, is it just name? I'm not sure.
That should just be a string. Passing char pointer to type to
Okay,
parameter
this is
type
the char
const.
pointer, not the const char pointer. That's the thing. So, uh,
It does not complain.
I hope we never try to free this then, I think. But yeah.
We probably will. It's fine.
Let's see.
Okay. So should I just try and compile? Expected new line after instruction.
Actually, that might work.
Oh, we have to eat the new line as a token?
Yes. You need to yeet the label.
Yeet the label. That makes a lot of sense.
Yeah.
Unknown temporary 2. Okay.
Interesting.
Let's take
Take a
code.io.
look.
That's fair.
The numbering off. Interesting. Oh, that's just wrong.
Yeah.
I see. Because I see what the problem is. Go to
Set.
in intermediate representation.c
Set
and
IDs.
make sure that the parameter indices start at 1, not at 0. It's in IR function.
IR
Where we
function.
create the
Parameter. Yeah. Okay.
it has to start at 1, not a 0.
1.
Let me show. Can
Not
you just
there.
set that to 1? I think you can.
I plus 1.
No, this has to be I minus 1 because the parameter indices start at 0, but the index, the like temporary name has to start at 1. So I
So-
think it's that. No.
Ah.
Okay, if you do I
Yep.
equals 0, then
Okay.
it's
Yep.
just okay. For I equals 1, it immediate is I minus 1 and ID is 1. Is I. Yeah, that's right, I think.
Why are you mad? Suspicious usage of. Oh, you can't see this on stream.
I can see it. Also, I can see. I'm not looking at the stream, right?
Suspicious usage of size
All
A.
that.
Size
Ignore
of
that.
A. Pointer
That's
to
correct.
aggregate?
You don't do that, so that's why.
I'm gonna. Yeah. It's good. It's fine.
Macro black magic.
Oh, I have to regenerate the IR.
Regenerate the- Yeah.
Okay, hold on. So I went here, and I made greatest common denominator into IR. Oh no. Parameter index out of bounds. Uh-oh.
Parameter index out of bounds? Really? What?
Where is that?
Where is that? Yes. Where's that check? Hold on. Parameter index out of bounds.
It's an assertion. Index is less than context function.
Parameter index out of bounds is in IR intermediate percent. Let's see. Index.
Does that work?
Interesting. That's very weird.
Parameter index out of. So IR parameter is being passed an index. What's IR parameter? When is that being
getting
called?
from? IR parameter. Only in like 2 places, and it's past the param count. And the param count starts at 0. That's right.
Nowhere apparently. That's in
And it
dot
also
dot.
starts at 0 here, so that's also right.
Huh.
That's weird. I honestly don't know
So-
what it's on about.
Let's think about what I just did. Oh.
You messed something up in IR function, maybe.
I did. Okay. Yeah.
Oh, well, yeah, less than or equal.
I was like,
Ah.
I know what I did now.
Okay, now I generated the code. Let's take a look and see if that's actually correct. That looks better.
Yes. That does look better. Okay. We're good. We're good. It took me a second. But yes, the parameters now have the proper numbers. So now, rename this once again. into code.ir, right? And then from code.ir, we
Take a
then
look at
compile
that.
that.
Yeah.
Okay, redefinition of temporary 2.
Interesting. Where? Online, that's not right. The column is not right, I think.
4.
Look at the column number in email and the error.
Yeah, that may be incorrect. I think it may be hard to go there.
Store into 2 GCC. Because it's no longer okay. Damn it, we don't have GCD Euclid.
Yes, because there's no global variables.
That's a problem.
So how would, in the parser, we'd have to have some way for global variables first?
No, the problem is if you go back to the if you look at
Assembly.
the output, it says wait, see right here. It says
Oh.
okay. It says defun L0. That's the problem, and not defun GCD Euclid.
Yeah,
The
that is a
problem is
problem.
that we handle that in a weird way right now. That's the problem.
I don't even know how we handle it right now. Where does the function name go?
Not at all. We don't have a function name because everything is just a lambda. We don't have named functions.
That's
Everything is a
right, they're
lambda.
just variables.
Yeah, which is a bit of a problem because normally that's not how it works.
Right. So first class functions really make things difficult.
Yeah,
But we have variable names.
Yeah, but the thing is,
But
they're
we omit
reassignable.
lambdas.
They're reassignable. You can reassign a global variable that's a function type. So unless you make it to where functions declared with the new abbreviated syntax are like const, they can't be reassigned. If you do that, then we can just give them
Oh.
the proper name.
Yes. We had something like this before. Okay, so that's good to know that the IR is working. It's just that the stupid way.
It does work, but there's some stupid problems right now. Yeah.
But it's because of not the IR parser or anything like that. It's because of how the current compiler handles function names.
Oh, and there's also another problem. If you look at if you look at the top,
Yes.
the first parameter is 2, but the first temporary is also 2. So we need to add 1 to that in whenever we emit that. That's in the IR backend.
Okay,
We
so
need
there
to
is
start
a
with
small
parameter
problem.
count plus 1.
Param. Okay, it's not
I
param.
should
Function.
say param count somewhere like it's in
It's got to be somewhere here.
Somewhere.
Is it just using instruction?
Okay. In that case, go to the where we assign the IDs. We need to do it there. That's in
intermediate. Yeah. So set IDs.
Yeah, it's now set function IDs, but I think, but yeah, set
Yes.
function IDs. Yeah, it's the function directly above it. In there, we need to do parameter size plus 1.
Yes.
At the top, up a bit.
Thank you. I was like, so yeah, we start assigning instruction IDs not at the amount of parameters because parameters start at 1 and
from 0 to n-1.
Mm-hmm. So we're 1 based everywhere now.
Yes.
Okay, that's still
except that the parameter indices internal are still the first one is still 0.
That's right. So now we're gonna do it again.
That looks better. We need to rename L0 again. But yeah.
Yep. So we're gonna copy code.s into code.ir. Do it. We're going to go to code.ir, change our little bippity boppity. What is happening? What is build?
Oh, did I call it build mode in accident? That could be the case because I called it the build mode. Yeah, it might just be called that. If you go to like
my scratch buffer.
Scratch buffer. Does it say build anywhere?
No, it's in the editor. That was the BNF mode. I'm all over the place today.
Oh, NIR mode. Does it say build? It does say build. Yeah, that's like where it says that. Yeah, there.
Let's go with unir.
And also the doc string is also wrong.
Oh yeah. For editing, the language that FunCompiler compiles intermediate representation. We're gonna get so many warnings about that being longer than 80 characters. I'm sorry. It should just say IR. Okay, then this needs to be GCD Euclid.
Mm-hmm.
And then do we jump to L0 down here?
Careful at the. We need to replace all uses of L0 with, like, at the top of main. There's add L0. That
Okay,
would
is
do.
that all? That's the only one. Okay. GCD.
Actually, the thing is, never mind. This won't work.
Yeah, because
It was correct before, but do you realize what's wrong here?
yes, we can't give two names to a function, but we need to.
That's no. That's not even the problem. It does a store to GCD Euclid. Do you know what it means?
Oh, we're gonna try and write to it.
Yes,
But there's no
we don't have
global.
variables in the IR just yet.
We'll get there. We'll get there. Simple math.
So
Simple math. We're gonna
So do me a
pivot.
favor and compile it with optimizations because that gets rid of this entire problem.
That's a good point. So-
Because the problem right now is that we're trying to compile
Oh,
IR that we need variables
There
in
we
the
go.
IR. We don't have that right now, so it won't work. So
That
yeah,
should
that
work.
looks better.
yeah, that should work.
Oh, and fun fact, by the way, because the function is called L0, but the first block we emit will also be called L0. So we have a namespace conflict here. So what it does is it strips any leading dots from function names.
Oh no.
So the function is going to be called L0 without the dot, and it's going to have a name. The first label in the function is .L0.
I like it. I like it. Vimy says,
That
huzzah!
will duplicate label names because they're going to be a relative for once, because labels start with a dot are relative, but that only works if you have an absolute label that they can be relative to.
Yes, yes. So now, okay, is this gonna work? Okay, I need to save this. That's why I'm freaking out. So now we save the optimized IR. Oh man. Yep, I can't use my keyboard. Hold on. And then we can just call it on code.ir. Oh,
Which, look at that.
it works.
As you can see, it transformed it to L0.
Vimy says, not sure who's on Discord, but huzzah to you too. And then Vimy has some sloth emojis. What are those? Oh, is that a hamster? With hype
That,
hands and
I'm not
hearts?
sure what it is. It's something.
It's beautiful. I like it. It's very symbolic. It's derivative. I see a slight problem. Oh no, here's the .L0 namespace thing.
Yeah.
I was
see?
like, wait a second.
Yeah. See?
That's very good.
I had that problem too. And I got some weird error and I was like, what's going on? And then I saw there was L0 in there twice and it was like, yeah, that's a problem. So there's now code in the parser that strips leading dots from function names because of that. And that's also why you have to do this like resolve function name thing. That's so that it checks that the function exists and so that it removes the leading dot.
It works. It works. I changed it. This is the
okay.
original.
I was
like,
say, don't scare me like that.
I changed it to 80. I was proving you can change the IR itself and have it update.
Yeah. What you can also do is add leaf in the fun L0. So before the brace, just write leaf.
Yeah. And
That's
then,
a leaf
it
function.
worked. What is a leaf? So how does that change the outputted code? Does it at all?
It should.
Windows makes this
Interesting.
hard.
Oh, you're not compiling with optimizations, are you?
Oh, not this one. That's right.
You also need to compile like that with optimization.
So we compile optimized IR and then optimize the optimized IR.
Yeah.
I like it. I like it. Oh yeah. Oh wow.
So what it does is a leaf function is a function that calls no other functions.
Which means what optimizations can be? So RBP, there's no stack frame.
Yes, there's a stack frame basically. That's it.
That's beautiful. Okay. Which in Windows matters a lot because it's like
horrible.
half the size. Windows is horrible.
Yep.
And then we can run this, of course, and it fails with. the
So
proper
eventually
code.
what it should do, the optimizer should just realize that it's a leaf function and add that, but it's not implemented yet. So
Yeah, we'll get there.
Leaf is implemented in the backend, but not in the optimizer.
Oh, Vimy says compile the compiler to compile optimized optimizer to then optimize compile results.
Yeah, something like that.
Something like that. Skoga, thank you so much for the follow.
And it works with like it should work with pointers and everything. I mean, the thing is, as soon as you have global variables, the compiling to IR step will fail. I will say that because the IR doesn't
Okay.
have global variables, but you can
Well,
find something else that doesn't use global variables.
let's take a look at some examples and find ones without global variables. And what I think would be interesting is if we take a look at the new editor mode
Oh,
and some new syntax highlighting. How about that?
how about that?
So I wrote a tree sitter parser for the language. If anybody doesn't know, what Vimy asks, "What are you doing today, guys?"
Um,
Compiler. We're
yes.
implementing while loops. Let's go with that. That's the high level of
Oh,
today.
that's why someone. Ah, now I know why someone asked whether you're writing a C compiler because you put pure C compiler from scratch in the title. That's why someone was asking if you were writing a C compiler.
Did I put that in the title?
You wrote pure C compiler from
I
scratch,
wrote
yes.
the word C compiler in the title. Oh my
Yes,
god,
you
I
have a
did.
C compiler there.
I'm an idiot. This is why I asked you for the title. This is your fault. You
I,
didn't give me a title.
I told you I'm bad at naming things.
Okay, I'm just gonna call it compiler from scratch for fun. That's better.
Yeah,
That's fine. Less
you can
confusing.
say impure C. That works.
That's true. Okay, it's happening. In PRC. It's in all caps at the end.
Of course it is.
It's got to have that real, vibe to it. Vimy, please stop. My brain is too 420 for that. Okay, so we're gonna load the TypeScript editor mode for Emacs, and then we're just gonna open an example and load up the new tree sitter mode. So let's open pointers, right? Hopefully there's no global variables other than functions, right?
Hopefully there's no global variables. Yeah, look at the very bottom.
Pog. So this is the new
Nice.
syntax highlighting mode. It's
You really like the Microsoft color theme, I see. Or is
I
that just the default?
I write all of this theme is my own. It's in .emacs. It's in my emacs.files if you go there.
I see.
But it's the Lenser theme. These are the colors. I just choose them. So if it looks like Microsoft, it's probably because
Yeah, it's VS Code and Visual Studio also has like the exact same yellow for functions and pretty much the exact same blue for types, or at least like keywords, primitive types.
see to me this is just always the type color. If types
Yeah,
aren't this blue, it like breaks my brain.
yeah. For me, they're like sign because I use Monokai, but and
Nice.
that sign, that not sign, the green that you have going on there,
One
that's
of
the
mine.
color that's used for enumerators.
I see. It is. I do. I remember that. Vimy says, "Do I have to write my own Vim syntax highlighting for that?" Well, guess what? Guess what, Vimy? There's an entire Vim plugin. Dun dun for syntax highlighting. It's already there. You don't have to write it. Just use it. It's here. I don't know how to use it with like package managers, but you can like manually install it just by putting it in your runtime. Vimy says, and then a heart. Aw. Thanks, Vimy. For example, one thing that's amazing about this new tree sitter mode is tree sit explore. If you don't if you don't know what this is, you're about to have your mind blown. This is an AST, a live AST. Are you ready? Let's highlight the name. Look, the name is an identifier. It's highlighted. Oh, and then you can also go backwards. There's a lambda here, which has a type of function. What's the type? Oh, look, it highlights integer. Isn't that beautiful? So you can just explore. You can press tab to go between things. Here's the lambda. Here's the type of the lambda. Here's the return type of the lambda. Here's the body of the lambda. Here's the first declaration, which has a name, a primitive, a primitive type integer, and a number 0. Isn't this amazing? This is like,
Very cool.
it's like the parser while you're editing it. And you know what the craziest thing is? Are you ready? Look at it. It updates dynamically. It's so cool.
Nice.
I could look at this all day. I know it's small, but like, oh, C is a variable. C colon, we don't know what that is. It's a declaration with an error. And then we go, okay, then make a pointer to an integer. You can make a pointer to a primitive integer. Oh,
Mm.
and this is also, this tree right here is what's being used to actually syntax highlight. And if we take a look at it, we'll take a small look at the queries because it's rather cool. You can literally write the exact query, scheme query. Yes, you write scheme in Emacs Lisp. It's true. These are scheme queries. That's hard to say.
Scheme queries, yeah.
And each of these scheme queries is just literally within a quasi-quoted list, and you can do things like
Oh yeah.
Vimy says
What?
squeries.
Square brackets. That's how you know that it's scheme.
It's right. That's right.
Yeah, that's how you know it's scheme.
So, and each of these features you can enable and disable in different levels of highlighting. So right now it's at level 3, which includes all of these. But you can go down to syntax level 2 and won't highlight numbers, operators, or punctuations, which means that these features will not be enabled in the syntax highlighting.
Interesting.
It's cool. And you can also do individual features yourself if you don't like this list. I still don't know why the variable query is broken. We'll get there. But yeah, this is how, for example, types are highlighted. And when you call something, then you can see that it's highlighted as a function name, and same as the name of a function statement. Let's go back here. But yeah, so I just thought that was ultimately cool. Vimy says we need that in Vim. Just no eLisp, please.
I mean, Vim has tree setter.
Yeah, Vim has tree sitter. It doesn't have this explore mode. It does have tree sitter syntax highlighting, where you can make queries like that. And oh, I just realized you can. It works with regions. Oh,
That's nice.
okay. I'm geeking out a little bit. I spent like 2 days writing it, and then never used it. This is the first time. But this will help a lot in both understanding what is being parsed and just syntax highlighting, because as you can see, when you have a pointer type, there's an @ symbol. And for example, right here, it's highlighted blue. But when you have a dereference, you have that same @ symbol highlighted a different color because it is now a dereference and it's an operator. Vimy says, 2 days not wasted. Oh, thanks, Vimy. I appreciate it. Oh, another thing that I should probably show off. You can... Oh, I gotta bring you guys with me. Is that you can use it from the... Here, this...
That's cool.
We're not going to be able to build it because Emacs is using the file right now. But you can literally highlight from the terminal. And so if you have a source file, all you need is a terminal and you can highlight
That's
any
cool.
example and just look at it.
You know how I usually do that?
That's really
By
cool.
hand. I usually do that by hand when I need to like syntax highlight a block of code.
Yeah, Tree Sitter it does it. It's amazing. And you can also
Yeah.
take a look at the parse output if you really want
Nice.
to. With all that.
As like an S expression, of course it is.
Yeah, it's a scheme S expression with
It's a
ranges.
scheme expression, yep.
And then you could also like use another program to just call Tree Sitter like this, and then use this for anything, like editing the file or stuff like that.
Or I suppose a language server or something like that.
That's right. There's also TreeSit inspect mode built in now. So you can, it's not perfect in my custom mode line. It'll look better in the default. But you can see that the S expression for whatever you're currently at just gets put in the corner. So you see this is an
Interesting.
address of variable or an expression assignment. It's cool. It sounds like you just fell out of your chair.
No, it's just, this chair is like, it's old and I need a new one.
Again, donate so we can get Sir Aid a new chair. That's the first thing. I'm going to make a Patreon and just say Sir Aid's chair. That's the first goal.
You have a Patreon, you know.
You do?
Yeah.
Link it. Literally link it. I'm going to put it in the description of this video.
Fine.
Because I made
fine.
donate jokes like 3 times. People are actually going to do it.
Oh,
You deserve
God.
it.
Let's see. I will say I don't really have anything on there except like one post about a URL parser or something like that. Or no, a UTF-8 decoder.
Oh, we don't worry about fulfilling promises. That's not something we worry about around here. You can make any promises you want.
Just gonna put the link here.
Look at that. That does look a lot like Visual Studio. Now that you said that, I'm gonna have to
Really?
change it. I'm gonna have to change it. Ugh, my brain.
I mean, you could just use the best color theme ever, which is Monokai, or Monokai Pro actually. So yeah,
I don't have
which is what I
my.
use coincidentally.
No, okay. Modus Vivendi is pretty good.
Interesting. It's a bit too black for me, the background, but
It's
and also-
AAA WCG contrast. Do you
I
know
see
like the
it.
contrast rating?
No, not really. I mean, it rings a bell, but I can tell that there's a lot of contrast going on.
Yeah.
It's like-
So there are 3 different levels of contrast for the web standard for like websites. So if you have a foreground and a background, you can actually calculate the contrast between them with the special number. And if that special number is over like 7, then it's AAA rated, and that's what this is for
Interesting.
accessibility. But like on a laptop screen, this is amazing. And on a laptop screen in the day, this is going to be bright. This is perfect.
Oh God.
I know.
Yeah,
It's
yeah.
bright.
Oh,
Okay, back to. Oh no!
okay. Oh no.
Oh no!
Oh no, you broke it.
I did break it. How did I break it? I just loaded a new theme.
Just restart Emacs. That always works.
Okay, I'm gonna first. Why is everything is the wrong color? It's terrifying. Okay, we're ditching. Goodbye,
Save
Emacs.
versus kill Emacs. Interesting. Didn't know that was a thing.
Yeah, I just type save-e, SAV-e, and it just exits Emacs, saves all the buffers, and it asks you if you have modified buffers that you'd like to save.
I just do Control X, Control C, and it prompts me anyway. So.
Uh-oh.
Did you? You need to restart your Emacs server. Your Emacs server to that.
Yeah.
Yeah.
Okay, there we go. We're in. It didn't even... Okay. We may not be in, but the theme is fixed, so we're good.
Yeah. Well, that's something.
We may not have loaded the... Oh, we're in the... Okay, sorry. Just install Vim. I mean, we can use Vim.
Oh, C-line.
It didn't work. It didn't work. Oh, I broke it. Recording. What did I just do?
Recording?
I somehow... It said recording in Vim.
Oh yeah, that's a macro probably.
Load file. I pressed something crazy. So let's load UNTS mode again. You know, let's start writing a while example.
All right.
So we're gonna have a condition, which is like an integer, right?
Yeah, probably.
And let's just say it like equals 10. And then, oh, you know, this will be a fun one. It's kind of testing a lot of things out at once, but it'll be fine.
Oh God.
It'll be fine.
You know, the
Interesting.
IR can handle external declarations. In theory, it's not implemented yet. It's a to-do right now.
Why are you so not working? Oh, I forget. So this is the crazy thing about syntax aware, like context aware syntax highlighting. While by itself is not a keyword, it's only a keyword when it then has a condition and a body and an expression. Oh wait, no,
I
it didn't
see.
work.
Maybe you haven't added while yet because that wasn't a thing before.
Oh, that's a good point. Did I not? Is it?
Just copy whatever the thing for if is and remove the else. It's that
Yeah.
easy.
While. It should just be a keyword, and everything in the grammar should... I think we should already have while in the grammar. I added a lot of things in the grammar.
So, yeah, there's a rule for if somewhere.
There we go.
You can just copy that and remove the else part, and that then replace if with while, and that's it.
Yes. Oh, I don't... Okay, so in the TS mode, I would have to make a query for the statement external. So, oh, that's why we don't do it. An external statement isn't necessarily a function name.
Interesting.
So we have to match a function type. There's definitely a query we can write to do this. It's just going to be rough. Okay, what are we doing?
A. Where's
A.
A?
I don't know. It was like, okay, so we should probably just call put char
Yeah.
with condition in it. Why not?
Let's print the new line, sure.
Yeah.
Because 10 is a new line. Okay, let's print non-printable characters, sure.
Oh, here.
Oh yeah, you can add 40. Yeah, that.
This should print 9 through 0. Right?
48 plus 10 is what is 58. Hold on. Man ASCII.
Man, ASCII.
Man ASCII.
It's like
thing. Decimal 48. I'm looking at octal. Decimal 48 is 0, and decimal 58 is a colon.
So yeah, so it'll start at 9 and then go, yeah, we're good.
Oh yeah, if it is that way, we'll start at 9. Yeah, that works.
We're good. First time chat from a new viewer. How's it going? Handry C. Handrick? I don't know how to read. It is Emacs? It is Emacs.
It is Emacs.
It is always Emacs. Did you see that Asm Blocks game that I posted in the Discord?
I saw it.
That's
saw
so
it.
cool. I love TIS 100. I played the crap out of that game.
Oh,
So I'm probably going to play Asm Blocks like all the way through. They're fun.
I see.
I love Lisp too, so it'll work out. So this looks like it should work, right?
Well, the syntax looks like it should something that it looks like something that makes sense. It won't work right now because it's not implemented, but
That.
I suppose the syntax makes sense if we're going for that. Yeah.
Okay, so we need to write our little compile command, which is just going to build, clean first, and run it on this new example. And then we just follow the problems, right?
Mm-hmm.
Invalid
we won't have to add any, just front end.
Okay, I forgot my own syntax. That's okay. This doesn't go here. This goes
Oh
here.
God.
Look,
Brilliant.
then we get typing properly. It wasn't.
Oh,
Yeah,
look at that.
it wasn't proper. I was wondering why this wasn't. I didn't mention it. I was like, uh-oh.
Wow.
Okay. So now put char is
Ah.
properly external.
Good, that's good.
There we go.
The thing about this is you only have to do something in the front end. Like this is just going to be add an AST node. Like the passing is the same as for
It's going
if.
to
You
take
can
5 minutes.
Copy the code that you have for if,
Exactly. Yeah.
remove the else part.
I-
And then
I'm-
obviously the II is a bit more complicated, but in the parser it's easy.
So instead of removing the else part, I think we should remove the then part and use the else.
What?
Don't worry, you'll see. You'll see.
Uh,
That's just how this parser's built. It's fine.
Oh God.
So this is
Alright.
the while. Okay. Yeah. So
Jesus.
this list right here is when we have an unknown symbol.
Okay.
We've already said, okay, is this symbol a type? Is it an integer? It's nothing. It's some symbol. It's either a variable access or a something crazy like an array or you know,
Okay.
right? And in this state, we check, okay, if there's an at, it's probably a dereference of something next. So call it a dereference
I see what this is. Yeah.
and then begin to work on the child node.
God, there's working result. Oh no.
Yes, we are here.
Oh no, we're using working result. Oh no.
So if is slightly more complicated in that there's an if node, but then there's a condition node, which is similar to this child node here in the dereference or address of. And this condition is what we're actually going to parse into next.
Yeah,
Hence-
that makes sense.
Working result, condition expression, continue. But in between then, there's this context stuff and stack stuff, because yes, parsing contexts and parsing stacks are different things. Sadly.
Of course. Yeah.
Yeah, that makes total sense, right? I honestly don't know why this is the case. I'm pretty sure every time we create a context, we create a stack. I'm not even joking. Like, I'm pretty sure they're the same thing. Yeah. So when we say stack, where is it? When do we handle the exiting of the stack? Oh, it's up and handle. Okay, we'll get there.
Yeah.
Anyway, for while, we're just gonna rename this to while.
That's
Oh,
the
we
most
can't.
important part, yes.
Can we go to while node? Perfect.
Yeah, just while is not going to work. That's always the problem when you're writing compilers.
Yes.
Like, I want to name this thing if. Doesn't work.
So, interestingly enough, we're going to need a new AST node type,
Mm-hmm.
which means a whole lot of things are going to break as soon as we add it.
I hope so.
Otherwise, there's no static asserts. And
Yeah,
it's a
I
little
mean,
scary.
the static asserts were in my IR branch, but he didn't merge that. So now there's a bunch of places where there would have been static asserts, but now there aren't. So
So,
we can add them whenever we get to that, I suppose. Because now we have static assert.
how do I name this better? Handrick
Uh,
says, okay, go ahead.
I mean, how do you name this? Condition and like this. I mean, that's fine, I think.
Well, the thing is, there's only going to be one child, but after the condition expression, we're going to have like all of the children. So it's going to have X children or N children, however long the expression list is.
You can also just say contains an expression list.
Condition at the beginning. Genius.
Something like that.
Genius. Okay, that's good. Node type while, and now everything should break. Yep. Parser.c line 160.
Okay, assert should fail. That's okay. We can immediately replace that with a static assert.
Perfect. Okay.
I would actually need to handle that in here.
I don't think we do.
Oh, really? Is it okay? It doesn't do anything. All
So
right.
here's what we're going to do. We're going to say we have panic, right?
Okay, yeah, that makes sense.
And we're just going to panic and say unhandled AST node comparison. When are we even doing this? Oh no. Unhandled. Because if isn't handled here.
Yeah. So
Okay. Of type. So I guess we're really relying on type comparisons for all those ifs and everything.
probably.
So an if compared to an if would be equal, which would be
Yeah.
well,
If it contains the same sort of expressions, yeah.
yeah, unhandled AST node comparison of type bleh, which
Yeah.
is a type,
It's that.
and then return
So-
not equal.
The most annoying thing always that C and C++ don't have an enum to string built in.
That's so annoying. You are correct.
I always end up writing my enums as macros and then just generating an enum to string from them.
We have a beautiful error message. Could not handle stack operator, which is exactly what we need to do. Remember that stack operator of while condition? We didn't handle
Yes.
it.
I see it. Yeah.
So now we need to go. Yeah. Now you're getting the structure.
Basically a pass table, I see.
Yeah. Yeah, exactly.
That's what this is. That's what the symbols are your pass states. Okay, interesting.
Yeah, the
these-
the symbols are the parse state. You have it exactly right.
Okay.
It's a serializable state machine.
Interesting.
I know.
I would make an enum, but you do you.
You're correct. It should be an enum. Instead of doing all these random string compares everywhere. Oh, I missed a chat message. Handrick says, do you think Emacs is better than Vim? Uh-oh. Do you think that if I adapt, I will be more productive? That's a great
God.
question. Handrick followed 7 minutes ago. I really appreciate that. Thank you for tuning in and sticking around. We're up to 220. I have so many followers today. This is incredible.
I mean, regarding the Emacs versus Vim thing, there's a brilliant quote from Andrei Alexandrescu, also a famous C++ programmer. He said, when asked about this, he said, I mean, all of this is kind of silly. I mean, let's come on, we're all adults. Of course, Emacs is the best.
Hey, I get to ban someone.
Oh, God.
How do I do this? I always forget how to do it.
Right click, I think, or something.
Yeah, okay. The hammer. That was fun.
Yeet.
Advertisements, not allowed. And I don't want questions about advertisements. No, thank you. I don't do boosting. I earn my level, okay? They joined pasted that message and followed all at
Yeah,
once.
in that case, yeet.
It's a bot.
That's also an option. Yeah, but what we also do on the Agmashwa server, where I'm one of the admins, is if someone just joined and immediately starts causing trouble, we just ban them. Because like if you just start and the first thing you do is pick a fight, then yeah, no, that's not going to end well. There's no point in trying that.
That's a really good rule to have, is like you gain leniency as time goes on.
Yeah.
And as you put more effort into the community and making it a positive place.
Pretty much, yeah.
So it's like a karma-based system. Like if you immediately join, you have 0 karma. And if you make it go negative...
we also have what a lot of other servers have, is we have rules depending on how many messages you've sent. So... not rules, roles. So...
That's a good idea,
yeah. On there longer.
That's a good idea if we ever implement a bot. Oh, as far as Handrick, question, do you think that if I adapt, I will be more productive? No.
At first, not. Definitely not.
Yeah, it's going to be months before you reach an equal level of productivity, and like, if you're already productive in another IDE.
Yeah.
From scratch, it's still going to be months, but that's how it is with every IDE.
That is true.
So we need to
also be warned, if you use Emacs, you're going to be closing a lot of windows accidentally all the time.
Yeah, the keybinds really screw you.
The keybinds, yeah. If I try to work with anything else, it's just screwed. Especially if I'm like, if the person has a different keyboard layout too, then it's like,
yeah.
Oh dear.
And they usually do, because we both have non-normal keyboard layouts.
I mean, most of the keys are what it's supposed to be. Like the semicolon is where it's supposed to be, and all of that. So
it's mostly okay.
It's mostly okay, yeah. The thing is, like, I have slash and backslash on the same key.
How does that work?
So slash is just, and the shift state of that is backslash.
Okay, so for me, I have the question mark there.
Yeah, the question mark is where is that? It's, I think, on the number 2. That's shift 2 for me. And the quotation marks are like the double quote is the shift state of the single quote, because it makes sense.
That does make sense. I have that as well.
And something is, my slash used to be somewhere else, but then I realized there's a reason. I'm not sure if that's why it is, but if it isn't, it's sure as hell convenient. But the fact that dot and slash are next to each other and in that order makes sense. Like,
that's like Unix heaven.
Yeah, it's like, okay, that makes sense. It's easy to type that way.
These can all be else ifs, can't they? They can definitely all be else ifs. That would make things easier.
I usually don't do else if I have a return at the end, because that's like, you don't need the extra word. Again, I don't like writing too much code.
It's true.
More than I have to. So I usually just do this too. If I have ifs that return or continue something, then you don't need the else, really.
Yeah, this is perfect. We literally, all this code is written. we don't even do anything. We just create a wild body.
Same syntax as if, except you don't have the else clause.
Yeah. And it repeats. So the code gen is going to be different. But this is actually going to be the same.
The parsing, it's the same with the parser, basically. The code gen is going to be interesting.
2 blocks, right? 2 blocks? 4 blocks.
Hold on, let me think. N blocks, because the body can be n, but if you count the body as 1, then that's...
2 with
4 blocks you have to deal with in total, I think. Okay. 1, 2, 3, 4... Yeah.
So does this work? I have to go back to uncompiler. And then spit out the AST if you can make it, please. And now it's saying print node must handle all node types. That's important. We can also make that a static assert.
Yeah.
If it's not already. Oh, I typed an R.
I mean, it's not. Otherwise, it would have been a compiler and not this.
True. I can never tell because I compile and then run all in one. Why are you mad?
You can tell by the formatting of the error, I suppose.
That's a good point. That's cool. Static assert says, hey, it's wrong. ClangD tells you.
Yeah, it does that. Yeah, wow. That's pretty useful.
Oh, wow. Okay, how do we do a node? It's a node. I can't speak.
Yeah.
While. That was tough. That was rough.
Oh yeah. Really
Hey.
complicated code here.
Uh-oh. Oh, okay.
Oh no.
Okay, everything's fine. I was like, developer warning, oh no.
Oh,
So we have two things
Also-
happening. Go ahead.
Just wanted to say for the assertions, we could also use the diagnostics thing with like an internal compiler error for an assertion failure. That was the
Oh,
plan.
That's a
Some
great
point we should-
idea.
Because it is an internal compiler error. That's a failed assertion. Just wanted to mention that because I just saw that and that reminded me of that.
That would be awesome. And then it's going to be way more consistent too. The user won't be like, what is this? I have to understand this format now.
Yeah.
Hopefully
But if
the
it looks
user
just
never
like
sees
compiler
these.
error, it makes more sense.
Yes. So we don't handle it in type check expression, which is probably a big deal. So let's go handle it in the type checker. What do we do?
And by handling it, do you mean actually handle it or putting in a to do?
I mean actually handling it.
Okay.
It's not going to be that hard, right? It's going to be like the if.
It shouldn't be.
Yeah, we'll just copy the if.
Sorta, yeah.
We're going to do this.
How do you type check a while? You don't basically just type check everything in it because it doesn't have a return value, so.
The condition.
Oh,
But
the
yeah.
condition, I suppose, yeah, the condition. But that's about it.
Yep. Because we have integer conditionals is kind of how we implement things.
Yeah, yeah.
So we have all of if, and
Okay.
now we have all of if twice. I'm sorry. I'm going to close that. So we enter the while body context, but no, while condition context.
Okay.
Does that make sense? No, there's no context yet to enter.
I'm not sure, maybe it does.
So when do we emit expressions? We type check the then expressions, which is all going to be... Okay, hold on.
Where do you type check the condition?
That's what I'm wondering.
Are you type checking the condition?
We might not type check the... Okay, hold on. We're not type checking it at all. It's literally not type checked.
Brilliant.
Oh no.
Let's copy the code for the if because we want that one part where it type checks the condition, and that's the one part that it doesn't handle. That's brilliant.
Oh
course.
no. Okay. Okay.
Why would you ever type check the condition? I mean,
Let's to do. Let's just add that in. To do. Type check the condition, maybe.
actually, you can't use actual to do like macro because it will abort the thing. But yeah.
Yes. Okay.
Okay, well, I really want to find some... Oh, hold on, I'm gonna do something real quick. Let's go into the source code. Come on, source. And let's do a grep RNI for to do and fix me.
Context.
So we have 59 to-dos apparently, and 15 fix me's.
That's a lot.
Ah.
That is a lot. And that doesn't include the one I just wrote.
And that also only includes to-do comments. Like if we search for the to-do macro,
Just gonna have to do
there's
something
21
similar.
of those as well.
Oh god. So there's quite a bit to do. Accepting PRs, I'll just mention that now. Enter while context.
And then basically just delete all of that, I think. Oh, actually, no, you need to type check the body, that's true, but yeah.
Eat while context. So the body context is created by the while keyword, the while node. Because, see, the stuff like that doesn't show on stream, which I usually don't mention it. But then now I know you can see it. My face went all red. I was like, oh no.
Okay.
For those that don't know on the stream, I just closed out, I minimized Emacs by hitting Control Z.
Max. God.
So we create the parsing context with the actual while keyword. We don't wait until parsing the while condition to then create the context here, because if there's an empty body, then we would have to create the context and then yeet the context. And I feel
see.
like we're going to need a context no matter what. Otherwise, it's a syntax error because there's
I
no
see.
body. There's no like while condition and then that's a thing, right? Okay. I mean, there is in C, but we're going to ignore that. So then it just creates a while body if we need to parse one, which will parse X children into the while node, the stack result. And all of the variable declarations will be within the while context. I'm just talking through this so I don't screw it up. So this should all be fine.
Yeah, just you're probably just gonna add another to do, like with the if.
Yeah.
For now, that's
I mean,
not that
all we have to do is
important.
ensure it's a... It's true. Type check condition, maybe?
Not like that's the point of statically typed languages, right?
Yeah, who needs type checking in a statically typed language? It's really overrated anyway.
Yeah, it's really overrated. That's definitely the reason why. It's not like anyone programs from TypeScript, right? It's funny because TypeScript is like the sign that people realize that statically typed languages are actually not that bad and that they're better than dynamically typed languages, because otherwise TypeScript wouldn't exist. Like
They're definitely faster at runtime.
the faster, and that lead to fewer errors, because
The program
if you
knows
have
more about itself,
type errors that would be runtime errors are now compile time errors.
which is just beautiful. So we now have, we enter the while context, which is created by the parser when the while condition, while condition,
Yeah.
so by the while keyword. And when this happens, then there's a bunch of body expressions, which refers to
Children, next child, children.
while. So this is the while node. Hold on, we got to look at the AST. Hey, look, we're getting further.
What?
Okay, so the while node, this is children.
I see.
Next child is none. And then children is variable reassignment, aka the first thing in the
I
body.
see.
Okay, first body expression. And then we increment to next child, because next child of this reassignment is function call. Is that right? Yeah.
So
the function. Yeah.
It's like intersecting or nested linked lists.
Yeah, exactly correct.
I see.
Where the extension of the children linked list is stored as a different linked list in next child. So the first child is always in children, but the next child is always next. But then that one can also have children. 2 pointers, lots of linked lists. I don't know what format is this. I just came up with this. Is this like a data structure or a data programming pattern? I don't know what it's called.
What part of it? The lists or?
Yeah, like the doubly, where the first child is different from the extension. That way, you only need 2 pointers, and each node has both children, any amount of children. It's like a tree data type, but
yeah,
with
I think
2
that's
linked
called
lists.
usually.
It's a weird implementation of a tree. Okay.
Yeah, it is a tree. It's some sort of tree, probably. Yeah.
Okay. Well, we now handle while in the same way as if, so that's
good.
That's good. And then in codegen.c, there's an assert, which can again be a static assert. Where are we at? 228. I'm so slow. I'm sorry for making you sit through this.
I'm not particularly fussed at this either, so.
Awesome. Okay, so then we
Oh
have...
god, Rafe 0. Oh god.
So now, it's just going to be a small case of cogen, cogening a while.
Now, actually, I'll be right back.
Alrighty, I'll see you soon.
Be right back. Where the hell is the... Ah!
Sorry, it is gone. It's just us now. We're going to start cogening a while. Did I change it to 16? Hopefully I did. And when we codegen a while, let's just start thinking about this. We're going to write the same thing as we wrote for the if, because this little basic block diagram is very helpful. So we're going to write something like that. So we're going to start with the current block. Oh, I get to use artist mode for this. So if you don't know, Emacs is an OS. It's a text editor. Yeah, sometimes. Most of the time it's an OS. And a great example of that is its paint functionality. You can just go ahead and open up artist mode in any file. And then you can middle click. Here, you guys can't see this. You can middle click and get a little thing. You can select, for example, a rectangle. And then you can just draw rectangles in a very nice way. Isn't that nice? So we're going to have like an entry, like a current. We're going to have the while basic block, which contains the condition check, or condition generation. Yeah, the condition. And then a jump. And then this is where it kind of gets complicated. Whoops, yep. Okay. So then we can copy a bunch of that. Okay, we don't need... I screwed up a little bit. Artist mode is screwing me over. Hold on. Yes, delete all the white space. There we go. And now we can, oh, yep, draw a line. Don't draw a line. Please draw me a box. And this is going to be like a little join box down here. Why not? And then we're going to have like a body. Okay. This is so confusing to anyone just showing up. It's going to be like, what are you doing? Okay, so we have the current one. So this is like if we were just to insert an instruction with like IR immediate or anything like that. You can see, or IR shift left. That just inserts an instruction into the current basic block, which will be here, and that can be much simpler. Yeah? That is then connected through control flow. It jumps. This is what we're going to have to implement into the while condition. And this will do compute condition. Yeah. And then it will also do a jump conditional branch. Does that make sense? And then it will branch to either this basic block or this one down here. Yep, I know. Bump. Oops, don't do that. Do that. Yep. Something like that. Okay. Hear me out. And then, okay, I don't really want that coming out the top. So this is going to look horrible. I'm sorry. This is just what's happening when you do ASCII art this heavily. Okay. And then I think we can do, what is it, a comma? No, comma's for the top right. It's just a plus. Ooh, okay. I don't know what quail is, but I somehow just tried to activate it. This is like ASCII art to the max. Bunch of lines there. And then we're going to need this with a comma. There it is. I said top right earlier. I'm not the smartest, the sharpest tool in the shed. Okay, there we go. Confusing, but correct. So now, this is our while. This is our body. This can honestly be much smaller. And an important thing to note would be that this can go to any amount of basic blocks before going back. I can probably just delete that line. I wonder if we can fit it in here. I mean, then we could go turn. Okay, that's the way we're gonna go. Oops. And then there we go. That took me a little bit, huh? So Sarid is gone. Hopefully he's fine. Okay, so these are our basic blocks. This is what we're gonna now create. So we are going to have some IR blocks, which is the while conditional block, which is, what did we use for the if? Oh, we do, okay, yep, one sec. So we need IR block create, that's correct. Okay, and then when we create this block, we're also going to need a body block. So we have the while condition block, the while body block, and then we're going to also need the join block. And the body block, that sounds funny, body blocking. We're going to actually have to keep track of the last body block, which is the actual block at the bottom here that will do the jump, because that's quite important. Okay, so when we create these, they're not actually attached. So if we inserted instructions, they wouldn't properly be inserted. So what we have to do is call IR block attach. Can move you back into Emacs now. And we can attach into the current context this new block that we'd like to emit into. And this is going to be cogen context. And in the if, again, while is a lot like if, just a little different. Then we need to generate, well, unlike if, we need to then generate the condition expression and a branch conditional. So after attaching, we generate the condition, which is the first child, and then we need to branch conditionally on which condition? Expression children result, because result is filled by cogen expression to the instruction that it refers to. And then we need IR block, then block, and otherwise block. So if the condition is true, we would like to jump to the while body block. Otherwise, we'd like to jump out into the join block. So that branch conditional represents these two lines here. We can either jump to the body or to the join. So this is the false pathway and this is the true pathway. Okay, with that, we then need to start doing other things. So we need to attach the body block and then do stuff into there. If anyone has any questions, let me know. I'm kind of zooming through this, but I hope it's at least somewhat understandable. So then we need to just basically loop over the block and insert all of those instructions. I bet you there's a little thing we have here to do that. Like this. See, we enter the body block and then do this thing. So we're going to copy paste and then very carefully look at it to make sure we're not doing something dumb. So generate the while expression body. Here, we'll do it while. Gotta use upcase more. Fix me. This makes no sense. We dereference. Look right here, we dereference, and then we're checking if it's null, and then check if it's null. Like what? It doesn't make any sense. I don't know what this is about. Probably not even needed, right? Probably just yeet the if. We'll leave it just in case. But then we want to generate the expression body, which means we go, again, this is the same as in the type checker. We know this is correct. Children, next child, children, to get to the first expression. And then cogen expression. Yeah, and then we just cogen the expression and then iterate it as on to the next child, which should work perfectly, given everything that's been set up with the while body block and everything. From there, we need to calculate the last block. So we need the while body block. Yeah, here's the thing. While may have a break in it. That's not implemented yet, but you can have while, right, A, and then you can break and it'll stop. But here's the thing. While statements are actually while expressions, so they actually return values. So when you do a break, you're actually going to have to like break 25. You're going to have to break with a value. Or it's just going to be the last value is going to be whatever's returned. But it'll probably be much like return, where it's just the last value before the break. Yeah? In any case, we need to keep track of the return type, which means that, where does this return type go? We need to keep track of it, not in here. Let's look at if. We need to make a phi, that's right. So, that's a good point. We should probably attach the join block. Okay, where are we at? So we have a conditional branch after a conditional a computation of the conditional. We branch on it. And this is all in the while condition block. So so we're going to have to make an IR branch to the while condition block is the first thing we're going to have to do. So we're going to have to do IR branch unconditional to the current. See, this is this right here that I'm missing. How about that? So now we branch into this. Hopefully Sir 8 is okay. We branch into this. From here, we conditionally branch after computing the condition. Yes. And then, here, this would make a little more sense like that. Hey!
All right, I'm back.
Awesome. I was
making myself a sandwich. How's it going?
That's an amazing idea. I should probably eat more often. I'm bad at that. I eat like 1 to 0 times a day.
Oh God.
I know, it's bad.
So where we at?
Here.
Current condition. Okay, you figured out the condition has to be in a separate block. That's good.
I did. I started thinking about if we have to jump back to it, it has to be a basic block.
Mm-hmm.
I don't know why body is so long. Don't worry about it. It seems like it'll work, right?
Yeah, I think that's about right.
Okay, so we're halfway through this. And we've created all of our blocks, our conditional block, our body block, and our join block. From the current, we do an unconditional branch to the condition block, right?
Yeah.
That's this thing.
Mm-hmm.
Then we attach the condition block, codegen the condition, and then codegen a conditional branch on that condition, where if it's true, we go to the body, and if it's false, we go to the join.
Makes sense.
This being called join doesn't make sense anymore, I realize. It's more like exit, but it's fine. We kept it from if. Then in the body block, we basically copied this from the if. We just generate all the expressions in the body block. And that's where we're at. So we've gone to here. So now we need to make this jump, right?
Mm-hmm.
But the jump has to be from the last basic block in the body.
Mm-hmm.
So I have to keep track of the last expression and then get its body. How do I do this?
Just like you said.
Okay, I did that correctly. I worry because I'm adding new things to code I copy and pasted. I'm like, why didn't we? Uh-oh. So we're going to have a node pointer last expression. And this doesn't need to go. I guess it does. Okay. And then last expression will equal expression. And then last expression, comp mode, please. Okay, there we go. Took a second. So it's going to have a result instruction, which is going to have a block, which is going to have it's going to have an instructions last, right? Isn't that how we do that now?
Yeah.
Okay. To do get last expression in body, not just last instruction. Is that reasonable to do?
I mean,
It doesn't really matter. It
the
shouldn't be
only
changed.
case you consider is if the last instruction is already a branch, then you don't need to emit the branch to the exit block.
Okay. Oh god. Okay. So
Actually, I need to check for that. So if the current block is closed, if the last block of the body is closed, you do not emit a branch to the exit. Otherwise, you'd have two branches, and that's like not going to work too well.
well, the last branch of the body never branches to the exit, right?
It
Am I
may.
incorrect? It may. But it only branches back.
Well, I suppose, and it could be unreachable or something, but that's only after you optimize it.
Okay.
So I think it's fine, actually.
Okay. Either way, this should be the phi argument that we need, right?
What do you mean? Oh,
Yeah, it's
Why do you need a phi?
well, while is a while expression naturally, not a while statement.
What the hell does it return? A while? What? Okay, that's weird. Okay,
What would it return?
nothing.
The last thing.
I mean, it.
I guess that wouldn't work, would it? Because then that would mean we have to preserve the last thing all the way through here.
Yeah.
So the only thing we could reasonably return would be the condition.
Yeah, typically
Which
loops are just
doesn't
void
make
expressions.
sense.
Like, even in languages where
Everything's an expression.
there's an expression, there's still void expressions. So I
Okay.
don't think it makes sense for a loop to have a return value.
So we have another statement. It's a while statement. Cool. That works. So while statements don't need to return a value, which means we don't actually have to do anything here. Do we need this now? I don't think we need this now.
You need to branch to the exit. Oh, never mind. It's in the condition.
So, does the body branch to the condition? The
Yeah, it
body
needs to
doesn't branch.
Condition.
So, okay.
Yeah.
So I still need this. No, I can just IR insert, right? Because this cogen expression should update cogen context.
Right.
Okay, we're good. So branch from this cogen context into the while cont block. And that
Okay,
would
the only
be
thing to consider is this will cause a problem if the last expression in the while loop is already a branch, like if you have an early return, which we at the moment don't. So it's not going to cause problems at the moment, but it may at some point.
if okay.
Typically with constructs like these, you only want to insert a branch if the block isn't already closed.
Cogen context block.
Because,
Done or closed?
done is only used in the backend. It should be. We don't have closed. Just check if there is a last instruction, and if there is, if it's a branch.
Instructions dot
You
last.
actually no, don't do that. There's IR block closed or something. There's a helper for that.
Okay. Yep,
Or
there is.
IR closed or something. I don't remember what it was.
Is branch?
Yeah, you go.
Oh, is closed. Okay, nice. That's perfect. And then we can just pass in. Where was it? This
The current
block.
block, I suppose. Yeah.
To do.
No, it's
I
not
guess-
to do actually.
We just don't do it.
Exactly.
So if not, IR is closed. Branch. Otherwise,
This took me a while to figure out when I was doing stuff in LVM.
yeah, that's a case I would never have thought of until you brought it up. That's pretty crazy.
And the same goes for the if, by the way. Everywhere where you insert a branch in the I in these constructs.
Uh-oh. There's some stuff to fix then. It's fine. Should we handle empty bodies in cogen?
Probably.
Which means we have to say... where is it? So if it's empty, what do we do?
Nothing.
Like we don't do literally nothing, right?
Just compute the condition and move on with your life, I suppose.
So instead of a conditional branch,
You don't even need any of that if the body is empty. Just emit the condition and keep going.
Yeah, so here's the condition. We don't even need a new block, is what you're saying?
You don't even need a new block. You just if it's empty, you can optimize it away. Just emit the condition and that's it.
If not,
What if it's an infinite loop?
an infinite loop?
I
Well,
mean, if the condition is true.
oh, you're right. I'm gonna not think about that for now.
I suppose you could just emit the condition block and the branch and have it branch to itself if it's false. Oh, so long as it's true, you can have it branch to itself.
But then what if it's runtime infinite?
Yeah, no. You emit code that checks the condition and branches back to itself if it's the same, and you basically do the same thing as in the other case. You just remove that loop that contains the body.
Yes. Okay.
And loop back from the conditional branch block to itself.
Oh god.
That's one way of doing it.
So if this is going to be rough. If the body is empty, right?
Mm-hmm.
So if expression children next child children is null.
And we also maybe add a comment to explain what the hell that case is.
So if while body is empty, then we actually want to do other stuff. Okay. What do we want to do? Here, we're going to invert this. If while body is not empty. Okay. So we would like to convert a condition, emit a conditional branch either way, but our block will change if the body is empty to just jump back to the while conditional block. Can we then return? Because it goes to the join block. We then have to attach the join block.
Oh yeah, that's true.
Okay, so here's what we're going to do. We're going to make this a little shortcut. We're going back to if while body is empty. We're going to do this. Oh, yep, not there. There. We're going to IR block attach, which is the join block. Oops. To the current CodeGen context. While body is empty, remove body block. Don't use body block. And then we'll say like to do discard while body block. Is there a way to do that? Is there like IR block delete?
Just create the block after the if.
Oh, that's true. We don't need it until then. So, yeah.
Yeah.
Okay. Return, okay. So, after we attach...
block, to answer your question, you can just free it because it's not inserted anywhere.
We also have to do that down here. We can just free it?
Attach it.
Beautiful. Okay. That's IR block attach. I'll get there in the end. Okay, so we attach the join block at the end. If we have to insert a join branch, it'll happen in the... Okay. Okay. It's happening. We don't need this now.
The only thing that's worse than this is CodeGen for 4.
Yeah, I don't want to think about that right now. There's 4 basic blocks in a 4, isn't there?
Actually you don't. You can just emit the increment at the end.
I see. So that's not too bad. 3 blocks. Just the semantics between them. What happens when you break?
Actually, you need, you need 3, but you need to emit the initializer before the condition block, so that you don't reinitialize everything.
Ah, so it's like if the condition is before the new block is created.
Yeah, in a 4, you have the initializer in the same block as the block before the condition, and then the condition block which checks the condition at the end of the last block in the loop body. You can put the increment.
I like it. That's, yeah. Okay, so we IR block attach. If there's no body, then all we have to do is IR block attach of the join block. Okay, that should be good. Shortcut handle. I like the pepper grinding. It's really adds to the experience. I feel like I'm in a kitchen. Gordon Ramsay's gonna start screaming, "Your code is raw!"
I mean, I'm eating raw tomatoes, so
Oh, those are so good with salt on them.
yeah, salt and chili in this case.
Nice. That sounds delicious.
Hmm.
Not chili as in like bean chili. Like bean chili? I just have to ask.
Pepper.
Peppers, yeah. Like okay. When I think of chili, I think of like The Office. Like the big giant pot of beans.
I have no idea what that is.
Do you really? Okay, hold on. This has to happen. Hold on. Yes, this is worth it. Before anyone asks. Chili. This stuff. Oh, it looks horrible.
That.
Yeah,
Oh, the dish. That's what you mean. I see.
chili.
I see.
So what do you mean? So when I think of chili, this is the only thing I think of. Or like this is a chili.
Yeah, that.
You're talking about literal chilies. Okay.
Yeah.
So weirdly enough, these don't really have anything to do with each other. Like this is
Really?
just there's not chilies. It's not chili isn't spicy with beans in it.
Mm.
It's like it's just beans and some tomatoes. So that's so
Brilliant.
confusing. Did I show the stream this? I can't even tell. I don't have OBS open. I probably didn't
No.
show the stream that.
I have a lot of monitors, but not that many.
The stream is curious. This is what we were looking at. Chili. And then the other chilies.
Yeah, now it's on stream.
Okay, legendary. Buttons are hard to press, you know?
I mean, I've Discord on my main monitor, and then the ID on another one, and a browser window on a third, apparently. So
That sounded great.
yeah, I dropped my knife.
So why'd we break things? What did I do?
What?
I broke things.
Did you break something?
Yes, exiting with code 5.
I would look at the IR. Because
Yeah.
if it's compiled, then we can take a look at that.
It exits with code 5. There is no IR.
Oh, the compiler exits with code 5. That's brilliant.
Yes.
Node last expression is null. What if there is no expression in the loop? Are you handling that case?
Here.
It's not that. Okay. So after that, last expression is never going to be null.
It can't be because this is check. So let's try
Okay.
that. Yeah, the same result. It's definitely
Okay.
not null.
Um,
Wild body block. We don't actually ever need that, do we?
I mean, what I do is I just like fire up the debugger at this point and check what's actually null.
Well, let's go for it then, I guess. There's one thing to do.
If you already have C line open, I can just press a button.
Yeah. Open up the proprietary badness.
By the way, I hope this thing isn't too loud.
Like I said, it's honestly it's nice. It's normally it's just dead silent while I'm streaming, so having any sound is like, I'm not
That's
insane.
grinding ASMR.
Yes. Just start whispering everything.
Oh god.
Okay, now that you say it, my theme looks scarily like VS Code.
Really? You think so?
The purples are different, but yeah, you're right. The green is almost exact.
The yellow is the
hilarious.
most exact match for me, like the function names.
That's definitely an exact match. Like, I'm pretty sure that's hex the same. That, it's, okay, it may literally be the same. What? While. Oh no, what have I done? How do I insert, delete, home, end? Okay. I have to always oh, it's already while. What? Okay, it's already while.
Wow. Bit too much pepper.
I hate that feeling. Your eyes go all watery.
Huh.
Don't worry about those warnings.
Jeez. It's a lot of warnings.
I mean, there's only a few warnings. It's really not that bad.
You?
MSVC
Jeez.
sucks, okay? These don't exist. They're not warnings.
Some of those are hopefully warnings.
F open. This function
Yeah,
or variable
that one
may
is
be
not
unsafe.
obvious.
The POSIX name for this item is deprecated. Instead, use underscore file
Brilliant.
now. There's shift going wrong. That's fun.
Ah, yeah, some more W conversion stuff, probably.
Yes. So when we run the debugger, it says cannot open file m.lib.
Ah, because I'm linking against libm for log10.
Are you really?
Yeah.
libmath doesn't exist on Windows.
Then where does log10 come from?
You write it.
What?
Yeah.
Hold on, Windows log10. Is math.h not a standard library header?
I don't think so. No.
What?
There's not in Lenser OS.
Okay, hold on. I gotta
So-
check.
Log10 is
C-
used in the IR person.
Standard. I always thought it was a standard library header. Maybe I'm wrong. Let's see. What are the standard library headers? Math.h is a standard library header. What do you mean? Math.h right here.
But inside math.h, I don't know if log10 has to be defined.
Actually, that's a good point. Let's see. Is there a log10 in there?
If there is, it's Windows' fault. Or it's just named something else.
How to find out?
Chili.
Math.h. FP classify isn't. There's none. Is normal.
This is
Sign
not.
bit. It's not, okay. All the trig functions are definitely in here. There's exp. There's ilogb. Of course there is. There is log f, log l, log10 is in here.
It's in there?
Standard C. Log10 is standard C.
Okay, so why is it complaining then? This doesn't make
Okay,
sense.
let
What
me
is it
find
complaining
out.
about?
Windows C log10. Maybe you don't need to link against libmath in Windows. Let's see.
Okay, so that would be in
Required
the
header is
select.
math.h. It doesn't say anything about required library, so maybe it's just in the standard library. So can you just go to the CMake and remove like wherever it is?
Am I here?
Yeah, that. Actually, it probably should be not Win32 because ClangCL emulates MSVC, but Win23, brilliant. Best architecture.
So it's gonna reload.
Let's see.
Oh, I think that did work.
Okay, so there's no libmath, but it's just in the main library.
Yes. Hey, look. Yes, please. Why? Okay. Okay, do it again. Okay, that's just a breakpoint. I don't think we need a breakpoint there.
Yeah. There we go.
UZ was null
UZ
putter.
Okay, let's go. Just there you
Call
go.
stack.
Just go up the
IR return, which is marking a branch as used. So branch is null here? No,
That's
branch
not-
is not null.
context block is actually no. What is null? The block is null. The current block is null. Jeez,
Is that
that's
not
not
right.
right. Is it? I'm sure.
so?
Name is
So
not
the context block does exist.
Okay, that's good. Does the return value exist?
The return value does not exist. Okay, that would be what it
There we
is.
go. That's the problem.
So iron return being called from CodeGen program
If not IR is closed, then we IR return.
And that's an issue because...
Oh, we should be checking if last expression result, or if last expression or last expression result, whichever makes more sense, is null. And only if that's not null, we emit that. Otherwise, we emit an immediate zero.
Which is what this does, right?
This only checks if but can last expression be true but be non-null, but last expression result be null?
Oh, okay, yeah. It's a malformed program that type checking isn't catching. You know why?
Because we're not type checking the while or something?
Close, close. So remember how the ifs, they both have to compare, they have to return the same type?
I see.
We do this checking in the if, but at the top level, if you have an expression that doesn't return a value, aka a statement, at the end of a program, we don't type check that that's not okay. So we need to put a zero here, or condition.
I see.
Right? Because this is just a malformed program. You can't return while conned, which is what we talked about. It doesn't have a return value.
Yeah. So it's just our type checker not being
Up to snuff.
You know.
So
again, this is why we need the notion of void, I think.
There we go.
So that way we know whether something returns a value or not.
You're correct. You're correct.
So
It's
as soon
in
as we
there.
have that, these problems should just disappear. Unreachable, brilliant.
Yeah, it's fine. So
Probably expected.
why am I here? Why did
It
I go to the
interferes
parser?
after death. Interesting. What?
So I think it's just an unhandled while.
While isn't a thing in the IR though.
Don't worry
What?
about that. Don't worry about that. What did I break? Okay, I did something really bad.
Why did it break 396 apparently?
Okay. But that's here.
Ah,
That's a brace.
yeah, that's not right.
Am I in the... Oh, I'm just in the wrong spot. I'm in
I
dumb.
didn't do the.
Okay.
Okay, that would do it.
Yeah, being in the wrong file. Okay, okay, it is. So IR branch conditional, IR branch, IR return.
What? Okay.
So somehow we have...
You have a block that doesn't end with a branch, I think. Can you dump the IR? Just pass in the dump IR flag to see what's going on.
Yes. I think
Oh,
we...
now it's debug IR. I forgot. It's debug IR.
it's not a dumper anymore. Okay, it's now start up the debugger. There is none.
IR, not it. Did you type it? Or did you type IR?
It's up there.
IR. Okay, interesting. When is it printing that? Before, after register allocation? That's the question.
It should be before in CodeGen, shouldn't it?
I'm not sure. Just insert it there.
Yeah.
Just insert IR FMIT.
So
Sometimes
after...
you don't need to set the IDs anymore because IR FMIT does that now.
Nice. That's actually very helpful. Standard out. Printf. If debugger. Okay. Whoops. That thing. So we're going to printf something like backend lowered. Sure. Is that fine?
Sure.
Perfect. Main.
Oh wow, that would do it.
Yeah, that'll do her.
The block that doesn't end with a branch, that would do it.
Yeah, that would definitely mess things up. So how did I screw up the condition block? What did I do wrong? While. Oh, nope, while. So the condition block, let's see.
Oh, where you attach the branch from CG context to the condition block. That makes sense. You attach the block.
We
Attach the
CodeGen
block as the insert
load
point. So that's
cond.
fine.
And then we say while body block. So we didn't copy the conditional, or I didn't, when I made this handling. I didn't put the
I see. That would do
conditional
it.
back. Yep. So this needs to be the while body block, which means, yep, after while body block is defined.
We forgot a condition. That would do it.
That would definitely do it.
Yeah.
Oh!
There we go.
Oh! Wait, did it work?
Well, it compiled. It looks about right. Let's see, BB3, BB4. At the end, we go back to 2. I think that's right, yeah. That is pretty much how a while loop works. We're loading the condition, because we're returning it, that's why.
Yes.
This unfortunately will trash the optimizer because it's not going to be able to optimize this away anymore because of it. There's 2 stores. So for this, we need a proper mem to reg pass, and for that, we need proper files.
So what you're telling me is if I return 0,
that's not the problem.
that's not the problem. Okay.
The problem is that we have a store in the while loop.
I see. Of cond.
We assign the loop variable.
Yes. Okay, well, here we go. It sort of worked. Let's check if it all the way worked. Fun compiler. O.s. It looks right. There's no null. There's no giant number.
Jump 0, L3, jump L2, jump L1. I think that's about right.
Okay, well we're gonna do it.
Let's see.
GCC code.s. We do need the standard lib, and then just run it. Oh!
Ah! It worked!
Oh!
Look at that. We have while loops.
We have while loops, at least
I think
unoptimized.
that's how you break something. Oh, let's test it optimized, yeah.
It actually did get shorter.
Not by a bit. It removed one jump and merged some blocks. Which, is that right? Oh, it is. That works, yeah. It managed to merge those blocks. That's interesting.
I have a feeling.
Are we doing -1 somewhere? I think we're doing -1 somewhere for the IDs. We might be doing -1 somewhere.
Oh, that's not good. Okay, well...
Should be in IRF emit.
Yeah, cogen intermediate representation, IRF emit. Okay.
Yeah. An F emit instruction, probably. You could also search for F emit instruction. That would probably get you there faster.
That's a good point. Where are we doing this? Here?
Probably at the top somewhere. Are we doing -1 anywhere?
So to print out...
Oh, actually, never mind. That code that prints like the parentheses, that's somewhere else. That's in, I think, defun or something. Just search for defun.
IR print defun. Yes, okay.
Yeah. Size... there we go. From size I equals Z. Yeah, well, from 1 to less than or equal to size.
Just gonna optimize that.
But now we do need I-1, like parameters.data at I-1, because the parameters are still 0 indexed.
That's a good point. Okay, so that was probably the code 5. Beautiful. Oh no.
Actually, we didn't change anything now that you think about it.
Yeah. Hold on. Why is the...
Okay. It might be that we don't... No, we should be setting them. That's weird.
So we're printing the ID of I-1, F parameters data. What is F parameters? So that's a vector.
Parameters is a vector, I think. Yeah.
And it's a vector of instructions. So this is just the instruction ID.
Yes.
So when we, in IR function, ID equals 1 through params.
Mm-hmm. And we push it onto the vector.
Well...
This is weird. Okay.
That is a confusing one. How are we getting
Can you,
in...
like, scroll up? Is the problem still... Is like... No, in the output. In the output.
Oh.
Is the problem still a thing? Yeah, there we go. Something broke.
Optimizations.
I know what the problem is, I think. This is a use after free. We're not removing the parameters from the
list.
So we don't want free parameters, basically. It's in IR remove, I think.
Okay.
We
Also,
don't
I
want to
screwed up
free
this
parameters
part.
is the problem. We're freeing parameters.
Okay, so in intermediate representation, IO remove.
Yeah, I think IR remove is what we are deleting instructions.
We have remove use and
It's
remove.
not that
Okay.
one. There's a free at the bottom. Just don't free it if it's a parameter. I think. So instruction type is not equal to IR parameter.
Okay. We can do that.
Yeah.
I was scared
Because
that we'd
I
have
think
to.
that's what's happening, because the optimizer realizes we're not using those, and it's just removing them.
I see.
But we don't exactly want to remove function parameters, so there we go, yeah. That's...
So to fit the calling convention, we can't optimize.
Yeah. Oh, and typically, if you
Uh,
ever see a temporary that looks weird, it's probably because it's been freed. Or removed when it shouldn't have been.
Okay.
Or you still
It
have
looks
a
better
reference
now.
to something that's been removed. Now it looks right.
And now we can go back to our code.s.
Yeah.
Everything works. Okay. And then we can... Oh, beautiful. That is so good. I can't type, but that's so good.
Alright. I think we can commit this.
I agree. Oh god. There's going to be a lot of commits to do. One thing...
Just
Do we
commit
have it?
everything and implement while loops.
What is it? 13? 12?
Hmm?
ASCII 13 new line? /n?
10 is new line.
10 is new line. 13's carriage return, huh?
I think so, yeah.
I always mess those up. There we go. That's fun. I like that. That's a good example. I feel like I've seen that example in fourth, right?
I don't remember, maybe.
We can write rule 110 as soon as we implement the not operator.
Which you could do right now. It's fairly simple. I mean, if you implement unary operators in... I mean, you have unary operators in the past, so...
We have dereference, right?
Which is unary, yeah. And should be trivial, really.
That's true.
Code for it isn't hard either.
We should try it. We'll
Yeah.
we'll commit this while and then do that. That sounds fun. We already talked about tree sitter. Oh, global variable optimization. Did you fix that in your
Yeah.
You fixed that. We're good. It was in the what, inline
No. And
global address?
it's in the backend where it's emitted.
Oh, in the
Where
XE.
you-
Yeah. That's right. I have to double check. Otherwise I'm gonna drive myself crazy.
Right at the
Okay.
very end of the file.
Perfect. Does store have a name in the value?
Should.
I thought, but you need the data.
Store should have a... It's global store name in that case. That is true. I didn't check that, so you need to check for that separately.
Okay, so we're gonna... Okay. Is this okay? I'm just gonna copy it and then remove the other two.
Yeah,
Just something
remove
like
the other two. You can remove some of the parentheses and check for... I think it's global store name or whatever it is.
And then... Okay. Yes. It's gonna be value dot... Okay, comp mode, help me out here. I don't remember. Oh, look at that. It's the top recommendation.
Well, assignment, of course it is.
Oh, I pressed the wrong button. I'm good at that. Dot name, which
Name
is
name.
in the wrong spot. So we would be testing new value as a string up here.
Okay, yeah. I forgot about that.
There's a lot to remember and forget, so I do not blame you. So now we only check global address or global load. And we...
Yeah,
then-
I think that works.
Okay. And if we... Okay, there we go. It still works, hopefully. Okay, it still works. We're good. Let's make that little change. That's crazy that I chose to just look at that, even though it was already fixed. What are the chances?
Yeah.
Life be crazy like that. Okay, we're gonna commit this little fix first. Because it's the easiest to name. Cogen x86-64 global store contains a different value than global load. That's a horrible
Yeah, just
name.
something.
It's fine. It's just a commit. I'm overthinking it.
Mm.
Okay, so we have a lot of stuff handled here. First, we should start with the parser, right?
Yeah, I mean, when I do stuff like this, I honestly just commit everything as like implement while because you can't really
Can't really separate them.
parser without the code gen for while.
Yeah, it's just going to crash anyway, like it was while we were
Like
developing.
commit
So.
everything except the editor stuff maybe, and the editor stuff or the mode can be a separate commit or something.
Yes, yes. Unhandled ASCII type. What do we have? Node compare must handle all types. Yes. Indent. Sure. Okay.
Right, this is my last tomato, so I'm done with this now.
All right, that's good to know. Good to know. Our ears won't be blessed for much longer. This is like parameter graph. I don't know what to. I'm just gonna include it.
Yeah, just don't worry about it.
A big ol' while. Code gen. Okay, yep. We have stuff like this. Oh yeah, remember we added the. Okay, I'm probably. I'll do those separately.
Mm-hmm.
And then we need this because that's makes it work. Okay. Then we also need examples while. Can't forget. I think that. Okay. That should be it. Staged, we only have docs and editor. And then in here, we have nothing in source other than a temp file. Okay, that scared me. We're good. So now we can do what? Commit, and just go. We'll do our little while. Here, we'll do it like this. Wow.
I love how you do the Spanish quotation marks for some reason. Oh, not quotation marks, exclamation marks.
I honestly don't know why. I just like how it looks. Is that racist?
Nah, just cultural appropriation.
Yeah, that's fine. Nothing wrong with that. Disclaimer. There's a lot wrong with that.
In this case, it's just punctuation. I don't think anyone cares about that.
Yeah. I probably only know about that from like yeah, I probably only know about that from high school, like Spanish.
I see.
Because our Spanish teacher was a little nutty. He really liked Mexico,
I
specifically,
see.
to the point where he wouldn't teach us or tell us about Spanish when we asked about it. He'd say, well, they don't do that in Mexico. And we're like, well, when you look it up, it says Spanish works like this. And he's like, yeah, that's only in Spain. It's like, okay, so
Yeah.
we're only learning Mexico Spanish.
I mean,
Just
to be
because,
fair, though, Latin American Spain, sure. Latin American Spanish and European Spanish can be a bit different, so I imagine why it would make sense to only teach the one or the other, maybe, but you should eventually probably learn the other two, if you want to learn Spanish, that is.
it's true.
Either way, be right back.
Alrighty. We'll be here. Cogen IR. So we're gonna. This isn't really Cogen IR. This is mainly. I'm gonna just put this under the minor tag. It's really not a big deal. I'm gonna add adder instruction in IR grammar and Emacs mode. Perfect. If anybody's here still, if anybody has been watching this for some reason, shout out to you. And do you like this new format? We have somebody here with us. It's cool. I like it. It's a lot more fun for me because I get to actually, interact with somebody directly instead of just talk to myself in an empty room, which is a little more sad. But yeah, do you want to be a part of the stream? Just join the Discord. You can join. You can be just like Eternal here. And this is going to be editor Emacs. Add while keyword to list of keywords. Well, which highlights it, of course. Oh, I only did that. I only did that in the one mode, but there's two modes now. One that isn't based on tree sitter, which also has keywords. Okay. Also add that. Okay, we're going to do a little bit of a fix commit. We're just going to add this. So we're going to just name it fix, and then we're going to rebase, get rebase interactively, right? And we're going to rebase from our fix onto add while keyword to list of keywords. And then we're going to do nothing on that commit, but squash the fix commit. And when we do this, we now have two commits that are being merged, and we want to keep the one message from the first one and remove fix. And now you can see that our Git history includes the one commit we made for the editor Emacs, and now it contains both changes. That's how you can use Rebase interactively to, actually merge a fix commit from the head into a earlier commit. How about that? You can also do crazy stuff with Rebase, so be careful. In that case, we're going to push it. Push. Amazing. We have while. We implemented while. Isn't that crazy? I feel like that's crazy. It works now. It works. It's a little crazy. We have while loops. What were we going to implement? Now that we have while loops, we have integers. All we need for rule 110, we have bit shifting. We need and. Yeah, we need the bitwise operators. That's going to be difficult, isn't it? It's not going to be difficult. It's just going to be a whole thing. Because we have to parse them like and or. We have to parse them first as binary operators. Then we have to type check them, which as binary operators should be easy. That should be like automatic. So type checking is kind of XNAID. It's part of the parsing because of how our operators are defined, our binary, built-in binary operators. Here we can just look. Binary. You can see that to define a binary operator, we already know the types of the left-hand side and right-hand side. So we can ensure that at parse time. Well, at type check time, but when you actually define them, we already know the type. So type checking is automatic. That's what I'm trying to say. From there, okay, we would need to have and or. So if we had and or, we could add them here. They're going to be type checked, and then in CodeGen, we're going to have to implement new IR nodes. Oh boy. I'm going to have to go soon. I've been streaming for 4 hours. Anyway, we have while loops. Look at us. We implemented this today. We now have while loops. It's beautiful. And we can even run them. And we get, woo, a loop.
All right, back.
How's it going?
I now have a glass of water, so...
Beautiful stuff. I just carry around like a 30-ounce water bottle.
I
So
mean, I also have a bottle of sparkling water now, so so
legendary.
um,
Yeah,
submit everything yet?
I did. It should all be pushed.
Okay, that's good.
Should all be there. Yeah, it's there. And I was just thinking about what we would need for Rule 110. We also need and or. So I was thinking about what we need
Ooh.
for that.
For short circuiting and an or. Actually, yeah, you don't need operations for that. Actually,
I don't need and or IR types.
no, because the way you do and or, well, optimizations are a different matter. But the way you do a logical and an or with short circuiting is you replace it with an if. So A and B becomes if A, B, and A or B becomes something else. It's like something
Logical.
similar.
Yeah.
Yeah.
Yeah. We need bitwise and or.
We need bitwise and or. Okay. Damn
Those
it.
are
Okay,
new.
in that case, we're doing instructions.
Okay. I was like, can we really get away without new instructions? I
Yeah,
was
in
like,
that case, we can do instructions. They're just gonna be more like arithmetic instruction or like bitwise or whatever.
yeah. So we're gonna call these. I mean, we can just call them or and because, like you said, we just use if, right?
Mm-hmm.
Okay. Also, those are in the wrong order. And an or. Oh, next big idea is rating. Are you ready? With a party of one.
Oh.
What's up, next big idea? Thanks for the raid. What's going on? What's your next big idea? Oh, he says hi. Hi. First time chat from next big idea. What's going on? Thanks for the raid. What brings you here? Why'd you raid? You just want to join? First time chat. Gondler, I count a party of two. Oh, nice. Okay, we got two. So it's not too
Ah.
bad. Gondler says Twitch is wrong. I should have suspected that. Twitch is always wrong. They just tell me like, oh yeah, you have no viewers, and it's like people are talking in chat. What are you talking about?
Yeah, brilliant Twitch.
So with and or, when we add new types, it now it exits with code 1 now because a static assertion failed. Handle all IR instructions.
I like with code 1 important, not
That's the wrong
compiler.
How did yeah, the compiler did it, not the compiler. It's pointing to the static assert in the macro.
Okay, you need to not.
Oh, it's in the expansion.
read-
Okay, yeah.
Yeah.
Here.
Here.
Okay. We're good. It still has the data. It was just green instead of red, so my brain couldn't figure it out. So IR count now equals 30.
Okay. No, it's 30, and we need to add and or, and I suppose we can just call them and or.
Yeah, much like all of these, right?
Mm-hmm.
Okay.
The exact same, actually. Yeah. That's a lot of code duplication now that I think about it. I should really like have a map for that or something.
It's true. It's fine. Everything should be a macro, really. And or. Okay, so now those are handled,
They're handling here, yeah.
which means that we can change this to 30, which we did, and we can continue our compilation. Okay, we can now go to unused expression, assert. Okay, this one. So many windows opening. Okay.
Has side effects. Okay, they do have side effects, so
Do nothing.
actually they don't have side effects. Never mind. They have a value, but they don't have a side effect. So
So we need
actually,
and or.
do they have a side effect? Yes, they do, because yeah. Okay.
What sort of side effect?
That's also a question. Like, why is add and subtract in there? That's a good question.
Yeah.
Did you put it in there, or was I that? Did I do that?
I don't think I wrote here.
Because has side effects and add doesn't have side effects. Like, side effects does do anything other than just produce a value. So that's like stores,
I don't have
branches, obviously, and calls. So all of this is nonsense. II immediate, Actually, no, never mind. Never mind. It's right. If you look, it's right. It's right. It's right. If
Okay.
you look at the code again and not
Yes.
at the blame, it says return false. So that's right. These are all the ones that don't have a side effect.
Ah, you're correct.
I managed to
How do I
confuse
get out
myself.
of this?
Yeah.
Oh, oh, okay. It's
Yeah,
it's
that makes
okay.
sense.
It's
I
inherently
thought,
confusing.
yeah, because it's better if by default it does have a side effect.
I see. Yes, yes.
When in doubt, we don't want to eat it.
That's a good point. So the optimizations are not absolutely aggressive, which is ideal. Here. Okay. Next big idea says I was writing a bot in Python and wanted to see some compiler written from scratch. Oh, this is that. This is all that. We just implemented while loops. So now this example, whoop, a little squished. It's a little big. This example now works. So you can define put char as an external thing for linking. Don't worry about that. But you can describe this condition, which is 10, and then put char the condition as a number. It's a little complicated because we don't have a lot of types right now. But then you can run this, and you can see that we get 987654321 and the while loop works. Isn't that amazing? We did that today. I didn't think we. I figured it would be fast, but I didn't think it would work this fast.
I mean,
So-
Void had codegen for if, and it's pretty similar. So
That's true. These aren't branches, so we don't have to worry about handling anything here.
that is true. Yeah, the
And-
handle branch types is like all over the place because there's so many places where we care about that.
It's true.
Yeah. See.
Okay, handle all branch types once again. 30. Move on. Okay, then we have 28, which is to address.
They are.
They are. And it clobbers the right. I guess it doesn't really matter what they clobber because we can just emit them differently based on which side we want to clobber. So we could have clobbers 1 as an option as well, where it can clobber either one. And it doesn't matter the order. Either or. Okay. Where are we now? IR mark unreachable. Okay, handle all branch types. Not important. Not a branch type. Static assertion, handle all branch instructions. What do you know?
That's for jump threading. Yeah.
So to
Emit instruction. Oh, here we go.
Yeah,
that's important. Okay. So now we need to add the instructions here.
okay. I'm gonna fix all these other static asserts so that we can actually get there in the runtime. Okay, I'm good at this. I promise. Static assert.
What is this?
This is
This
in
is what we
print.
Okay, I think you can just add them. Yeah, you can just add them.
So we'll go 30 and then look at shift left. And
Yeah.
copy like 2 of these, whatever. Okay, we're closer. Where are we at? Here now. Block reachable for handle all branch. Okay. It's like, uh-oh, this is a complicated one.
Oh yeah, for each child. Okay, here you
It's a
need to do the same
pair.
thing for. There should just add them here.
Oh. Oh no, don't do that. Okay, I hit the wrong button. Sorry, Emacs.
Also, I'm still not used to this. I'm not used to not having to tell you everything what to do because usually I when I'm talking to Ahmed, I'm trying to like show him how to change something on the website. I have to like describe every step, and I'm not used to not having to do that.
You're like twiddling your thumbs when you normally don't have to.
Yeah.
It's like, what? Okay. Oh my God. IR is value. It is a value.
Yeah.
We'll just put them here. And Or that was an efficient one. Whoops, not that one. So I need a way to open this compile window in its own thing. Is that all of them? That is all of them.
Oh my god, that's a lot. Yeah.
Okay, so now we're just here. Code gen.
Okay, now we need to do a bunch of things in here.
Yeah, not too bad. So shift. Okay, so as far as an and,
It's just and I think, yeah.
we have to move into the
Should
result.
probably copy like sub or something, or like yeah, sub probably or something, because it has
That's
to
a
be
good
in the right.
idea.
Shift left is a bad idea because it uses
Yeah.
CSTL.
I discovered that quickly. Okay, here we go. So let's go down below shifts. And then we'll just copy 2 subtracts and we'll
Yeah.
work on it from here. Oh.
Yeah,
Yeah.
we need to add that as well. of
Okay.
course. And now make sure that like Khan and Coda are the right way around.
Yes. I love hearing you say car and cutter. That is very nice. Okay. So now we're just going to copy this instead of having the second subtract. I lied. Or.
That also works, I suppose.
So now I underscore.
And just go all the way to the top of the file and just yeah, there we go.
And
You can put them up with the
the other
arithmetic
ones.
instructions.
Okay.
like-
And then
yeah.
reg. Immediate? No.
Yeah, you can end with an immediate, I suppose. Sure.
Okay. This is going to be horrible.
And then the same thing for OR. I mean, we already have all of this, so you can just use the same code gen as for something like sub.
That's right.
Now we need to go to, I think, we need to tell it what the mnemonic is. So
Yes, right down below. Nope.
yeah, there's a lot of lookup
Here.
tables. Yeah, here. And for like here, they're the same, I think, for all the assemblers. So
Shift right. And it should be the same per assembler, right?
yeah, I
would
hope
hope.
so.
Oh, okay. I'm good at Emacs, I swear. I meant to go up one symbolic expression, but it went to the global for some reason. Okay. Add sub and
That should
or.
probably also be a static assert.
Oh, that definitely should. Nice. Which will trigger. Okay. And then hopefully we have asserts anywhere else we need to handle it.
In
oh.
IR emit, I think.
Yeah,
It's
so
not a static assert yet.
femit itself needs to handle.
Yes.
Yeah.
And now it's just femit, yeah.
Okay.
There's a static assert though. Would you look at that? Yeah.
Nice.
I think you can just add it to like the big one at the top where it has add sub test zor compare and all of that. Because it should be just the same.
Ah,
We have
yes.
zor, really interesting.
Yes, for zeroing out quickly.
Oh right, that's why that makes sense.
Yeah.
We'll go with that.
So now with and or, I guess we just accept all of these. It's fine.
Yeah, should be the same.
And. So
I mean, it
now,
has to be the same. Otherwise, how would you do like an atomic test and or test or atomic fetch and
that's true.
fetch or?
That is very true. So now we emit the code. We wait for an assert. Oh my god, it worked. Okay. Oh, we didn't include it in the example. We need to still write rule 110, I forgot. So let's just go and or, and then we'll return what? 4 and 3, which should return nothing.
Now we need to implement and in the parser too.
Ah, that's true. So what are the bits of 8?
It is just like 1000.
So we need like 13 and 4 or something. What does that do?
13.
And 13 and 4. Does Emacs have and? It doesn't have bitwise and.
Okay, hold on. I'm just gonna open up root 13
We don't have-
and
Yeah.
13 and 4 is 4 apparently.
Well, that's good. That's a good test. So 4 and 13 is also 4, which will tell us if that works. So now we can just go fun compiler and or. Don't try and optimize yet, please. Mismatched
Oh yeah,
type.
we need to add that. That's one more place where we need to add that in the optimizer.
Oh
in
no,
like the
address of.
in the instruction combine pass or whatever we're calling it.
That's true. We added it to has side effects, but we didn't.
That's
Yeah.
probably a static said that too in
Yes.
the optimizer.
Okay, I just realized something. If this is the syntax for and, is this for address of A or for and A?
4 and A. Because 4 address of A doesn't make sense.
Okay. So address of has a higher precedence. I guess
It's
binary.
not about precedence. The rule typically is if it can be a binary operator, then it is.
Okay, we'll go with. Hopefully, the parser follows that.
Ooh.
We'll hope. We'll hope. Okay.
Because the reason why is because it just by default the grammars are designed to where parsers do greedy matching, meaning you try and match as big of an expression as you can, and for and A is a bigger expression than for and address of A.
Yeah. So this one would be favored versus this thing.
Yeah.
Even though they would, this is still equal to this, is what I'm saying. Yeah, we're good. So this should be 4 and 13. And hopefully that just happens now. We were rather close.
Unrecognized binary operator.
Yeah, we have something wrong here. The and doesn't actually get code gen. So where do we handle like plus?
I mean, I'm more concerned about the fact that it says assertion failed with false and unrecognized binary operator.
Okay, that should be in the backend. I think that's okay.
Huh.
So I think that's in the backend here. Unrecognized, right? No? Oh no. Where is that? Yeah. Unrecognized binary operator. What have I done? Okay, grep help.
Just do a global search yet.
Okay, yep, I'm good at this, I swear.
Okay, I can.
So we're searching for unrecognized.
Okay, let's go with unrecognized.
You can tell I wrote it because it has a Z.
Cogen.c apparently.
Did I finally fucked up my grep?
It's in cogen.c apparently.
Okay. Okay, yes, it is. Yeah, here it is.
I see. Yeah, we need to cogen it. That makes sense.
It's easy to forget when you're doing 18 million things.
Yeah.
Oh, and then we can't call this IR shift left. This is now IR and IR or, in which case we now have to go to the intermediate representation and add these.
That too, that's true. And actually, we should just have IR binary expression. Actually, I mean, we could do that because there's a lot of code duplication, or at least internally, we should have something like that, I think.
That's definitely the way to go. You are correct. Because this is a slight mess. Okay, so shift. Yes, here. Oh god. I feel so bad. I'm so slow. I'm sure it's killing you. You're like, I would have wrote this 10 hours ago.
I mean, I'm not particularly fast either when it comes to like keyboard navigation.
That's true. That's true. You didn't. I always picture that you like type at 200 words per minute. You just seem like that GigaChad programmer that's.
I start typing and then hit tab and Copilot types at probably more than 200 words per minute. So the result is the same in the end.
It's true. It's true. So set parent
Now that I
mode.
type 200 words per minute, I don't need to type at all.
That's right. That's the true GigaChad part of it.
Also, please don't name it and in case we ever want to compile this as C++, because and
Okay.
is a keyword in C++.
Oh, okay. Okay, we won't do that. Okay. We
Same
won't
thing
do
goes
it.
with all, by the way. You can, if you've seen any of my projects, I commonly write and instead of the double ampersand, because you can do that in C++. It's an
And
it's an equivalent token on the preprocessor level. It's not just a different operator. It's the same token, which
that's
means if you have an
crazy.
R value reference, you could also write like const string and.
That's, oh no.
Really good.
That's really funny. I didn't know that. You can use the and
Yeah,
keyword as an
same thing
operator.
for or, and there's a bunch more. There's compl for like the binary for like complement, and there's bit underscore or and bit underscore and because of course there is, and so on.
It's X now. I don't know what else to call it.
I mean that's fine in this case. I think it's pretty clear what it is. I usually just call them I because of instruction.
That's probably a better idea. Oh, okay, that's not going to work. 2 renames.
At least X is easy to search and replace.
That's true.
I mean, it's context, so but still.
And or. Where are we at? That's looking much better.
Ah, right. We are generating an and. That's
Yes.
better.
And it apparently worked.
Apparently. Let's see. What did it spit out? That's an and, if I've ever seen one.
That actually works.
It's in RAX, so that's correct.
It does fail with code 4.
It's
Awesome.
called fall. Yeah, that's right.
Yes,
Good.
yes. So
We have and all.
well, 3 or 7 should be 10, right? Because it's just
3
adding.
or 7. No, it's not just adds them. It combines the bits. That's different from adding.
It's true. So 3. Okay, so if we combined
3
binary.
is 1, 1, 7. No, 3 and 7 is just 7 because 7 is 1, 1, 1, and 3 is 1, 1. So
That's a good point.
3
So,
or 7 is just 7.
but
2
binary
or 4 is gonna be
6.
that's gonna be 6. Yeah.
Okay, so when they're binary values, it just adds them. That's what I was remembering.
Yeah, if they're powers of 2, distinct powers of 2, then
Uh-oh.
distinct. But if they have no bits in common, then it's the same as adding. Yeah.
Oh,
That makes sense because you're omitting the and the or.
but we get a panic.
Yeah, that does make sense. We are what?
Right?
Interesting.
I was like, wait, and doesn't have a register? What are you talking about? What did we screw
Oh,
up?
yeah, that's weird. And doesn't have a register. That's weird.
So, how does or have one and doesn't? So needs register?
And is unused.
Needs register. Yeah, that
Does
would be it.
register check if it has a use? I don't think it does. Do
We just.
have and?
Oh my god.
Ah, well.
Yeah,
Well.
I'm pretty sure I wrote this. I'm not not gonna lie. Assert instruction. Okay. Exhaustively handle
See, the thing is,
instruction
like,
types.
which statements are so stupid? Because let's
Do I need
not
a
only
session?
not for the fact that you need a break everywhere instead of break being the default and fall through being optional.
Oh.
But then there's also the fact that there's a warning that warns you if you're not handling all the cases, but that doesn't fire if you have a default.
That's so weird. That doesn't make any sense. That's what's going on here, huh?
By the way, if you want to like have a warning, there's a trick you can use. Instead of having a default, remove the default and just put that outside of the switch. Just put the return false at the end. That still works, and now the compiler will warn you if you're not handling everything. But then you need to handle everything explicitly, so that's also not ideal. So
There's no
We don't-
solution.
yeah, there's no good solution. I think it's better to just leave the default in there because we do want to handle the everything else case. It's just that here that's a bad example, but where we're like where we there are cases where we really want to like do different things for every instruction, like where we print all of them. We could do this there, for instance. But
That's
here it
true.
makes sense by default.
Yes. Okay, so these and an or need a register. The only reason they were being assigned before is because the return value sets rax as a register. That's a pass.
That makes sense. The coalesce
Yeah.
again. Again.
Yes.
Okay, now I
Well,
should fail with code 6.
okay. It's
Okay, that's right.
fog.
Nice. And now, there's one more thing we need to do.
Okay. What is it?
The optimizer. We need to do constant folding.
Ah, thank you. Thank you. Constant folding. Oh god.
Yeah, of course, constant folding. It's actually you can just do the IR reduced binary. You can just use that, and
Legendary.
if you go down to where that's used, yeah, just add them. Like just do IR reduce add and then
Okay.
with the AND operator.
Yeah. Okay, I see it. I see it now. So we're literally using the C operator and here
Yes.
to implement the const eval of and.
Yeah.
Okay. Okay. I get it now. And this is single and
Yes.
pipe. Okay. I'm just going to match.
And now compile it with optimizations.
Oh. It's just going to return 6, isn't it? Oh my god.
I hope it does.
Oh.
Oh, it's still doing this for some reason.
That's something I wrote, I'm sure.
Oh, because I know why. Because it's not. It doesn't realize that it's a leaf function because it isn't checking for that yet.
Ah, that's right. That's right. This is amazing.
That's why. So
That'll
this makes
return
sense.
6. I have a feeling.
It returns 6.
What do you know?
Hi.
That's so
Surprise.
good.
6.
That is so good. Well, we can now. Should we?
I
Should
think
we?
we need negate, right?
We need what?
Negate. Don't
Oh,
we?
yeah, we need negate. You're right.
Like, but not you mean like C the tilde in C, right? Complement.
I think we need logical negate, like
Yeah,
not
that's right.
equal. Yeah.
Oh, not equal. I see. Not negate. I forgot that existed.
Well, here's the thing. It can be not. It's just not in general. The logical not is what I'm thinking about.
Yeah. I somehow forgot about that.
So, logical
Yeah.
not is a unary operator,
Mm-hmm.
which we handle weirdly. So we're gonna have to do something like this in the parser,
Oh god, I see.
and then we're gonna need a new node type, unless it can be not a comparison.
No, it's a not. Like it's you. I mean,
I guess it's just a new node type. That's
yeah, it's a separate instruction. Not.
okay. So node type. Where's dereference? I guess we'll just do node type not. Okay. So we should now be able to parse not. Type checking not. Oh god. What does type checking not even do?
It just type checks if its child is an integer.
Okay.
That's it.
Which is very similar.
Because you probably don't want a not a pointer. Actually, we could. That's like that should do something else. Like on a, you cannot. You know, in C we commonly use not to check if a pointer is null, but that is like a special case. I feel like you could still provide that syntax, but just handle it differently in the parser, and maybe generate a comparison with null or something like that.
That's right. That's right. So why am I? So we don't even type check. Like the shifting, do we? Oh no, that's a binary comparison. I'm dumb. I'm not thinking straight. Okay. I'm gonna have to go probably soon. It's been over 4 hours.
Me too. I still have to record some stuff with Agma tonight, so
I see. Feel free to pop out anytime. I don't want to keep you.
no, it's we still have some time.
Awesome.
I'll tell you if Agma messages me and says we go record now, then I'll tell you.
Legendary. So, not should return what? Like, what is a...
I mean, it returns It will return a boolean eventually, I hope, but right now it's just another integer, I suppose.
Okay, I lost it because, yeah. So yeah, it just returns an integer. And then we also have to make sure, is this how this works? What am I doing? Type check expression sets result type to integer type. Okay, we're not insane. Is this? That
Is Charlotte
looks,
copying it? That seems a bit weird.
I was gonna say, this looks a little sus.
When in doubt, just don't free it. Like, we can
That's
fix
true.
that later. I mean, at some point I'm gonna have to go over this entire thing with address sanitizer and just stomp out all the memory leaks.
I don't know if that's possible anymore. There's
Oh
so
yeah,
many.
with ASAN it probably is. Like,
That's good.
shouldn't
So
be too hard.
we need to
But again,
type
if
check.
need be, we can always introduce like a better context object or whatever, and just store the allocations in there or some metadata about them, and then just clean everything up later.
I see. Yes.
And the thing is, I mean, memory leaks are mostly relevant if you have a library. This is a standalone executable, so it's not that bad, but it's for debugging it helps.
So do I need to allocate a node for the type that I'm getting from type check expression?
I don't know. You wrote this,
I do.
not me.
So I need to allocate a node for the result type. Not the result type. This type. Child type. This is so difficult. So not child type. Does that make any sense? So the child type of not, we then need to do a type compare. How do I do a type compare? I don't remember. So when I ensure,
Types, I think.
I should have type compare integer somewhere here, should I not? I don't think I do. We have, there's less type comparing than I think there should be in a type checker.
Oh,
What's going
God.
on?
Perhaps.
Type compare symbol. That. But we need result type. Okay, yeah, we can do this. We can do this. Do that.
By the way, just so you know, an idea for something that would be interesting. We wouldn't be the first language implemented, but what some languages do is they normally when you type check, if you're type checking like an assignment or something, you just check, okay, is it like that type convertible to is the source type convertible to the destination type, like implicitly? What you can do is have no return be a separate type and make it convertible to everything. That way you can check for that way no return would be part of the type system, because if you call exit, there's no point in type checking if you're assigning the return value of exit to something. Yeah, sure, go ahead and do that. It doesn't matter because exit is not going to return anyway. Like, as soon as you encounter anything that doesn't return while you're type checking, you basically don't have to continue.
I see,
That's
I
how
see.
it works. That's how you can have like a call to exit at the end of a function, and then the compiler won't complain if you don't return after that, because it knows that exit doesn't return.
Crazy. No return is complicated. Although helpful. So we need to, this is an IR type? No, it's a node type. This is an error type. I'll get there. Okay, and then this says not operator may only operate on integers, I guess.
Mm-hmm.
Sure. Sounds good to me. And then we return it. Otherwise, we just break. Is that what we do? Yeah, otherwise we just break. We fall through. Not fall through, but fall through the switch case. The switch statement. Okay. Result type. So not should work. So not 0 should be 1. What happened? Static assertion. Oh yeah. Remember all the static asserts?
Yeah.
Okay. Node compare, we already have the default where it panics and will tell us, hey, you didn't handle this. An expansion of static assert node text. Okay, so I need to print out a not. Oh, how
Should
did
be
I?
cool.
Yeah. So node type not.
And
Gonna be
also
quite
just
simple.
some code from like address of or whatever.
What? We could reuse what?
Code for like address of or something, because that's probably the same. Because it's also a unary operator.
Yes, we should. You are correct. But we don't have any idea of what a unary operator is.
Oh god, okay, I see how it is. You're just passing a thing, okay?
Yeah. It's
Yeah.
we'll get there. It is now running, which is good. We have two.
Good.
Okay, we have none. The not has been. It's none, which is interesting.
I mean, that's not quite. That's also a type of not, but I don't think that's the one we're looking for here.
Yeah. Okay. So we have node type not, node allocate, working result equals child after adding the child to the not. Then we continue. And then we get this. Oh, symbol not 0. It's not a delimiter. That would be an issue. Oh, pipe
God.
needs to be a delimiter too then.
Brilliant.
Okay, that's good. That's better.
More sessions. Oh, that's where we need to actually emit the thing. Yeah, that makes sense.
That's good.
And
We-
what's going to be worse than this is we will need another IR instruction for not.
Yes.
We'll have to pick another 10 or so static asserts.
Yeah, you know. Oh, I'm in the wrong file, aren't I? Is that in CodeGen? So we already did type checking. Now we need to CodeGen in the same. So it's just a new. We'll go next to dereference. Okay. And we'll just do a simple CodeGen expression of the child, and then an IR not, right?
Yeah.
Node type not, and then okay, IR not, which means this is going to get messy once more because this changes. So just to be clear, we don't really have any comparison. It's next to comparison. I'll put it here. It's logical. And then type.
What I would recommend is grep for static assert IR count equals.
And then use
just-
that.
Yeah, that's probably faster
Let's
than
make
trying
sure.
to pass GCC's output.
Yeah. It's a little crazy. Grep dot recursively for static assert.
I would do static assert of IR count, yeah.
Perfect. Legendary. Great idea. And then all the ones that say handle branch type, we don't really need to deal
I've
with.
stuff like that too many times, so.
I'm just going through and doing the branches so that we can do them. Probably a bad idea because they're not gonna. I'm gonna have to skip some on the right now in the grep output, but I don't care. Handle all branch types. I'm gonna have all the buffers open. Handle all branch instructions. Okay. So now, where is this? Where are we? This is in print, so we need to actually decide how to print out a not, which is similar.
Yeah, that's just not, I'd say.
Yeah. Not.
It's probably going to be a reference, not per car, right?
Yep. Thank you.
And in IR not, it also needs to be reference if you haven't done that already.
I don't think I've written I or not yet.
Okay, yeah, sure.
I are for each child. So wherever
Yeah, you actually need to handle the child.
here, right?
Yeah, add it there. Yeah,
Not
yeah. Mm-hmm.
legendary. Okay, where else? 30. I are is value, yes. So sure.
It is a value, yes.
Just match indentation for now.
Hmm.
Emit in okay, that's a little don't want to just update that one. Handle all instructions and has side effects. Yes, no, it doesn't have side effects.
Correct, it doesn't. Yeah.
Okay. And then branch types. Okay, so we've effectively done it all except for code gen. That's good. So now we can hopefully reach the single static assert.
Hmm.
Yes. Perfect. So when we emit this instruction, I or not.
Oh, we need to emit an I not, and then we need to add that again.
Ah, yes, yes, wonderful.
Just go to the code for I copy. It's basically the same as that.
What am I? Okay.
IR copy, yeah. It's basically IR copy and then another not.
You're correct. I see what you're saying now.
Oh, I mean IR copy and then a move, if necessary.
Yes. Not move. And then that's only after the I not with all this stuff.
Mm-hmm. No, it would just be register
Okay.
if it.
Yep.
Because not doesn't have it doesn't have an output register. It's just one register. So it
So
would
it'll-
just be reference.
Okay.
Because not only takes one argument.
So we just use its child register as its register, no matter what? No. Oh, no.
It
That's what this does.
Child,
Okay.
that's important.
Yes. Yes, yes.
And then we move to the right register, which hopefully is the same register, but like it will not emit a move from one register to itself, so we can always write extra moves in there.
Yes. So this is going to be a little different.
Oh, this will just. Can you do not with anything that's not? Can you like not a memory address? Hold on.
I think you can.
You can register or memory. So this just takes register or memory.
So this would be reg,
Yeah.
and then
But it takes memory. It's a. Is it a? I think it's a displacement if you have memory, right? So, is it?
oh no. I don't know.
Just we can just ignore that for now.
Yeah, that's fine. That's fine. Everything's fine.
I
Yeah.
don't think we have any other like really unary instructions that are actually unary.
We don't have any. Static assert I count in dot now.
Oh yeah, if you check out instruction operands x86-64, memory is a register followed by an offset. So that's what that would be.
I see. Yes. Yes. 24. Not.
Not. Yeah, not.
Okay.
Should be the same, or it should always be called not, I hope.
And then should be a static assert I count.
And emit.
Yes. And in f
Now
emit,
it needs to be. Can we add that somewhere? I don't think we can. Let's just see.
I'm
No, I
hoping.
think
Oh,
a separate one. Push. Actually, push is a pretty good one. I mean, you can't not an immediate, so that's different. But it's almost push. I think you can just copy the code from push and remove the immediate branch.
which is pop.
Is it? It is. Wow. Okay, it's the same as pop. I forgot about pop.
I would not expect that. Okay, not in pop.
Not and pop are the same. Okay, sure.
What's happening now? Implicit declaration of function I or not. Okay, yeah.
Oh. Yeah, never yet.
And then there's this. is to address. I or not is not to address, right?
Hold on.
It clobbers
Is-
neither.
No, it clobbers its only operand though.
So it's not to address.
Oh yeah. It's not to address, but it clobbers its only operand, unfortunately.
So to address clobbers, it would just clobber neither. This,
Yeah, if it just counting to address clobbers, it clobbers neither, because it's not to address.
okay. What is this even used for? I don't remember. Oh,
You were
lowering.
right.
Lowering. I did write it. Yeah, here.
Ah, lowering. So we can like do clobbers 1, and instead of saying to address clobbers, just do clobbers.
And what would we do?
So instead of doing to address clobbers, just call it clobbers. So we check if instructions in general clobber something, and then add a like clobber reference
Copy.
or something.
So whenever something clobbers a register, what we do is just add in a copy before it of that
Yeah.
register into a new register, and then we use this new use.
Yeah. That works. So what I'm saying is basically, right now you're only doing 2 address instructions, whereas you could only extend that to like 1 address instruction. So just add a clobbers 1 or clobbers reference, and instead of calling it 2 address clobbers, you can just call it clobbers or something. I don't know.
Okay. We're going to go with it. We're just going to call this clobbers. Fuck it. That renamed the struct tag.
Yeah.
Okay, and that failed. It says conflict with symbol. So
Okay, in that case, good old what's it, query replace.
There
to
we
the
go.
rest.
I did it.
Oh, that also works.
It was just
I-
complaining.
Place honestly, if I'm in Emacs.
Ooh, what did I just type? Jesus. Okay. Clobbers 1.
Clobbers 1, yeah. Or maybe you could say clobbers reference, because clobbers 1 could also mean clobbers either one. That's the case you mentioned earlier.
That's right. Okay. So clobbers reference.
And maybe it shouldn't be called is to address anymore, but instead just, I don't know, clobbers
Does clobber?
does clobber. Yeah, I was going to say clobbers question mark, but that doesn't work in C, so
Not quite.
don't think you need a break after the return, let's be honest.
We don't. It's just warnings. It reduces warnings.
What? Okay, is MSVC really that stupid?
It is.
Jesus Christ, that's sad.
I know. It's really bad. So again, we still don't have I or not. And then it says clobbers 1 doesn't exist. Did I really write clobbers 1?
Oh, MSVC warnings in general.
So clobbers reference means that instead of pair car here, we need reference. And everything
Yeah.
else stays the same.
I think so, yeah.
Okay, I'm just going to add a to-do here and say to-do reduce code duplication. Because these are all the same.
Yep.
Just change the... Yeah. Totally doable. That's a good to-do. We now handle reference clobbers, which means I or not should happen there. Yeah?
Okay, that's good.
Okay. It's not. Oh, I or not still doesn't exist. That's still an issue.
Right.
So codegen intermediate.
I should just be able to copy IR copy instead, but except you need to also insert it, because IR copy doesn't insert.
Yes. I or not. Okay. And then I or not in C, copy. Oh, yep, we're gonna... Did we handle it here already? We did. Okay. We're gonna
I
have to
think
add
so.
it to the grammar as well.
Oh, that's a good idea. And an R as well.
Mm-hmm. Mm-hmm.
I forgot about that. Damn it.
I'm gonna try not to think about that.
I mean,
What am I
it's
doing?
not that hard to add. I can just add it right now.
Yeah, we'll go in there. Okay, so IR not has to do what? Return X in
I mean, same
instruction.
as IR copy, but it also needs to insert. Yeah.
What? Oh my! What am I pressing?
iRoot
Oh, I was pressing Alt N.
Alt N.
Alt N moves lines up and down. Alt P and N.
Ah, I see. That's Alt up, Alt down for me. I use the arrow keys a lot.
I don't have arrow keys, so that would be a difficult one for me.
You have arrow keys. I see how it is.
Yes.
Probably also have a numpad, right?
Here's the thing. I don't have a numpad, but I have an entire layer for the right-hand side only that acts as a numpad. So if we look at it, we
I
can
see.
see
I see.
layer 4 has this
Okay.
numpad here. It does have the arrow keys
You do have arrow keys, so
on the 4th layer. So all I'd have to do is toggle, hold Alt, press the arrow keys,
it's not that hard, is it?
and then retoggle. It's not. So I would toggle. Oh god, I'm practicing now.
I mean, consider
There we go.
also just,
Okay, and then just bump.
you could also just have the arrow keys on your first layer.
Where?
I don't know. Just
I mean,
somewhere.
they're in there. They're just not in a sensible place. Like I can't press them with one hand.
I don't know. Just move J like H, J, and M around a bit. Who needs those anyway? Just put it there or something.
Yes, replace these.
Actually, yeah. Replace H, J, K, L with the arrow keys. Just trigger the Vim people.
That's right. That's so cursed.
You forgot to insert it.
Thank you. That's a big deal.
Possibly.
There's still what's happening now. Oh, I didn't
Another
change the number.
Oh yeah, that would do it.
Oh, for the IR backend, we have to handle IR
also
not.
need to- Do we have any unaries? Just search for like. Okay. We don't have pop actually in the IR, so yeah. Just. We do have copy. That is true.
Okay, so then IR not. There we go.
Yeah, basically just that.
Yeah. What else? Okay, we're getting there. Cogen
We're getting
expression.
That should probably also be a static assert.
Yes, it should. Okay, so we can close this. We can cogen dot c 228. Oh, whoa. 228, and change this to 17 because we are going to, I guess we just need to add in somewhere. Let's go to the end. Remember casting? I forgot that's a thing. Oh no.
What?
Yeah, remember? Well,
Oh, we have casts.
Yeah, we have typecasts.
I forgot about that.
The reason we forgot is because we have one type.
I mean, can you bit cast from a pointer to an integer?
You should definitely be able to.
What do you mean is the syntax for casts?
I think it's square brackets. I don't
think we have
remember.
an example of casts, do we?
We don't. No.
Yeah, that's why I forgot about that probably.
Yeah, there's no example. So I probably just wrote this and never tested it. So it probably works great.
Brilliant.
No,
I remember going over that though, all the different cases for casting, like zero extension, non extension, all of that.
that's right. And hopefully, see, we have half of it done. We have big to-dos.
Right. We need to implement sign extension, zero extension, and truncation. Right.
Yes, which was hard because we need to
mean,
know the
now we-
type.
Back then, yeah, but now we can do it. I mean, not now, but
It's true. Yeah, do things. There's lots to do. Node type not. So for node type not, we just need to make sure. Didn't we already do this? Didn't we do IR not in cogen.c? We did. Is the static assert right here? I'm just going up. See, this node type max is 17. Why are you
That
mad?
should be an assert, not an assert.
Yes. Why is it mad?
I mean, it works.
Yeah. Yeah. I don't. Okay. Nice.
That looks about right.
Is this optimized?
Code
That's-
255 now.
That's even optimized. Okay. So unoptimized, that makes more sense.
Jesus Christ. Oh yeah, because we have and and or. I forgot about those.
Yes.
It just yeeted that. I forgot
But-
about those.
Loading 0, not. This is a
Nothing zero.
bitwise not, right?
Yes, it's a ones complement not.
So if you not 0, it'll be 0?
If you're not zero, it will be all ones.
Perfect. Okay.
So it should be 255.
That's fine. That's totally cool. Right?
Mm-hmm.
Okay. So what do we have? We now just run it. Okay. Hey! That's
Look
what.
at that.
That's the number you said.
That's right.
That's that thing.
Mm.
Oh. Okay. And then we can just test. Oh. Know what we can do?
I was about to say. So I don't think I have unit operators in here, so you have to reduce it manually.
Yes. So IR.
I
not.
recommend you just copy the code for shift right logical.
Is it going to be
'cause-
similar?
Yeah, you just have to, instead of doing kind color, you just have to do one thing.
Okay. We'll try it out.
So you have to do one thing. First of all, you have to check if the operand is an immediate. We
Ooh,
don't
boy.
have. So you need to do if I value reference type equals
Yeah.
equals.
Okay. Yeah.
We can only constant fold it if it's a constant.
Equals. This is an IR type, which is an immediate.
Yes. And then just set the immediate equal to the. Actually, no, set this equal to the not of the immediate. I mean, you just follow whatever it's there. It's like. With use of im. Remove all of that. It's just casting because we need to do a logical right shift. And the only way to do that is to cast it to an unsigned. And so, no,
Oh.
that's the wrong not.
This is immediate now, right?
This is immediate.
Oh, and then we change our. Okay.
Yeah, we change ourselves to an immediate.
Into
So
not
just not I value.
in
that's the wrong
immediate,
not.
right?
In value, yeah. But that's the. You're doing a bitwise.
Which is how the backend implements it currently, right?
No. This is actually, hold on. I think it's this. Yeah, I think it's a lot.
Because a logic. You see where we're
but
at.
I think that's neg. I think the complement is neg, not. That's different.
You're right. Negation is different than not. You're right. I'm tired. It's late. I forget. Bitwise operations are always the
Actually,
most
no.
complicated.
There's logical not and bit and like complement bitwise not.
What is bitwise not?
That's a good question. Actually, that just sets it to 1, right? Not to like invert all the bits.
Yeah.
Like logical not just sets it to 1, right? Because if we have not 42 or not 0 is true and not 42 is false. Yeah. So what we have implemented logical not accidentally. I mean, no, we have bitwise not in the backend, but in the okay,
We've messed up slightly.
Yeah, because our backend has implemented bitwise not, so that part is correct, I think. Wait, do we want bitwise or logical not? What do we need?
Either one will work if it has 0 and it makes something that if will catch as true, right?
Okay, then
doesn't
I'd say
matter.
let's just implement bitwise not.
Okay,
Because
which means
we
I have to
that. So
cast?
instead of complement, and also instead of the exclam, I would. Can you not bitwise not? Oh, you're trying to bitwise not a pointer.
Oh.
Don't do that. Don't cast without reason. Okay.
It was
Bad
red.
idea.
It was red.
And then that's no reason to cast.
You're right.
Don't cast, especially not if it's red. And you
You're
don't need to
correct.
cast in 64T.
Okay. I'll just, yeah. Yeah.
And you can remove the parentheses. Yeah.
It's much simpler.
Good. Well, I would recommend changing the operator in the parser from an exclam to also the tilde. To
You think so?
differentiate the two.
We'll do it.
Yeah,
We'll do it.
because
It's
logical
one
not
thing.
is a different operator because bitwise not just inverts all the bits, but logical not returns 1 if it's 0 and 0 if it's anything else. It like not logical not of 0 would be 1. Bitwise not of 0 is all ones.
Yes. Yes.
That's why.
Yes.
And this also needs to be a delimiter then.
Good point. I like how you caught it right before the compiler told me. Oh. What's the unknown symbol? Symbol X. Oh.
Oh, well.
If you don't change the example.
Yeah, well.
Hey.
Okay, that makes more sense.
And it should still work the same because all we did was change
we're
semantics.
with optimizations right now, so I think.
Yes.
So
So if this works, yep, 255. So then if we do optimizations, oops, it should hopefully,
just be -1. Yeah, that makes sense.
nice.
Because -1 is all ones.
Yep, and it returns 255.
Yeah.
Beautiful.
And the assembly, it's just going to be 3 or 4 instructions.
They're not even needed. A little bit of optimization to do because of Windows.
Again,
crap.
functions.
Yes, yes. Beautiful stuff.
We now have bitwise operators, I suppose.
That's awesome. Well, should we... Oh, man.
All right. I'll have to go now, I think, because.
Okay.
Well,
Egma schwa.
Yep.
Awesome.
Gotta record something for a video.
Well, best of luck to you. All I'm going to do is commit everything we just did and then end the stream.
I'll probably work on some optimization passes, maybe, or something like that.
That's so exciting. I love optimizations.
All right. Then,
All right. I'll see
see you
you.
later.
Yeah. Thank you so much for coming out, spending the 5 hours with me programming. It was a lot of fun.
It is. It is. Right. Bye.
Bye-bye. All right, we did it. I got to look at Discord now. Is it broken? Okay. Oh, God. Can I... how do I... Can I leave the call without breaking... Okay, I'm going to stop streaming my screen. Okay, and then I can disconnect. Hey, I have 20 ping. Okay, it worked. I made it. Chat, I made it. It's just us again. This is so lonely. Anyway, we did it. Isn't that incredible? So now, not only do we have bitwise not, we also have bitwise and an or. Oh, uh-oh. My stream just crapped out. It's coming back, though. Hopefully you guys are okay. We changed a lot of stuff. So we're just going to add bitwise not is really what we're going to do. Oh, and then okay, one thing we should do first. Remember we talked about changing the grammar to also include binary operators of and or. Yeah. And a unary operator of not. BNF mode. I restarted my Emacs. RIP. I'd have to copy and paste from Discord again. It's not worth it. It's fine. So now, this should be, yeah, this is perfect. We have the grammar updated. Hopefully, the IR parser, we're still going to have to update. As far as I am concerned. So where we have adder here. So binary, I don't see any of the binary types here, like add. Oh, they are here. Okay, so if add is here, we probably gonna also need all the other ones. Like and, or, And what's the other one that we just did? Not. Okay. And then these are actually what? So we have not and or. We'll do like that. So then type, all caps, right? I think I need to add them here. Well, they're already IR instruction types. So I think I just use them directly. Everything should be fine. Okay. So and or and not, they're all their own IR types. And or are actually just binary expressions like add. Okay, I just need to check intermediate representation before I go crazy. Yeah, yeah. So and or and not are all separate IR types, which means and or not should all show up here. Shouldn't there be a static assert? IR parser must implement all IR instructions. I feel like this didn't trigger. Okay, so there's not, that's a little bit of an issue. It's fine. Basically, if we don't, the problem is if we add it to the IR, a new IR node, then this will also be updated. So I'm gonna write a little to do here because that doesn't seem right. We'll write a fix me. If a new IR type is added, this check will pass, even though it's not handled down below. Even though it's not handled, that's fine. Okay, and this is next to a long line, so who cares? We can reduce the long line, so I care. Okay. As far as that goes, the IR parser should now have it in there. Then we just need to fix this thing. I'm going to get rid of these random comments. Do feel like this should just be here, though. Or C equals, what did we have? Tilde. And then eventually we're also going to have this, so I'm just going to add it. I won't add it. That'll be confusing. Is start. Check if a character may start an identifier. Okay, check if a character may be part of an identifier. That's, is continue. Oh, I see. Is that all we have to do? Do you remember what we did earlier? For and? I think that was it. Hopefully that's it. Okay, how's it happen? It definitely works. Look at that optimization. That's beautiful. How does it happen without it? What do we got? That looks perfect. Okay. Yeah. Perfect. Woot woot. Okay, I definitely have to go soon. People are going, it's 5:30. What are you doing? It's fine. Everything's fine. I like being with you guys. Oh, yeah, baby. Okay, so we now have, while not, everything should be good to go. We're just going to start committing. Get the commit there. And or not. Oh, man, this is a lot. I'm just going to do the whole thing at once. I sincerely don't think it would help to try and split this up into commits. Because this is just a mess. And there's static asserts all over the place, so we can't like do and or, but not. We have delimiters, which is properly updated. Ooh, and or need to be delimiters in the IR parser. Okay. and C equals or. Okay, so now we have and or some bitwise stuff. Shouldn't we have, okay, there should also be the angle brackets here, no? Am I insane? Because if we do a bit shift, that should be a delimiter. Oh, this is for the IR, so we don't actually need those. I'm incorrect. We don't need any of these, which is why they're not there already. I get it. I get it now. I fixed it. Okay. We should probably test the IR parser a little bit. So we're going to have the format set to IR. And you can see that that makes it exit with code 5. So that's a good sign. I definitely broke something. Oh, man. What did I break? So the IR parser shouldn't have anything to do with it, but the IR backend probably matters. Did we implement this in the IR backend? Is there not a static assert here? There's not a static assert here. Oh, there is. It's right here. So we handle all IR instructions. So we handle them. So IR not is handled. IR not is handled. IR and is handled. And IR or is handled. So is there something wrong here? There's nothing wrong here. So what is going on? Why could we possibly be crashing? I'm sure it's very obvious. Let's check out what Visual Studio has to say about it. This is not the correct thing. Yes, I know. And or. Is that not it? What do we... We're trying to do IR-F... Okay. So we're trying to output... -FIR. Instruction value block was null putter. IR parameter. Well, it's referencing null, so that would definitely be an issue. This looks like just old handling of a parameter reference, because parameters no longer work like this, right? I don't think parameters work like this anymore. Why does it think... Why are we even handling IR parameter? That's for like argc and argv, aren't we? Trying to emit a function, which is main. And we're trying to emit a parameter reference, which should just be 1, you see here. So does it have to do with optimization? I don't think we have optimization enabled because we don't have -o here, right? No -o, which means we're trying to emit a parameter and it just does not work. It worked earlier. So what did we do? You know what I mean? What have I done? So case IR parameter. What is instruction value? Instruction value is 0. Is that proper? So when we're setting intermediate representation, what are we just looking at? What are we looking at? Parameter, IR parameter. Because this one fails. So we can't output IR right now. I'd just like to look at the IR, please. When do we have parameter? So it's got to be before the backend is lowered. which makes sense because, okay. So this can't be right. I'm going to ignore that and treat it as an error. I'm just going to open an issue on GitHub. How about that? Does that work? How do we do that? What do we need to look at? What did we just discover? IR parameter and intermediate representation when we're printing things. This is mainly just so that Suraid can see this, because I'm too scared to figure out what's going on right now. I don't have enough time. Intermediate representation, see IR param. Something's going wrong here. Reference a new issue. IR parameter causes crash with -FIR command line flags. IR parameter causes crash here with -F command line flags. Here is fine. It's kind of implied. So we're looking at this. Is this still correct? Do parameters still reference in this way? I'm not sure why, but okay. I'm just gonna say I'm not thinking too hard about it right now. But this seems like a result of changing parameter reference into parameter. That's good enough, yeah? Now we can just move on with our lives, because we can't output IR, but we can output assembly and even optimized assembly. So who cares? With constant folding, look, we just return -1. Ain't that beautiful? Okay. In this case, we can now start our engines. So this is, again, and, or, and not, all in one. And we're just going to do it all at once, because man, is it a mess. Sure. Yep, looks good to me. Stage them all. Do it. I don't think, do we want the and or example? We'll just have the and or example. It's not really good, but it's we'll just include it so that we don't have it fall by the wayside like typecasting. All right. Now we can just, what? And or not. Bitwise operations now function, are now implemented. Woot woot. How about that? And then we're just gonna push that giant thing. Put it in. Beautiful stuff. So now we have while and or not all implemented today. How about that? We should write a rule 110 now. Right? We're going to have like a state integer. Also, I can open tree sitter mode. Look at this beauty. Ooh. Okay. And what we can do is, okay, we're going to need putchar as an extern. I'm going to look up. You know what we could use as a reference implementation? Is it still here? Okay, you might see some private repos. Don't at me. Korth. It is still here. Perfect. Rule 110. Don't worry about it. Initialize column pattern. So build initial table. Store a 1 at the first byte of memory. Store a 1 at amount of columns minus 1 in memory. So this builds like a 1, 0, 0, 0, 0, 0, 0, 0, 1 to however amount of columns is, which is like mem 9900. This is a stack-based language, in case you're very confused. Okay, so triangle side length is something that we need. So we're just going to do length, size. Why not? And it's going to equal 10. Why not? Now, the column pattern, we need to set the bit in the initial table, right? The initial state. We need to set the bit of 1 and 1 in memory. So basically, state needs to be assigned to 1 to the left 10, and then state needs to be ORed with itself. Also, we have to add the new operators. We'll just do that really quick. Down here. So we have left and pipe negate. We have up here and for and negate. Not negate, but yeah, opposite bits, opposite bits. Why is this indented like this? Cool. Okay, that's fine. We already had and because it was a address of. Okay, so now we have bitwise and arithmetic operators, which means, by the way, if I do this. Oh, I broke it all. Oh, because the grammar doesn't have those in it yet, which is going to break the query. So we'll wait to add those. Otherwise, it'll break things. It's fine. So state needs to be ORed with 1 now. So this will set the, I guess we need to decide, this will set the last bit. Here, we'll do this. This will be a little simpler, I think. State is 1, and then state is ORed with 1 to the left size. Return state. That apparently, oh, that's the wrong example. And we want to do rule 110. Register name. Could not find a register with descriptor of 0. Oh. Why are you trying to? Nothing here should tell you. Find a register. Why? Why? What if we optimize it? So if we optimize it, it doesn't matter. But if we don't optimize it, something breaks. It's got to be the type checker not catching something, right? What is happening? So we have a declaration of size to 10, declaration of state to 0, a reassignment of state to 1, a left shift of a reassignment. Oh no, that's not how that works. That's a problem. Oh. Oh no. So we OR state and 1, but then we bit shift. So this is incorrect. We would like to OR this value. So we're just going to have temp state. We're just gonna make a temporary. How about that? Right? And then we're gonna say temporary is assigned to one left size, state or temp. That works. I know it's not perfect. It's definitely, we just need parentheses in the language, but we don't have them yet, so don't at me. It's good enough. It's good enough. So we should now just return state, which if we try and run it, we failed with code 1, which is a little worrying. That doesn't seem right. So we load state after storing 14 into state, which is an OR of 12 and 13, which is load state and load temp. And we store into temp. Okay, let's look at the code. Oh no. So we're doing a shift arithmetic left after a bunch of moves. Is that correct? After a bunch of moves, we do a shift arithmetic left by 1. Rax has size in it. RCX has 1. So this should shift left into RCX, which is 1. The amount in CL. So the register allocator is messing up. God. So the register allocator is assigning... What's happening here? So we load the immediate 1 into R2, RCX. We load size into Rax. And then for our shift left, we move Rax into RCX. And then move RCX into R8, because our result goes into RCX. So when we shift CL by CX, we're saying shift 1 by the value in CL, but that doesn't work because... Why are you not working? That's a little confusing, right? It's got to be the back end because we're trying to move it into R4, which is not RCX. It's R8. But our result is, for some reason, always RCX. What's going on there? What's going on there? So we're going to look at... okay, so there's does clobber. But why isn't this... So when we do a shift left, we implement a move of the right-hand side into RCX. But if the left-hand side is in RCX, that's a bit of a problem, is it not? So why is shift left in the register allocator able to do that? Needs register, yes. So that's the only place it explicitly shows up. Where are we probably dealing with this? Shift left is... Okay, so shouldn't there's like a... There's a helper. Interference. Interfere. Here. And you can see that IO shift left has RCX not able... Oh man. So any children of RCX, of one of these, should also not be... Oh man. What am I trying to say? So when we have a shift left instruction and we're trying to register allocate, right? What we do is say, okay, use this mask and say, yeah, whole bunch of complicated interference, I know. So as you can see, we call this function and then we say we can't use those registers. But so we also just can't use RCX for these shifting instructions children either. Is that true? Why can't we have to shift differently, don't we? So why can't Felix Cloudier shift left? I guess it's Sal. Why are you mad? So you have to give it CL, right? Shifts the bits in the first operand to the left or right by the number of bits specified in the second operand. Bits shifted beyond the destination operand boundary are first shifted into the CF flag, then discarded. Yes. The count operand can be an immediate value or the CL register. See, this is what's killing us. Okay, so the count problem is that it must be in CL, but its children may also be allocated CL. Which means that, okay, this is horrible. How can we do this? If any of the uses of an instruction, oh Jesus. This is hard. Iterate over all values that interfere with A and collect the physical registers that are clobbered by or pre-colored to those values. So the weird part is we're actually assigning 9, which is a use, in shift left. But these don't interfere because we could technically reuse this here. Which means we have to explicitly handle this when, oh man. So for every instruction A and B, they are said to interfere if, okay, yeah, what do we do here? But they're said to interfere with the registers. Oh man. Reg masks. So now we store all of the register masks. Okay. So this is for each putter B. If A type. Okay, I'm just going to add a fix me and say, this is horrid. This is a horrid fix that only works for x86-64. So we should probably check that. If info context format equals cogen format x86-64 gas and a type is equal to a shift instruction, any of them, this thing. Okay. Right? So if we're outputting x86-64 and it's a shift instruction, reg mask or equals itself ORed with what? We want to OR reg mask with RCX. Here's the problem. So if we are at a shift left, shift right, etc., the register mask of A should only include, yeah, so we can go through and update the old register masks. So we need to say G reg masks at A, and then this is going to be its children, right? So car ID, right? And then this is going to equal, we're going to or equal mask RCX in both children, in both sides of shift, bitwise shift binary operator. Sure. And this means that we need to somehow know what register RCX is from here, which we don't. So register RCX should be R2, which means it should be 2. Does this follow? Does this make any sense? Am I insane? See, it's still placed this here. So are we ever even getting here? Do we see here? We see here 3 times. What? How do we see here 3 times? If A type equals shift left or shift right. I mean, there's only one shift. Are you okay? So if it equals one of these types and the format is gas, say here, what? How does that make any sense? Also, I think this may be the case. Nope. Okay. That's not the case. So we're saying here 3 times somehow. Maybe this is a silly mistake. So for every instruction A, also set these but it's not setting that. Unless it is and it's just not working properly. So let's print out the IDs that we're dealing with. I guess we can just do like a femit instruction. A. Is that going to work? So you can see we have 3 different shift lefts. So we're probably just calling build adjacency graph multiple times. And every time we build it, we end up here. Which is why it's changing over time. Because you can see here it's 9 and 11, and then here it's 9 and 10, 9 and 11 and 13, etc. You would think that this would work. So if we emit A and then a value pair car, you can see that it's an immediate one and the ID is less than, which means that as we loop through these, hopefully we don't overwrite it with this equals. But what we could do is just say or equals here. Is that what's going on? See, now shift left is being stored in R5. But that doesn't seem quite right. Because this is still stored in R2. What's happening here? Edible Monad says, hey, what's going on, Edible Monad? What is up? We're just figuring out some stuffsies, trying to figure out why it's not working, basically. because we're having some register allocation issues with shift instructions in the x86-64 backend. So register none is 0, which means that RAX is going to be 1 and RCX is going to be 2, which means this should effectively work. Okay, does the shift left properly mark? It does set pair and mark, left-hand side, right-hand side. So what we're trying to do is set the reg mask of the children of a shift left when we need to. Because currently, failing with code 1. What should we fail with? Should fail with like, yeah, not 1. And the current issue is we're trying to shift left CLCX. Which doesn't really make sense to me. Why are we moving RAX into RCX? And then... Oh, so yeah. Okay, so in the Arch x86-64 backend, when we emit a shift, we first move the count into RCX, which is where it has to be. Otherwise, it's an immediate. Yeah? So we have to do this, which means that if the car assert instruction value pair car result does not equal RCX, because if it does, register allocation must not allocate RCX to result of shift. Edible Monad says, I've missed a lot of this project. We're at the code gen now? Oh yeah, we actually just implemented while loops. So now while loops properly work. That's what we did today. So if we try and do while, you can see we get this whole intermediate representation with basic blocks and everything, because yep, we have an IR now. And that outputs this code right here. And this is a little long, so what you can do is now enable optimizations, including tail call optimizations and all sorts of things. And as you can see, it inlines the while body block, so there's not another jump where there doesn't need to be. And then if we run this, look at that. You can see it runs while 10, 987, 65, 43210, because the source code is here. There it is. I've also implemented very nice syntax highlighting, in case you haven't noticed. But yeah, so this code now outputs 98765432110, all on new lines. It's definitely still a work in progress, but we are getting somewhere. And currently we're having an issue with register allocation, where we're trying to put... It's basically just something very specific to the x86-64 backend, where a shift... When you do a shift, if you want to shift by an arbitrary value, you have to put it in the CL register. And the register allocator, if you take a look at the code, yeah, see, it doesn't even do it now, because register allocation must not allocate RCX to the result of a shift. So what's happening is we're trying to move, like we're trying to shift left by CL into RCX is our issue. This can't be RCX. Does that make sense? So whatever this is, we just have to fix up. Is there a reason why we're doing this? What if we just... Okay, hold on. What if we didn't do that? Why don't we just do this? Question mark? Did it work? I don't think it worked. Why wouldn't this work? Shift arithmetic left, CL, which has 1 in it. Oh, move racks RCX. Crap. So it's, okay, yeah. This is a problem. And then to result of left-hand side of shift. To result of shift. Should check that case. There. So we can now see must not allocate to the result of the left-hand side of shift. So this shift left, which uses 9, the left-hand side is R2, which isn't allowed. So the register allocator has to somehow know this. So we were trying to do this when we build the adjacency graph, which sets the reg masks. Where else are the reg masks set? In build adjacency lists, they're set from G reg masks I index. Index, not ID. Okay, still didn't work. Edible Monad says, by the way, off topic, but how close to affiliate? Affiliate, I think we made Twitch affiliate. We made Twitch affiliate, I just didn't activate it because it requires like tax information and I don't want to pay taxes if I'm making $10 a year. There's technically like minimums in my state, but last time I did the math, I don't know. Taxes are hard. Edible Monad says, awesome, congrats. Thank you. But yeah, I have to do some tax information and deal with Amazon as a business, which is always fun. So we set the left-hand side. So can we what is this? This is a size T? Can we just print it out? What is it? Right? Equals size T. What do we get? It equals 4, which in binary is 1, 0, 0, which is 1 to the left 2, which should be -1. Look, we have to do -1 from a register here. So this is 2 minus 1. Yeah? Oh! I think it worked. Yeah, the assertion doesn't trigger anymore. Okay, I fixed it. This is not ideal. This is a horrid fix. We should probably deal with this in some generic way. Yeah, because this is... just having this here is ridiculous. So let's just name it so it's a little more clear. We're going to go size T RCX mask. That's a little... okay. We're going to do regmask underscore RCX. That's at least clear what it does. And then we can just do this. Please mask out RCX. Which means that it won't, it won't allocate it. So now you can see this is no longer R2, it's R3 because it's forced to use a different register. Which means in our code, it does actually work. Okay. Okay. Here's the problem. So if I run this again, am I gonna update? Oh, it did update. I just missed it. So that fails with code 1, which is worrying. So we're moving state, after moving RDX into state, after moving racks into RDX, after ORing RDX into racks, and racks contains temp, RDX contains state. So what happens if we return temp? Shell command succeeded with no output. What? Temp. Move 0 into temp, but then we move R8 into temp, which is size. Oh, now we have to move. Did I screw that up in the back end? I did screw that up in the back end. And then didn't fix it. Oh, that's annoying. Why did I do that? That was dumb. So the problem is that the left-hand side contains the value we'd like to shift. And then we move the left-hand side into our actual result, which means that this probably isn't a big deal. Which means that our output now returns 64. That's perfect. That's what I was looking for. So now if we do state, it should be 65. We compile. Hey, it worked. Okay, well that was a detour and a half. Let's do that. Let's add those. We should also add. Oh man, there's so much stuff I have to do. I'm gonna write this down before I forget it. Add or. How do you draw an ampersand? Oh my god. Okay. I gotta look at an ampersand. I can't my brain is breaking. Oh, this font isn't gonna help me at all. What is that? Okay, I'm just gonna draw it. That's not an ampersand. Add or and. I'm just gonna use the words. Add or and keywords. Nope, operators. To TS. Tree sitter mode. That way we can actually highlight them. We won't worry about that right now. Yep, that's fine. We had an auto include there. Did you see it? That's not good. Should probably include codegen forward for codegen. Is that not allowed? Why is that not allowed? Why are you unhappy? Oh, because it's in codegen. Guess it's fine. Okay, well that's cool. That's cool. By the way, if you don't know, we now have TreeSit explore mode and others, where you can now view the AST live, for example, in Emacs, and also have syntax highlighting based on it. So you can see that the name of a declaration statement is an identifier, which has a primitive type integer, and a number which it is being assigned to. And then if we move over to down here, you can see that this one is a different declaration. Here's an assignment with a variable and a number. So cool. And that's also how this syntax highlighting works. Ain't that cool? But we haven't added or and, which is what I was talking about that I still have to do. Well, this is good. We should commit this to Git, which is why I keep going in circles. New operators. We should definitely handle those. So just first things first, we're going to add the assert. Codegen x86-64. Ensure non-interference of left-hand side of shift and RCX. Sure. Because that will then trigger in that build, so then we can include this here. And then say fix. And this will say codegen register allocation. We'll just abbreviate RA. And we're going to say shoddy fix for shift instruction register allocation. Left-hand side register allocation. Perfect. Heyo, I have to go. That's what that text meant. It's fine. I'm gonna stay. I'm gonna stay as long as possible. For example, one thing I could do is go to treesitter and update the grammar to include new binary operators like and or negate. Negate. This is JavaScript. Thank you. Whoops. And or. Okay, then we have to add those in the queries for highlights. We already sort of have them. And or. Yeah, that's fine. This is scheme, by the way, if you don't know. Oh, and then negate was the other one, which is the little tilde. Okay. This should now work. Can I... Oh, that's interesting. Why is that doing that? Invalid node type 65. See, this is why we do it. So, why are you an invalid node type? You should be fine. I don't know why you're an invalid node type. You are an anonymous node in the grammar. I guess it's... Oh, it's not a binary. Okay, hold on. I should also like tree generate. Tree sitter generate. I should do all of this, but it's not going to work because it's open. And it says 65 invalid node type. So when we have a dereference, we're going to have to also have a not. Bitwise not, sure. Which is a thing. And then we can have a bitwise not happen. Are you gonna freak out now? There we go. Now you can see it highlights once more. And with this new grammar and highlighting, we can then move over to our editor, UNTS mode, and once we rebuild it, we should be able to do this. So we're just going to include this and then go to here and go to this git and commit this. So this is and or negation. Okay. And we'll just say grammar and or negate. And or not. Sure. It's not negate, it's not. Okay, we'll push that. And then we will close it. And then we will go here. And should be able to do those changes. Okay. So now we have editor Emacs. Yeah. Editor Emacs and or not operator highlight. Cool. And then we can go to Vim as well. Not here. un/syntax/un.vim. Operators. Oh no. It looks like we already have negation. Hopefully we have bit shifting. It looks like we already have and or. What is this? Was this or? What am I looking at? Regex. Oh my god. Okay, so we have question mark or plus or minus or star or semicolon or colon or comma. Oh man, I really have to go. I have to go so bad. I'm so late. Oh my god. This is so much more fun than what I have to go do. Less than, greater than, and, or. So this is the pipe right here. That's why I'm confused. This is the pipe that matches it. So we're good. We already have it in the Vim. It's already, well, it already will happen. So we can push this, make sure everything works. Again, it won't really work right away, but it will. We started Rule 110. We're getting there. If you're familiar with Rule 110, then you'll know that all we really need to do is loop over size and do some ands at each section. So we're going to do that next stream. I recommend staying tuned. Be sure to follow and keep up with the dates, the things. Be sure to join the Discord if you are interested in all this stuff. We have a ton of fun. In fact, today we had Eternal in the stream itself. We were in a voice call for some time and had a lot of fun. If you want to do that, just let me know. Join the Discord, be a good person, and you can be on the stream. Why not, right? You want to be here? You can. VS-printf is where it's seg faulting, not where I would have expected, actually. Oh no. VSN printf to the rescue, I guess. Lamau. I have to save this somewhere. Anyway, we implemented today while loops, and they're great. They work, and it's incredible. I did not think we would have that be a one-day feature, right? That's very impressive. So be sure to go clone the repo, check it out, make sure to play with it a little bit, and then be sure to check back in for when we are working on the Rule 110 in this language. How about that? Because I have to go right now. I really have to go. I should have gone 20 minutes ago. It's 6:20. But yeah, join the Discord down below. There's links. There's an invite link, and it should be permanent. So everything should be good there. And yeah, we now have while loops in this language. If you don't know what this little program will do, it will actually print the ASCII number of condition as long as it's less than 10, and then a new line. So if we actually go to FunCompiler, this is just a directory for the proper working directory, then we can run this command at the bottom here and run while, and we can even optimize it. And you can see this produces optimized IR as output, and that optimized IR is then converted into code. And when we run it with gcc code.s and a.exe, you can see, look at that beautiful output, 9 through 0. Isn't that cool? So now we have while loops and external functions and integers and type checking and syntax highlighting and bitwise operations and a whole lot more. Languages are, it turns out, hard to make, but this language is coming along nicely, I would say. Why is this not... Okay, so we just need to make... Oh, because an external variable isn't necessarily a function, so we'd have to make a query in the Emacs to make sure this is a function type, which is totally doable. Okay, better syntax highlighting on the way. I'll stop rambling. I think that's all I have to say for now. This is our language. We've made this. Are you proud, chat? Because I'm proud. Honestly, I'm pretty proud. I'm pretty happy with it. Did I make a GitHub issue? What was the GitHub issue I made today? We're going to look at it. Where is it? It was in the FunCompiler. We're going to do this, then we're going to go. I should have, again, already should have gone. IR parameter causes crash with FIR command line flags. Yeah, that still happens. That still happens because of this right here, and I don't want to think about it too hard. So we're going to leave that for next time. But it's not that big of a deal because the compiler works with optimizations. How about that? And now we have while loops. We have bitwise operations like in AND OR. All of these work. Negation, bitwise not, that is. And then OR and AND. So we have all of these. And with these, we're now going to implement Rule 110 next. We're actually there. A statically typed, optimized language with its own IR, its own parser, its own type checker, its own everything. Everything from scratch in C. And we're about to write Rule 110 in the language. I think that's pretty pog. I'm pretty happy with that. I'm just happy with where I'm at right now in this. And oh yeah, if you haven't seen TreeSit, be sure to test out TreeSitter because TreeSitter is awesome. If we take a look at the while example, it's going to break things, right? Yeah, because we don't have while parsed in the grammar yet. But we do have, for example, if parsed in the grammar. So what we can do is load untsmode and then TreeSit Explorer. And now you can see, if we explore here, there's a function statement, which has a name, GCD Euclid, an expression lambda. Here, there's a little small. Yeah. There's a lambda expression, which has a type function, which is, of course, the type of a lambda should always be a function, and it returns a primitive integer. It has a name identifier with a integer and then another name identifier integer, which are just parameters, as you can see. Then there's a block, which is the actual body, as you can see in the name. And then there's an if within that, which has a condition, a binary expression of variable equals variable, a equals b. Then we have another block, or this is the then block within the if. And the if then block just contains one thing, which is a variable access. We have the else block as well, which has another if, which has another binary, blah, blah, blah. But now you can see how basic tree traversal is done with our AST. And you'll notice this is missing because it's context dependent. So this is a call with a callee of GCD Euclid and two numbers as the things there, the arguments. It works, it works. I really recommend TreeSitter. It has beautiful syntax highlighting, and it's great. Anyways, I should have gone so long ago. I'm basically just talking to myself now anyway. Thank you all so much for watching. Be sure to check this out on GitHub. The VODs will be up on YouTube. There's already 40 parts out or something, so go check that out. And yeah, continue being awesome, guys. Special thank you to Sir Aid. Be sure to go check the description for his Patreon link because he needs a new chair. Not even lying. He needs a new chair. Go donate to Sir Aid. He needs a new chair. Anyways, thank you so much to Eternal Sir Aid for actually spending the time today to hang out and code with me for 5 hours, because that's a pretty rare thing, I'm sure, as you will know. Thank you all so much for watching. I've got nothing else to say except go click the buttons that tell you to go places. Check out the Discord. We have a ton of fun figuring out how Britain works. What is Britain? Is it a kingdom? Is Ireland a part of it? It's all here. The true programming questions. There's a game based on TS100 written in Emacs. You should go check that out. It's an Emacs conf. Or in the Discord. Come check the link. Or just ask about it, because we like it. Anyway, that's it. That's all I got. Go check out the things. I've been doing this for 6 hours. My brain is melted. Go check out the things. Be good. Be good to each other. Bye. Bye, everybody. I love y'all. I gotta go. And do the classic. Goodbye. Bye. Bye, everybody. I'll see you next time. And this will say welcome, I promise. Anyways, be sure to hit that follow button. Go subscribe on YouTube. Join the Discord. Hit all those buttons, please, for me. I like it. I like it when you press those buttons. I want you to. Please do it.